Good morning, everyone. Good morning, Shri Ashni Vaishnavji, Honorable Minister for Electronics and Information Technology, Sir Demis Hassabis, CEO of Google DeepMind, Shri Jitin Prasad, Honorable Minister of State for Electronics and IT, Sir, Shri S. Krishnan, Secretary MeitY, Mrs. Kavita Bhatia, COO India AI Mission, Ministry of Electronics and IT, and distinguished guests, eminent researchers, ladies and gentlemen. It's a very warm welcome to all our dignitaries and participants. We welcome you to the Research Symposium on AI and its Impact, the flagship event of the India AI Impact Summit 2026. Now we begin the opening ceremony. It is my privilege to invite Srimati Kavita Bhatia ji, Chief Operating Officer, India AI, to deliver the welcome address.
Honorable Minister, Honorable Minister of State, Secretary MeitY, Sir Demis Hassabis, Symposium Chair and Co-Chair of the Program Committee of the Research Symposium, esteemed researchers, academia leaders, innovators, partners from India and across the world, a very warm welcome to all of you. It's my privilege to open the Research Symposium on AI and its Impact, a flagship knowledge platform of the India AI Impact Summit. Over the past 1 year, as the preparation for the summit have unfolded, one conviction has guided our efforts, that meaningful conversations on AI must be anchored in research, evidence, and interdisciplinary exchange. The Research Symposium has therefore been designed not as a ceremonial gathering, but as a working platform, one that brings together the people building AI systems, studying their implications, and shaping the real-world deployment. Today, convening reflects months of institutional collaboration. We have worked closely with researchers and academia, in particular our knowledge partners, IIIT Hyderabad, to curate a program that is both globally representative and substantially rigorous. The diversity of the participation we see today across geographies and sector is a testament to the growing importance of such integrated research platform. Increasingly, the meaningful progress is emerging at the intersection of communities, computer scientists and social scientists, engineers and ethicists, public institutions and private laboratories, startups and universities. By bringing these communities into a shared space, we hope to enable conversations that are technically grounded, societal aware, and implemented oriented. Another important dimension of this platform is its emphasis on emerging research voices. Alongside globally recognized scholars, the symposium has created dedicated space for early career researchers, doctoral scholars, and student innovators. Because institution building in AI will require not only nurturing ideas, but also building ecosystem of mentorship and visibility. From an institutional standpoint, convenings such as this play a catalyst role in surfacing frontier research questions, identifying partnership opportunities, and aligning innovators' pathways with real-world needs. It's our hope that the conversation initiated here will extend well beyond today's session, evolving into a sustained institutional partnership. As we begin the proceeding, I would like to express my sincere appreciation to all partner institutions, knowledge collaborators, speakers, program curators who have contributed in shaping the symposium. Your participation is what transformed this platform for an event into a living research network. As we inaugurate this symposium, we do at the moment when India's AI journey is accelerating. The insights and partnership that emerge from these discussions will play an important role. It's now my honor to invite the dignitaries to give their special address. Thank you.
Thank you, ma'am. Now, to set the context for the sessions ahead, I invite Professor P.J. Narayanan, Professor IIT Hyderabad and Chair of the Symposium, to address the gathering.
distinguished members who are sitting on the dais, Sri Ashwini Vaishnav-ji, Jitin Prasad, Demis, Hassabis, Chairman, Secretary, Mr. Krishnan. And I would like to also recognize some special people sitting in the audience. Professor Raj Reddy is here, Turing Award winner, and so this is an academic gathering. So when the summit was planned, the MeitY or the organizers also wanted to have a academic symposium or research symposium in parallel with it, and I was contacted to see if I could coordinate it. So I agreed to be the co-chair, and I get to stand here and represent a co-chair. But there were so many people who helped me with this. They are very critical decisions. One of them is Kalika Bali sitting there. I mean, she is part of the India AI team. She did a lot more firefighting than I did. And of course, Abhishek Singh, the additional secretary, who guided us in multiple ways. See, we think we are researchers, we think only researchers' way, but this is not only a research event, this entire summit. So how to put these things together, Abhishek has been very instrumental in doing that. So AI has suddenly become so big. Even 2 years ago, if somebody had suggested people working in AI or machine learning will win Nobel Prizes, everybody would have laughed. And we got 2 in the same year. And even the Turing Awards, you know, the first initial pioneers, 4 or 5 pioneers of computer science got Turing Awards, I mean, of AI, got Turing Awards, say, back in 60s and 70s. After that, about 20 years, there was a gap in even Turing Awards being given to AI work, and Raj Reddy and Professor Feigenbaum were awarded Turing Award in '94 for their work in AI. So even the computer science community was not recognizing it as much. Of course, now it has changed. You have many more Turing Awards in the last year, the recent years. So when we started planning this, we didn't know where to go. There are so many things happening in AI. How do we bring everything together? And we tried to get as much of it together as possible. And I'm very, very pleased to have 4 stellar individuals doing keynotes. Demis Hassabis himself, who uses AI or ML techniques to advance science mostly, where the humanity benefits unquestionably. And we will have, after that, Dame Wendy Hall. She's been working in web sciences and looking at the progress of how web and this big connected world enable this whole thing in some way. AI wouldn't have been there without this data and this adoption. Then we have Yoshua Bengio, who has been on the safety side, on cautioning everybody of the potential dangers of AI. And I think they are very real. We need to listen to him. And we also have Yann, LeCun, who probably takes the other side, who is very, very gung-ho about AI's potential. So I think we need to listen to all the voices. I'm very glad that all 4 kind of voices are heard here in terms of plenaries. Then we have what we call research dialogues. One is on the, you know, how AI can be a catalyst in discovery of science and engineering progress, and how we can increase the impact of that. The other one is on AI itself. What next? What is what next frontier for AI research? Where is AI going? Then we have 2 international, we call it international panels, or Global South, with Global South concentration. One of them is on Global South itself. What is the impact on Global South? The other one is on AI safety, safe and trusted AI. These are the 2 parallel sessions that will happen. And then we have invited several top publishers from authors who published influential work in AI from across the world. People have come from all over the world to present. They will be in posters during lunchtime and right after this session. So we have a fantastic program ahead, and this should spur dialogue and discussion in topics related to AI. And I was very pleased to see the large crowds for the last 2 days, and I'm sure every one of us is pleased to see a full hall like this here. Everybody is eager to know about AI. Everybody is eager to know how it will affect them. So we'll have a fantastic session today. I'm thankful for this opportunity to curate this session and bring it in front of you. Enjoy this session. Thank you very much.
Thank you, sir. May I now invite our Honorable Minister for Electronics and IT, Shri Ashni Vaishnavji, to deliver the special address.
Very good morning, friends. This is a research symposium, and I'm not at all qualified to be standing here. I wouldn't take too much of your time. Just want to thank you for coming out in such large numbers at 8:30 in the morning. Yesterday we had about 250,000 people, mostly young. The average age was, I think, below 30, attending the AI Expo and the entire exhibition area. It was phenomenal response. When I interacted with the young minds, I was so surprised at the optimism that most of the young people expressed towards this opportunity which is coming for them. Initially I was a bit apprehensive, but looking at their optimism, I am feeling really hopeful for a totally new future for our country and for the world. We in India are very focused on AI in the edge, AI for use cases, AI for solving real world problems, AI for improving the productivity in the enterprises, AI for population scale problems like healthcare, like agriculture, like climate change. These are the things that we are focused here in India. And this AI Summit brings that opportunity. And as we discuss various technical matters, I will request the topmost brains which are present here to please do bring some solid, concrete suggestions on how to make AI safe. This is a great tool. It should be used for the benefit of humans. It shouldn't be something which really distorts that balance. I really look forward to the suggestions and ideas which will come out of this symposium. Thank you very much for coming to this symposium in such large numbers, and I wish you all the best. Thank you.
Thank you, sir. With this, we formally conclude the opening ceremony of the Research Symposium on AI and its impact. Thank you, sir, and thank you, everyone. Thank you.
Mic यहीं रहने देना माइक सेंटर Hello, everyone. My name is Mausam. I'm a professor of computer science at IIT Delhi and also one of the co-organizers of the Research Symposium. I welcome everyone to the symposium, and in fact, we are all looking forward to it, and the rain gods have also showered their blessings today, so we know that this is going to be a great symposium. It is my distinct honor to welcome Sir Demis Hassabis, the Fellow of Royal Society, a Nobel laureate, and the CEO and co-founder of Google DeepMind for the keynote address. And with him on the stage would be the moderator, our own Professor B. Ravindran, who is himself a IIII Fellow and Head, Department of Data Science and Artificial Intelligence at IIT Madras. So I request you to please join us on stage and deliver your keynote address. Thank you.
Thank you, Ministers and Government of India and our fellow professors for inviting me here to give this keynote. It's a huge honor to be here. Very excited to see the incredible turnout from the country and the interest in AI, of course, but also from many of my colleagues from around the world in both industry and academia who've convened here. So I'm looking forward to a really amazing couple of days of discussions about the way forward for AI. When we started DeepMind in 2010, seems it's only 16 years ago now, but it's almost a lifetime in terms of AI. Almost nobody was working on AI back then, few people in academia, but almost nobody in industry. So it's been amazing to see the progress we've made in just over a decade. But at this point, I think we're at a threshold moment where AGI, artificial general intelligence, is on the horizon, maybe in the next 5 to 8 years. So this summit comes at a critical moment as we start seeing more autonomous agentic AI systems, much more capable. I think we're seeing the beginnings of what those kinds of systems can do. And of course, the opportunities are incredible. For my personal passion is using AI for science and to advance science and medicine with systems like AlphaFold. I think we can revolutionize drug discovery and human health, and also areas like material science and climate change with the help of AI. But of course, it also comes with many risks too. AI is a dual-purpose technology. It's going to be one of the most, if not the most transformative technology in human history. And that's just on the horizon now. And the thing about this technology is it's going to affect the whole world, everybody in the world. It's going to cross borders. So it's very important that we have summits like this, international summits, to bring the international community together to discuss how to make sure the opportunities benefit the whole world, and also how do we mitigate the risks. And I think in order to mitigate some of the risks, it's going to need international cooperation. And the first step for that is to have international dialogue. And I think that's what these summits, starting in the UK, and then in Paris, and then in Korea, and now here in India, are for, and have been really helpful in convening many of the important heads of state and many of the important leaders in this technology together to discuss what is on the horizon. So with that, thank you for having me, and I look forward to the discussions here in the next couple of days. Thank you.
Good morning, everyone. And so, Demis, you started talking about how amazed you are at the progress that AI has made. And you started DeepMind in 2010 with a vision to solve intelligence. So, are we there yet?
No, I don't think we're there yet. I have quite a high bar for, if we talk about solve intelligence, meaning building artificial general intelligence, then my measure for that is having a system that can exhibit all the cognitive capabilities humans can, including in creativity, long-term planning, things like that. And today's systems are very impressive, but as we know, they still have many flaws and things they can't do, including consistency across different tasks that you would want from a general system.
So you did mention AGI, right? So what do you think really that we can do to take where we are right now and move it towards artificial general intelligence, as you define it?
Well, when I look at the current systems and what's missing from them being a kind of general intelligence, I would say things like continual learning, so learning after they've been trained and put out into the world. The today's systems, we train them, we do various different types of training on them, and then they're kind of frozen and then put out into the world. But what you'd like is for those systems to continually learn online from experience, to learn from the context they're in, maybe personalized to the situation that, and the task that you have for them. And today's systems don't do that. Also, they have difficulty in things like doing long-term coherent plans. They can plan over the short term, but over the longer term, like the way that we can plan over years, they don't really have that capability at the moment. But I think probably one of the biggest issues is what I would call consistency. So today's systems, they're kind of like jagged intelligences. They're very good at certain things, but they're very, very poor at other things, including sometimes the same thing. So, for example, today's systems can get gold medals in the International Maths Olympiad, really hard problems, but sometimes can still make mistakes on elementary maths if you pose the question in a certain way. A true general intelligence system shouldn't have that kind of jaggedness.
But aren't humans jagged as well?
No, not in that way. I don't think so. So I think if you're an expert in maths, and many of you in the room are, or in physics or something like that, you're not going to sort of make a mistake on a strictly easier, more trivial problem, right? You would have some way to work through that problem. Similarly, let's take the example of games, which is very close to my heart, and we've used in the early days of DeepMind to train our AI systems. Today's general foundation models are very poor at, for example, playing chess, below kind of weak amateur level. And that is not what you would expect from an AGI system. There are other tests too that I would have is true creativity. So AI is very useful as a scientific tool, an assistant, or for solving specialized areas like AlphaFold does with protein structures. But really what separates great scientists from good scientists is their creativity and their sort of, maybe you could call it taste for what's the right question, what's the right hypothesis. And it's much harder to come up with the right question and the right hypothesis than it is to solve a conjecture. And, I would call that the highest level of sort of creativity. And so far, today's systems, they don't have that capability. One way we maybe would test that is you could imagine training a foundation model with a knowledge cutoff of something like 1911, and then see if it could come up with general relativity like Einstein did in 1915. But that would be a good test, I think, for AGI. And I think today's systems clearly would not be capable of doing that. But I think this will be solved in time.
Okay, that's great. So you talked about scientific tool, it's a tool for scientific discovery, right? And so we see a lot of headlines about AI, making great breakthroughs in science sometimes. But how would this become the norm, right? I mean, so do you see AI becoming the scientific tool for discovery soon?
Yeah, the reason I spent my whole life and career working on AI is I saw it quite early on as if you could build these kind of general models that were good at pattern recognition, they would be incredibly useful scientific tools. Maybe the ultimate tool for science. That's what I was thinking. A lot of science is about finding insights and structure in vast amounts of data. That's perfect for AI. And so I think we're going to enter in the next probably 10 years, a new golden era for scientific discovery, almost a new renaissance, using these tools, incredible tools like AlphaFold, but I hope that will be the first of many that can massively speed up our research and accelerate scientific discovery across almost any subject area. So I think that's going to be the next period is using these systems as tools. And then after that, we'll see as they become more autonomous, can they be kind of like co-scientists with you, like a PhD student, something like that? I think we're still quite away from that, but maybe in 10 plus years that will be possible.
So just to reassure a good fraction of the audience, you still see a role for humans in that future, right?
Yes, I think the next phase is going to be incredible, I think, for human experts and scientists, the amount of work they'll be able to do. And I'm actually really excited about cross-disciplinary science, which is quite hard because you have to understand, more than one subject area, maybe 2, 3, 4 subject areas, and then find some interesting connections between that. I actually think that's where a lot of the really valuable advances are going to happen in the next few years, these combinations of subject areas. And I think having a tool like AI will really help scientists learn about and be able to understand and process all of that information from multiple different domains.
So in some sense, science is a well-defined field, if you will. I mean, you can recognize success and so on and so forth. So what do you think would be the role of AI in more abstract domains like policy and other kinds of public decision making?
I think I think things like science, but especially if you take coding and maths, are more amenable to the current systems we have today. Mostly because, especially coding and mathematics, but also things like games like chess, they are verifiable. So the answer that the AI system outputs can be checked for correctness. And so it's very useful for when you're training these systems. You can have databases of questions and check to see if 100% if it's right or not right. I think, of course, when you get into the arts and the humanities, things like decision-making, policy, I'm not sure what you necessarily had in mind, but they're much more subjective. They're hard to run the same experiment twice. So it's difficult to get data about what is a good decision in those cases. So I think there'll be, those areas will be a lot harder for AI to sort of model.
So as a neuroscientist, so what do you think we have learned about human intelligence itself with all these advances in AI that we're seeing?
Well, I think when you're in the early days of this, I guess, modern AI phase, which maybe you could say is the last 20 years, with the advent of things like deep learning from Jeff Hinton. A lot when we started at DeepMind too, we took a lot of inspiration from the brain. High-level systems inspiration, not the direct mechanics of the brain, but things like episodic memory, what does the hippocampus do, which is what I studied, how, obviously, neural networks, reinforcement learning, your area, which we know the brain, dopamine system in the brain implements. So we kind of took inspiration from the brain, which is the only example of a general intelligence that we know of, maybe in the universe, as a starting point. And so we sort of knew that it was possible in the limit, right? And I think that's why neural networks and reinforcement learning have been so successful, because I think learning is the key to these modern AI systems working, not being programmed with the answer like expert systems were in the 90s, like Deep Blue, but actually allowing the systems to learn directly from data. And I think now, what I view looking back at neuroscience is, how efficient the brain is, sample efficient. It doesn't need, to ingest the whole of the internet to understand things. So it's a different. What we've built now today, it uses some of the same principles, but it's been manifest in a very different type of system than probably the way the brain works.
Okay, thank you. So. One of the things that people always talk about is the safety risk, security risk from AI, and so on and so forth, right? And so what does GDMs stand on this, and how do you approach making sure that AI is safe?
Well, we've been when we started DeepMind, we actually, were planning for success. Our mission statement was solve intelligence, step 1, and then step 2, use it to solve everything else, which at the time, sounded like science fiction, but I think now is becoming clearer how that might be possible, and applying AI to almost every subject area. But we planned for success, so even though we were just starting out and the field was mostly just building up ahead of steam, we understood also the implications of that if that did turn out to be the case, and we thought about it as a 20-year mission, and I think we're basically on track for that, around 2030. Then it would come with these attendant risks as well, as the enormous benefits to science and medicine and all these things that I think we need as a society to help with our other challenges, many other challenges that we have around the world. But also, as these systems become more powerful, I think there's at least 2 risks that we've always worried about. One is bad actors, human actors, but individuals, but it could be also nation states, using these systems and repurposing them for harmful ends. Because they're dual purpose. But then also, as we get closer to AGI, and I think we're entering maybe a kind of agentic era, should we call it, where systems are more autonomous, I think we'll see a lot of that happening this year and next year. Then we have to make sure as well that the guardrails are in place, that these systems do what we expect them to do and don't veer off into areas that we hadn't planned for. And that could also be problematic. So I think those are the 2 challenges. There's a very sort of societal one, which I think also is going to require international dialogue and maybe ideally a minimum set of standards that is agreed internationally. And then the second one is more of a technical risk of how can we make sure these systems are robust and reliable.
So, I mean, setting aside all existential risk questions, so what do you think is the top 2 risks that we should address with AI systems today?
Well, I mean, I think I mentioned the 2 classes of problems. I think we need to worry about things like bio and cyber risk very soon. I think that the current systems are getting pretty good at cyber, and I think we need to make sure cyber defenses are more powerful than the attack vectors. And it's something that we work on quite a lot at Google and at DeepMind, is sort of using AI for cybersecurity to make sure that, of course, it's a very useful tool for cyber defense too, but you need to make sure that the defenses are stronger than the offenses. So, I think those are kind of near-term risks, but there are many that we need to think about and do a lot more research on, and some of them are to do with agreeing a sort of set of standards, which, I know many people, including yourself, are trying to work on.
Great, thank you. So again, talking about international collaborations, right? So you said that we really have to work on that. So an audience like this, or a gathering like this, right, where we are trying to involve the Global South very much in the dialogue, right? So what do you think would be the impact of such gatherings on the overall direction of AI? Do you think, and are these going to make a big change going forward?
I think so, and I think that's why it's important we convene this summit around the world, because it's going to affect, this technology is going to affect everyone. It's a digital technology, so it can't really be contained by borders. There's things like open source, which is generally very good, but also one has to think about if you found a vulnerability or some issue with an open source piece of software, how do you recall it? How do you patch it? There's no recall. So we need to think about that. These are new issues with something like AI, where it's hard ahead of time to fully understand if there are any vulnerabilities. And I think for the Global South and countries like India, I think there's huge opportunity for the youth of today. You all have access to pretty much the most cutting-edge tools in the world. Right? I don't think that's ever sort of happened before, maybe only 3 to 6 months after they've been invented in the frontier labs. And I think, and I can say as someone working on the coalface of this, we barely have time to understand what are the amazing capabilities that could be supported by these models, in products and applied research. So I think there's so much potential there to be explored. And I think we'll see a lot of that, and hopefully many of you in the audience too, entrepreneurs here, you can do incredible things, maybe 10x of what you could do before, because these tools are so capable and they're available almost instantly around the world.
So I have a question that's more specific because you are right now in India, right? So the Indian population, like one of the things that a lot of people have been remarking is that the crowd at this summit is extraordinarily young, right? So this youthful energy, right? So you think what would be the role that India can play effectively in the future, given the resource constraints of India, but also the availability of this talent pool?
Well, look, I've been incredibly impressed already about the energy that's here, and we heard from the minister that, the youth of today, and in India especially, I think when you see the polls on this, are very positive about AI, which I think is great. And what I'd recommend to the students of today is to really lean into becoming incredibly proficient with these new AI tools. And I think over the next 10 years, that will almost kind of make them superpowered in terms of what they're able to do, whether that's business or science. And it's a little bit like the dawn of the computer age, or maybe mobile or internet that we went through. If those, the generation that grows up native with that technology will end up doing sort of incredible things that we can only dream of right now. And I think that's going to happen with AI, and I think India and the youth here can be at the vanguard of that.
Since this is a research symposium, can I ask you to get a little technical on the next answer?
Sure.
Great. So, so we saw the evolution of how AlphaFold, right, started off by building on top of existing work from Baker Lab, and then moving on to evolving all on its own, right? So what do you think is the next stage technically in the evolution of these kinds of co-scientist models?
Yeah, so well, with AlphaFold, we actually built a completely new system, but it required the PDB, the protein database. So it needed the 150,000 structures that humanity had painstakingly found over the last 50 years through experimental work, right? And that turned out to be only just enough data to actually, solve the problem and build a system like AlphaFold. The interesting thing is, and the debate we have at DeepMind and other places, is what's the difference between the general system, which you can think of like the brain, and the tools that it uses? So for us as humans, there's no debate about what's our minds and what are our tools, because obviously it's physically separated. But if both things are digital, and in some cases both things are AI, the tool and the orchestrating system, then what do you put in the main system and what do you leave as a specialized tool? Now, in my opinion, I think you'll end up with, in our case, with foundation models like Gemini, will use things like AlphaFold as a tool. So if Gemini wanted to or needed to fold a protein, understand the structure of a protein, I think it would be better for it to call AlphaFold as a tool than put all of that protein information into the main system. And I think if you want to talk about it technically, I think the choice comes down to, if you put that data into the main system, does it help with other tasks? Does it transfer to other tasks? Or does it actually degrade the performance on those other tasks? So it's actually an empirical question. So that's why, for example, coding and maths, we put that in the general foundation models, because it turns out if you get good at coding or maths, you're actually better at planning and reasoning in general. So it's a useful skill, but it also generalizes. And but something like the folding proteins probably is a very specialized skill that wouldn't necessarily transfer to other domains. So I would be of the opinion that we should leave that as a specialized tool.
Oh, that's interesting. Because a lot of learnings from robot path planning was used for robot path planning was used to try to solve protein folding. So you think knowing how to protein fold will not transfer back to other domains?
It might do, but we would, I think in fact, we do these experiments all the time on smaller scale models where we ablate different data sets and we try and mix in certain data sets and see if they help or if they regress some benchmarks. Like, it would be no use if you put all the protein data in and then it got worse at language, for example. which is probably currently what would happen. So maybe over time with an AGI system, you just have everything in the one system. But I think for the foreseeable, maybe future, I think it'll be more efficient to still have separate tools. Also, those tools, by the way, might be hybrid systems in that they might not be just learning systems. They might also have built-in structures like AlphaFold did actually about physics and chemistry and chemical bonds that you could learn, but would be more efficient to just tell the system or program that indirectly.
So now that I mentioned the word robots, so I'd like to ask you, what's next in physical AI?
Well, look, I think I'm getting increasingly excited by robotics. I probably wasn't so interested in that 10 years ago because I felt that the issue was the algorithms, not the physical construction of the bodies. I thought the algorithms were the thing that was behind. Now, I think algorithmically, and actually we're very excited about Gemini robotics because we built our foundation model to be really good multimodally, so it could understand vision, image, the world around us. So it has a very good understanding of the physical world. And that's exactly what you'd want for robotics, is a kind of general system that understands the physical context the robot's in. So I think we're probably in the next 2-3 years, we're going to see some very interesting new breakout moments for robotics. I think there's still quite a bit more research to be done. I don't think we're there yet, like some robotics companies are claiming. And I think we'll have humanoid robots and also non-humanoid. I think both will be useful. But I think in the next couple of years, there'll be some really breakthrough moments. So I think it's a very exciting space to watch and a good area to get into right now.
So a little tricky question. So a lot of people are, that is a lot of fear mongering around AI. We know that most of it is unnecessary. But if you start getting humanoids that are running off foundation models, do you think the fear factor would go up?
Potentially. It depends how we design those humanoids, but I think some risks go up too, right? Again, depends on what you deploy them for, and I think increasingly, especially if the humanoids are pretty capable and they're heavy, there are dangers and risks with that. So I think we need to have those guardrails that we were discussing earlier in place by the time there's a lot of robots roaming around.
Great, thank you. So we talked enough about risks, so let's talk a little bit more about the positivity of things. So I know a lot of the benefits of all this cutting-edge AI right now still seems to accrue to the countries that have more resources, right? That have GPUs, that can run their models there, and so on and so forth. So what do you think would take for AI to reach the global south, benefit a much more larger fraction of the population? So what kind of initiatives that we should be looking at? Well,
look, I think we kind of touched on it earlier, but the leading foundation models, maybe there's 3 or 4 of them, and perhaps 5 or 6 if we include the Chinese models too, then they're pretty much available very cost effectively for a few months behind. Also open source. We work on our own open source models, Gemma, which we'll be releasing a new version of soon, which are very powerful for edge devices. So I think that's very interesting areas, really efficient models for computing on the edge, whether that's your phone or a single laptop, or eventually robotics. I think there's huge opportunities there for optimizing what those kinds of models do and the types of products or applications you can build on top of that. So I think there's a lot of potential there for those types of work to happen.
The entire the auditorium went dark for a bit. So, no, that is not signaling any kind of ominous thing, so don't worry about that. It's amazing. So I was actually there when you did the first game-playing demo at one of the NeurIPS side events. Yes. And that was in this tiny room. Yes. Even then, it was packed. Yeah. And this large auditorium is packed. So what's the largest size hall you think you can pack if you're talking nowadays? Madison Square Garden?
I don't know. This is a pretty big one, and I hear it's streaming to many, many people online. So But yes, I remember at that NeurIPS event very well. It was a hall maybe a third of this size, but I think it was standing room only, and it was packed outside the door. And that was really the first success that we had with these deep reinforcement learning systems that we sort of pioneered that could play Atari games, very simple games now, but just directly from the pixels, not giving any other information, just maximize the score, here are the pixels on the screen. And it was the first demonstration, I would say, maybe of the modern AI era, of an agentic system doing something kind of challenging and interesting. That, in this case, a task that was designed for humans to find interesting and enjoyable and somewhat challenging. And I think it was kind of a watershed moment, of course for us, but also maybe for the industry. It was back in 2013, I think. And that actually this thesis of learning systems, learning algorithms, this idea of generality, that you don't special case the information or give it privileged prior information to the system, that maybe was the way traditional AI had been done, or good old-fashioned AI had been done until then, expert systems, that actually that could scale to something interesting. In this case, an Atari screen with 20,000 pixels on the screen, trivially small by today's standards, but very, very large action space and data space for the types of systems we had then.
Yeah, now they've become like the hello world of reinforcement learning now. So
Yes. And then, of course, that encouraged us to then go on with AlphaGo, which was, I think, really the big watershed moment that made the field and the industry set up a notice in 2016, and I think started a lot of the commercial interest in these technologies, that we could scale this kind of deep reinforcement learning and learning systems to actually, beat the world champion and the legendary, Lee Sedol in our South Korea match.
So, and one thing I really have to say that, you wrote up everything about the Atari game player and also later AlphaGo that allowed the rest of the reinforcement learning community to catch up. So thank you for that. Yes. And of course, my first success was I was actually in the room and not outside clamoring to get into the room to watch the demo. But so that's great. So again, let's forget AI for a minute. Let me ask about reinforcement learning. So that Rich Sutton has been talking a lot about how David and Rich wrote this amazing article on how reinforcement learning is going to drive AI forward. So what's your take on that?
Well, yeah, obviously we've had many debates over the years, and I think it's, for me, if I was to say, and maybe we can take this question more generally, like, what do I think about today's foundation models and reinforcement learning? Of course, reinforcement learning is an integral part of the post-training of these models. And I think the inference time compute, the thinking part of the models, could actually benefit a lot more from the ideas we pioneered in AlphaGo, the Monte Carlo tree search and other things. So in actually many respects, we need to combine the ideas we had with AlphaGo with today's foundation models. Of course, it's harder because you don't have a perfect model of the world. Right, you need a better world model. In games, it's trivial, right? The transition matrix. So I think that's an issue. But if you're talking about, if I was to guess today, I think the foundation models are going to, like Gemini, are going to be a critical part of the ultimate AGI solution. And then I think we'll have lots of interesting reinforcement learning on top. I think eventually, one day, maybe 20 years from now, we'll have a kind of more like an AlphaZero type system where, reinforcement learning can learn everything from scratch, right? But I think actually that's not going to be the fastest way to AGI. I think it makes sense to use the foundation models and all the information that's already out there and learn that as almost like a model of how the world works, and then do your reinforcement learning and planning on top of that. I think that will be more efficient in the first case.
Is it still going to be the cherry on top?
No, I think it's going to be, you have to ask Yann about his cherry comments. I'm sure he can talk at length on that. But I've never really agreed with that. I think it's just a fundamental, I don't really, I think obviously if you measured it in terms of bits, then one can say, well, how much bits of information are you getting from the reinforcement learning? But in my view, and presumably your view, is that not all bits are equal in terms of information. Of course, if you get a bit about, did you win the game or not win the game, that's much more important than some random pixel on the screen, right? So to equate the informational value of those bits in just, a trivial way is clearly incorrect in my opinion. But I do think that the foundation models are going to be, the question is are they going to be all that's needed or just a critical part of what's needed? I think there's no question they're going to be at least a critical component of the first AGI systems.
So we're almost out of time, so I just want to ask you, what's your message for the attendees of this summit?
Well, look, I think my message is one of, I would say, cautious optimism. So I think we're on the cusp of an absolutely incredible transformation that's going to bring incredible benefits in science and medicine specifically is what I'm passionate about, and I can see revolutionizing the way we deal with human health. I think there's many amazing companies and tools and products to build on top of these systems, and I think everyone in the world can build on these AI systems to do that. But then also I would just add a note of caution, which is I think we will solve these technical issues given enough time and enough brain power on it. I believe in human ingenuity, and if the best minds work towards that, I think we'll solve the technical risks. But we also need to do this internationally, so the societal challenges of that may actually end up being the harder problem than the technical ones.
Thank you. So Demis Hassabis, everyone.
Thank you.
Thank you, Sir Demis Hassabis and Ravi, for such a stimulating discussion covering the breadth of AI and reinforcement learning in such a short time, talking about possibilities and challenges. I have been asked to tell you that the number of people waiting outside to get into the room outnumbers the number of people inside the room. So you are requested to please stay seated if possible for the next session before we have a break. That would help with the law and order situation of the auditorium and outside. So I kindly request the attendees to stay on for the second keynote of the Research Symposium, which is going to be delivered by Professor Dame Wendy Hall, yet another fellow of the Royal Society and a professor of computer science at University of Southampton. And joining her as a moderator is going to be Dr. Anant Deshpande, founder and chairman of Persistent Systems. Over to you, Wendy and Anant. Yeah, that side might be easier. So we are joined on stage by Professor Dame Wendy Hall from University of Southampton and Dr. Anand Deshpande for Persistent Systems. Please give them a huge round of applause.
Okay, Anand, I don't have a clicker. I have slides. Oh, hang on. Wait. Okay. Yeah. Are you introduce me? Are you going to introduce me? Sure. Okay, right, wait in a minute. Oh.
Let me start.
So good morning, all of you. It's a pleasure to welcome and an honor to introduce a true pioneer in the digital age, Dame Wendy Hall. Long before artificial intelligence became the global headline, and even before web reshaped our daily lives, she was working on hypermedia and linked information systems, foundational ideas that anticipated today's interconnected and intelligent worlds. Few people have influenced both the birth of the web era and the global AI conversation. She has done both. She serves as the professor of computer science at the University of Southampton. She's a fellow of the Royal Society and the Royal Academy of Engineering, reflecting her rare ability to combine deep scholarship with real-world engineering impact. Her contribution to the global computing community is equally profound. She is a fellow and former president of the Association of Computing Machinery, the world's largest professional society in computing. Through ACM, she has championed international collaboration, open science, and the responsibility of digital technologies, shaping the profession far beyond her own research. In recognition of her extraordinary contributions to science, technology, and public service, she was appointed Dame Commander of the Order of the British Empire. At the moment when the world is asking how to build AI that is powerful, trustworthy, and globally accountable, Dame Wendy's voice carries both authority and wisdom. Please join me in welcoming Dame Wendy Hall. It's an honor to have you here.
Hello, everybody. Are they all coming in? Huh? Okay, fine. Are they going to come in? Let them in. We should let them in, right? If they want to come in, there's seats. You want me to just keep going? All right, well, I'll start because it's so distracting. There's a huge crowd of people there. The crowd following Demis, you know, the we are not worthy crowd went that way. This always happens to me when I speak with Tim Berners-Lee as well. But I just want to say, first of all, before I forget, a big thank you to the Indian government. Abhishek Singh is somewhere here, PJ, Anand, all the people for inviting me to be a keynote here. It is a huge honor. And I want to say a few things that are a bit different this morning. So I have used some slides to try and explain where I'm coming from. So I'm talking about unintended consequences, because that's what we've all got to worry about. Whenever you invent a new technology, you have to think about what might get wrong, what might go wrong. And you will have noticed with Demis, who I will preface these remarks by saying I have the hugest respect for Demis Hassabis. I think he's one of the greatest people in the AI field. and one of the few that actually does address the challenges. But you heard him say on safety, we've got to do this, but no talk about how. We've got to build the guardrails. We've got to keep things safe. But meanwhile, we're carrying on inventing more advanced technology. So that's what I want to try and get us thinking about today. And as Anand said, I was around building hypermedia systems before the World Wide Web. Met Tim Berners-Lee at one of the first World Wide Web conferences. And you know, I remember him putting up the first website. I don't know how many people, there's a lot of young people here, I don't know how many people remember the first website going up. There was one. And it wasn't a very exciting place to be at the time. This is what happened. This is a graph that one of my PhD students produced in 2013, just as the web was beginning to get completely explosive. I'm going to talk about the ChatGPT moment later. I would argue the ChatGPT moment for the web was the invention of the smartphone. See, the iPhone was released in 2008, and that's when you could actually start using social media. The internet was there, but you could start using social media on the move. And I tell lots of stories about this graph. I haven't got time today, but it is amazing to watch. There was a bubble, remember the bubble? And Facebook started in 2004, and little did we know, because we weren't anticipating people would do bad things with this system. We thought it would be used for the good. Beyond this point, the social media starts to take off, and the oligopolies grow. We hadn't foreseen that either. The fact that Tim was always talking about lots of different people innovating on the web, but of course they coalesced into a small number of big companies, oligopolies, with the Googles and the then Twitters, the eBays, the Amazons. And look at what's happened. With the internet and those companies, this is what's driving the current AI revolution. The internet's given us the access to the data. The companies have that data, and they have the deep pockets to invest in the new systems. And so we're moving into a world, we've got the issues with social media, which we still haven't tackled, that the unintended consequences of social media that's doing so much social harm. I didn't think about that in advance. We thought it would be for the good. And then also the rise of the big tech companies that are dominating today's AI field. So this was in 2006 with Tim Berners-Lee, Nigel Szabo, Danny Weitz, and others. And by the way, that's Rod Brooks there when he was head of MIT. He's the man who invented the robots that clean your carpets, iRobot. So this is 2006. We launched this concept of web science to try and understand what had driven the growth of the web, what the social consequences were, and what they might be in the future. It's very hard to build scenarios when you're talking about people as well as things, because you can't predict what people are going to do. So we drove this development of web science. Tim talked about, in his book, Weaving the Web, the concept of a social machine, the concept of technology and people coming together to create artifacts that couldn't have existed otherwise. Google's an example of that. Twitter's an example of that. And all the other, so we talked about web science being the theory and practice of social machines. And we were thinking about, could we monitor, could we anticipate the social consequences of the development of this technology? Does that ring any bells about what we're trying to do today with AI? And so I'm now going to leap forward, because I've only got a short minute, 10 minutes or so, 5 minutes left probably. And we're going to talk in a minute. But jumping forward to 2017, the Royal Society produced a seminal report. A seminal report on machine learning. As we all saw that this. Demis said they founded DeepMind in 2010. It was when the machine learning revolution was coming, and he said there weren't many in academia. There are loads of AI professors in academia, But anyway, that's beside the point. And then I was asked by the then Prime Minister of the UK, Theresa May, in 2017, to write a review of how AI could impact the growth of the economy. She was looking positive, and job creation note we were asked to talk about. That was the beginning of my world of AI policy. Jump again another 5 years forward. I don't have time to go into the details of everything, to what I call the ChatGPT moment. 30th of November 2022, when OpenAI released ChatGPT, and suddenly everybody in the world who had access to the internet through the web, this all happens through the web, could talk to an AI, right? And thereby hangs the tale. We anthropomorphize it. A lot of people think, you know, we've had all the issues of falling in love with their chatbots and all the issues around people, the vast majority of the world not understanding what this technology is and what it is they're dealing with. And then we had an era of a year or so of, you know, existential threats. So there's OpenAI saying, here's this amazing technology, does fantastic things. Oh, by the way, it could wipe the human race out in 2 years' time, right? How are people supposed to deal with that? Our Prime Minister at the time, Rishi Sunak, who is here, I don't think he's here, but he's here at the conference this year, he got very interested in this and launched the first global summit on AI, which was, as Demis said, in London. They were still talking about existential threats. That was his advisor was talking about them. But also he introduced the AI, he created the AI Safety Institute, which is an important part of this story. At the same time, exactly the same time, the UN launched its high-level advisory board on AI. It was a huge, huge privilege to be on that. This, I believe, is a way forward. I think the only game in town for the global dialogue that we called for in our report, Governing AI for Humanity, and Demis called for on the stage this morning. And hopefully there's going to be some discussion of this amongst the world leaders tomorrow. We have to have global dialogue. We have to have discussions on standards and what values and standards we set for the industry globally that will be managed in the nation states. This, I believe, is so important, and they announced their new scientific panel that Rav is on, other people in the room might be. It's moving forward, and I think it's possibly the only game in town. I just said that there. And the other thing, so where are we today? The United Nations have just launched their panel, new scientific panel. Hopefully they'll launch the global dialogue at the AI for Good conference in Geneva in July. And also the Yoshua, of course, who's talking later, produced the latest version of the safety report. Sorry. That was published last week, 222 pages. I hope you've read it all. I haven't yet, but something new I want to talk about, which I think is really the way forward, building on those, is in the UK, is something I'm really interested in. Remember back to what we were doing with the World Wide Web as it grew. Our National Physical Laboratory, NPL, with the support of the UK government, has just launched a new centre for AI measurement. Oh, that's bad in the slide, isn't it? Sorry, measurement. Centre for AI measurement. This could lead to the sort of Met Office for AI, right? Met Office, Metrology Office for weather forecasting. We're talking about AI metrology here. And I think this is a way to help us define what we mean by the science of AI. Can we forecast? Can we simulate? Can we get the data we need to do that globally? Right? This is very important that we can share data in order to build up the whole concept of AI metrology. You won't have time to read all this slide, but it's basically about building industry for AI assurance. This is the future. This is one of the very particular ways we can do safety, is how do we assure products? How do we assure people who are selling products? How do we, what license do people need to use AI? Do we bring in laws that says if it's AI, it has to say it's AI? All these sorts of things. And how do we measure the impact? I mean, you know, the Australians, good for them, are trying out an experiment for stopping social media for the under 16s. How do we measure the consequences of that? Right? These are the sorts of things we have to be able to develop. And this is where my life is going to go over the next few years. I also want to shout out for the UK AI Security Institute. Some of them are here, I think. Because they do the most amazing things in terms of looking for the bad actors. Seeing a lot of it is very deeply security-based, because they're seeing where... I'm way over time, aren't I, Anna? Sorry. Seeing, you know, what are the results of the... are any of the AIs going rogue, basically? And the network of those, which is the countries that have AI safety or security institutes, is being called the International Network for Advanced AI Measurement, Evaluation and Science. And I think this is so, so, so important. I believe this is where we need to go. I'm sorry, Demis, but I think AGI is a meaningless term, or at best, an ill-defined aspiration. We need to work out what we're actually talking about here. It reminds me of The Emperor's New Clothes, if you know that one. I'm told it is also an Indian folklore. What are we really trying to achieve? Yeah. And I would just make, there's a difference between machine intelligence and our human intelligence. And we need to think about, what are we trying to do with this? This came from a friend of mine, Pete Rye. I should have put his name on there, sorry. Talking about, I think of the machine as more like the Dr. Spock in Star Trek. And of course, we are messy, unstable, we have emotion. You know, people talk about AGI, well, the machines will have emotion, they'll have consciousness. We don't understand what that means for ourselves, let alone trying to build it into machines. And, you know, that moment in 2001, where the machine says, I'm sorry, Dave, I can't do this. Right, that's what we want to be able to avoid. I just pay homage to what India's done with data governance. I've been here, I travel here a lot, and my friends here know. I've followed the story of the Aadhaar, what Nandan and the iSpirit team did with that. And now this is one of the things that India can really lead on. We can't have good AI governance without data governance. And I'm on the UN working group on that. It's very difficult. Cross-border data flows, really hard stuff. Whose data is it? How do you value it? All those sorts of questions. This is the end, basically. You know, it's more about physical... We're not just measuring physical artifacts, we're measuring and assuring social machines. These AIs are a huge force for good, but we've got to stop the bad things happening if we can, mitigate against them. We've got to reset our moral compasses here. It's not okay to do bad things with AI systems. We've got to let people to understand that, right? And it's not just governments and the technical companies, it's tech companies, it's civil society as well. We've got to all be more responsible. That's a big project at Southampton, by the way, our AI UK. I'm just going to finish with this slide, because I'm also into scenario building. How can we actually model the different ways that the AI world can develop, and AI meets people can develop? There's lots of forking paths. We've got to decide which way we want to go. And we have to decide what type of world we're trying to build here, which pathway are we taking. And I love, by the way, the slogan we see as we drive in India, AI means all-inclusive. Good for India.
So thank you, Wendy. I think you teed off many different topics, and you were one of the original persons in the multimedia and then hypermedia and the web. Over the years, you have seen the web evolve. You started out by sharing that was very optimistic, and then social media and various other things have happened. You have advocated for, you've seen this happen in the web. How do you see the same kinds of things happening in the AI world? And what would be, are you looking forward? Are you positive about where we are? Are you worried? What would be your learnings from the web to the AI world?
Well, I tried to explain this here. We didn't get it right with the web. I mean, Tim is building solid social link data to try and fix the web in terms of what we didn't see was what was going to happen to our data. Effectively, we give all our data to the, not just the governments, I'm not talking about governments here, if it's the retail companies, it's the big tech companies, we sign it over, you know, you tick the terms and conditions, no one reads them, the data's with them. And so they can therefore do what they like with it. And of course we get Ravi was talking earlier about reinforcement learning. Google was a huge reinforcement learning machine and we were part of that. We were part of that social machine as we gave them our data. We gave Google our data, but in return we got access, we got a search engine that worked. And we kept, we reinforced it every time we used it. I like Gemini. I'm using that because I feel comfortable that the values that Google have are good, and of course Demis is part of that. But we know there are safety issues, we know there are security issues, but we can't really define them in terms of the social consequences. We can talk about cybersecurity, and of course we have our intelligence services fighting very hard to make sure the bad actors, humans or states, aren't using this technology to attack us or to, ruin our lives in that respect. But the social consequences we didn't predict with the web. We didn't predict what was going to happen with social media, we need to find ways to try and think about what the social consequences will be of the introduction of this technology. We talk about, I think we might come on to this. There's a lot of rhetoric about job losses, and the social consequence of, unemployment caused by it. But actually, there are huge social consequences in terms of the use of this technology that we just can't predict easily because we don't know exactly what people are going to do with it. And that's the science I'm trying to, as we started to develop it with web science, I'm trying to talk about that in terms of AI, because it's about, as I say, we're building social machines, and we need to think about how we evaluate and test and forecast what might happen. Things that could go right and things that could go wrong. And it's really difficult. It isn't like forecasting the weather. That's hard enough. Okay. But because you're trying to forecast what people will do, and you can't predict how people are going to react, particularly as a society.
So what do we do about it?
We have to start, I think, developing ways of thinking about it. So building simulations using the data that we have. AI might help us in doing that. And data, it's all about getting as much data as we can and encouraging a generation of data analysts that are looking at the data from this perspective. Monitoring what happens. You saw that graph I put it right at the beginning, which is a very simplistic way of looking back at how the web evolved. Can you then extrapolate and predict what might happen in the future?
So you've
not easy, by the way. I'm not pretending any of this is easy.
I think we'll leave it to the young people here to explore new ways to see how we can learn from the past so that we can build a better future. But you've been a big champion of inclusivity and diversity and various other things. I know your term during the ACM, you did a lot of work on ACMW, women, and you also alluded to the fact, and we've seen posters about AI equal to all-inclusive in this context. Do you think AI will help inclusivity, are we going to get, will AI make it possible for it to be more inclusive, meaning other people who are potentially deprived will have access to AI so they can do a lot more? Is that a positive thing, or is the bias going to make it very difficult, or what do you think about it?
Well, you've asked me about 3 questions in there.
Yes, I want you to. I don't want to interrupt your answer.
Well, let me try and unpack it a bit. We're here in the Global South because it's so important, and I'm really glad the summit has rolled to India this year, although the scale of it, like India, is a bit scary. 150, was it? The number varies, but hundreds of thousands of people.
250,000 yesterday.
And a lot of young people, which is great, yeah? And I think that making sure that AI is used, I mean, the UN report was called, we talked a lot about the Global South when we were having our discussions, governing AI for humanity, right? The whole world, so that everyone can have access to the good things that AI will give us. And this is good old-fashioned AI as well as the new generative AI. And I'm a great believer, the Chinese are way ahead of us on this, but robotics is the next big thing. Embedded AI in robotics will come, and I'm sure there's a future in India for that, particularly because in farming and all sorts of areas, that's going to be really big. In terms of inclusive, I think there is the issue, of course, of how we make sure that the elderly, like myself, are included. This is a world, the young people here will be, this is your world, you'll be building it, right? In every sense of the word building, because you'll be part of the development of it if you go into the tech world or AI product world, and you'll be using it in whatever career you do. So it is your world. We need to leave it safe for you. That's what I'm really passionate about. And we need to build the frameworks and well, we talk about guardrails, the safety rails, the infrastructure, I suppose is what I'm looking for, that the young people here today can build on in the future to know that what they're doing is going to be as safe as we can make it. And you know, what are the things that put people in jail for doing bad things using AI? That's create laws around that. Inclusivity. My big worry, when I get asked about what keeps me awake at night about AI, yes, there is a existential threat down the line if we get it wrong and we build AI systems. I don't use the term AGI. We build AI systems that are more intelligent than us. And they get out of control and make decisions on their own that are not good for us. Yeah, that's dangerous. My biggest worry is the lack of women in AI. Right? We are 50% of the population. I've fought my entire career to get women into tech, and I feel I've singularly failed to do that. There are more, and it's lovely to see the young people here. You don't see the female leaders. I'm one of the few women on this plenary stage. There are some others, but tomorrow, I don't think, at the World Leaders' Day, I don't think we'll see many women on the stage at all. And my friend, you asked me yesterday, why is it? Because we get women coming into the industry,
Yes, in India at least, when we are recruiting fresh graduates, we get about 40% women coming into the workforce.
Yeah.
But as you go higher up in the organizations, the number of women and leadership positions comes to be lower.
Well, it doesn't just happen in the tech industry, but it's particularly bad in the tech industry. Women when you move up in the industry or in academia, you get fed up with being dismissed, being disregarded, being patronized, being told your ideas aren't good enough. And I mean, the number of times, and girls, it happens to me still, you put forward an idea and they say, oh, that's useless. And then a week later, you hear it put forward by a man and they go, oh, that's a really good idea. Didn't you hear me say it? And my friend, Dame Steve Shirley, she had a lovely saying which said, why do women leaders have flat heads? It's the constant patting on the head. Says, don't worry, dear, it'll all be all right. And that's the problem. And it isn't a problem women should be solving, it's a problem the men have to solve as well. You have to stop patronising us, you have to listen to us, and you have to encourage us. I had the most fantastic mentors, both men and women. And without them, I wouldn't be here. There are several times in my career where I wanted to give up because people have been so rude to me or dismissed what I was saying. And it was my mentors who kept me going. And some of the men I remember, but particularly Steve Shirley, Martin Rees, the Royal Society, who told me I could do it. And I have.
You are an inspiration to not just the women of this world, but also to the men. So thank you for keep doing what you do. I've known you for many years now. I just want to shift this, since we are here in India and Global South. Clearly from the point of view here, we see that AI is completely dominated by 2 countries, 10 companies. What do you think is the future? How do we change that, or is that important at all? And what happens to the rest of the world, maybe, in case somebody decides to shut the taps off somewhere?
So what?
To shut the systems down to certain countries or not allow other countries to do it because of...
Well, I think that, again, it's good that we're here this year because, yeah, the first summit in the Global South, it's so important that the countries... I mean, India's got the scale to do it. I mean, to be honest with you, India could do whatever it wanted to do if it puts its mind to it, you know? Because of the scale. I mean, you want to live in a little country like the UK, you know. Once our navies ruled the world, but we're actually a small island off the coast of Europe with only a few million people. So for us to, for us to scale up with the big companies is really hard to do in the UK. I am very excited about what's happening in the UK. Our government's put a lot of money into AI, and I talked about the new the Safety Institute and the Measurement Institute. We tend to lead in the soft power area, and I think the whole the AI assurance industry, this is going to be a major industry. I mean, you think about how you buy insurance all the time for your health, your car, your house. We're going to do that for AI, right? There will be all sorts of insurance products that we will build, we will buy. And people, I mean, it's the same when a company buys some AI, they've got to know it's going to work. Who do you blame if it goes wrong? Yeah,
You're right.
So there's a whole new industries that are going to grow. And also the other thing is amazing. When I look at, I know much more about India than I know about Africa, but I do know in both countries I have seen the development of technology where it leapfrogs what's happening in the West or the East, because you take a new idea and then you say what India did with smartphones, amazing, what you've done with the Aadhaar and I find it hard to pay for things here because I can't get onto your system, but it all looks so easy. And then what's happened in Africa, in Kenya and Uganda and places where they're using the technology, it's quite amazing what will happen. And this is people being creative and innovative in terms of new technologies. And so every government in the world needs an AI strategy that is fit for purpose for their country. And it's not one size fits all. And I think that, we're talking about sovereign AIs. Do countries need the LLMs in their own language and with their own data? And or small, the SLMs. I think this is a world that's emerging, very much so. It's very exciting. And I think there's just everything to play for. I'm very positive. Although I talk about the negatives, I'm very positive about this future.
Thank you, Wendy. And I want to now move it to the younger people who are in this room. You talked a little bit about jobs and what happens to students. What should students be learning now, and What do you think is the future of work and employment in the AI world as you see it?
Well, okay, this is what we need to start measuring. We need to start gathering the data around the world of what happens as the AI introduces. I mean, it's all very well saying we're going to measure AI, but we can't do that without data and evidence and things to measure. So I'm calling for this to happen around the world. We need governments and companies to share data about what's happening as much as they can. Clearly, there's sensitive data you can't share, but and to enable researchers in industry or in academia to analyze that data and see what the trends are, see how things, because it's all hypothetical. I mean, there's a lot in the UK at the moment in the press about, oh, the jobs are going, the frontline jobs are going. There's also, the jobs are going also because there's not enough money in the economy. I won't go political, sorry. I won't criticize the current government, just in case they're in the audience. But because I don't agree with all their policies. But, you know, there's all sorts of economic reasons why jobs are going for young people in the UK, not just AI. I do think it's ironic that programmers are one of the first to be hit, people who write code, because, and we've seen the applications to our computer science program go down because the rhetoric is that companies won't need programmers, entry-level programmers, because the AI can do it. But the AI doesn't, at the moment, decide itself what it's going to do. Someone's got to tell it, and someone's got to check that it's correct. Yeah. And so, we need experts in the field of computing and software engineering. So the way they're trained might be different, but we're going to need those experts in the future. And I like to think about teams. I like to think about augmented intelligence, so that AI augments our intelligence, and talk about teams of humans and machines working together to do things better.
So do you have a specific message for the young people here who are studying various subjects? Should they be investing more in computer science or do other things?
Well, I don't
what
think
should they
put
do?
it like that. Everyone needs to understand, just like, oh, when I started out, we all had to learn what, I was a pure mathematician. I hated computing. Hated it. Now look at me. I think in the abstract, that's what I've always loved, but I had to go, I did my PhD in pure mathematics, and then there were no jobs, right, for pure mathematicians. There really are. And the computing was clearly the next big thing. The micros were coming out. I wrote my first AI code on a BBC B micro. It was a program to an intelligent tutoring system in 1982 is when I wrote that in micro prologue. And I'd learned that because I went to do a master's degree in computer science part-time at City University to learn about the computing, this poor mathematician, pure mathematician, learning about computing, because I knew if I was going to get into this world, I had to understand it. So I think, and my passion is about explaining AI to people who don't know what an eigenvector is. Now, all the mathematicians and physicists will know what an eigenvector is, but that's a small part. Most of the population are not going to ever know what an eigenvector is or want to know. And so what we're doing at Southampton is two things. One is we developed an online master's for non-scientists, right? An online master's in AI for non-scientists. And I'm passionate, I always have been passionate about the interdisciplinary work. I do loads of work with social scientists, historians, geographers, musicians. So I'm passionate about the interdisciplinary and about how we, as Demis was talking about, we go across the disciplinary boundaries. But they need to know about, everyone needs to have some understanding about artificial intelligence. And this is the most, for me, this is the most important thing. So young people, if you're not, learn about it. However, whatever's the easiest way for you to do it is to, and buy my new book, which is coming out in May or June, which is called AI Explained, and that's for non-scientists too.
Thank you very much, Wendy.
Sorry.
I think we are, our time is up. So I'd like to really thank you for being here and for sharing your perspectives. Yes, we will all buy your book. Hopefully you will come back again for the book tour, and we would love to host you again when you can share more details about your books. Thank you very much, and thank you all.
Thank you, Professor Wendy Hall and Dr. Anand Deshpande, for a very important conversation highlighting the need to do more as we build the future with AI. Thank you very much. We are now at the place of a well-deserved break. I think we would all want to stretch our legs, but before we do that, I want to make a couple of important announcements. We will reconvene for our panel at 10:55. I request you to be seated by 10:45. We are going to have two parallel panels. One is a research dialogue on AI for science in this room, and one is an international panel on challenges of Global South in level 1, room number 7. Secondly, people who are going to present posters can be beside their display boards starting 10:55. So we'll meet again at 10:55. Thank you very much. Sorry, an update. Apparently, there's a lot of crowd on your posters already. So if you are a poster presenter and you would want to catch more people, please go to your posters now and start talking about your research.
Sunaina Sitaram, Principal Researcher at Microsoft Research India. And it's great to see everyone turned up in such large numbers here. So we're going to start this session actually with a video from Professor Fei-Fei Li, who couldn't join us sadly, but she wanted to convey her thoughts. So we'll be playing that video and then starting the next session.
Distinguished leaders, colleagues, and friends, I'm deeply honored to address you at this historical gathering. I want to express my sincere gratitude to Prime Minister Modi for his vision and leadership in convening this summit, and to Additional Secretary Sinch for this kind invitation to be part of this moment. Though I cannot be with you in person, I want to share my excitement for what India is building and what this moment means for our shared future. Historians will look back at this period and call it the first true era of artificial intelligence, a time with civilizational consequences. Every sector, every industry, every nation will be touched by this technology. And this is precisely why gatherings like this one matter so much. Today's AI has achieved something remarkable. Large language models can write, reason, and synthesize information in ways that seemed impossible just a few years ago. Yet, for all their capabilities, these systems are just the first steps towards building intelligent machines. I firmly believe that the next frontier of AI lies in what I call spatial intelligence, the capability that connects perception, reasoning, and action in 3D and 4D worlds, enabling machines not just to see and talk, but to do. 540 million years ago, the emergence of vision triggered what scientists call Cambrian explosion, a sudden flourishing of life and complexity. Vision gave rise to understanding. Understanding enabled prediction. Prediction made purposeful action possible. And from this chain, intelligence emerged. We stand at a similar threshold. Spatial intelligence will transform how AI perceives and engages with three-dimensional spaces, with applications spanning scientific discovery, education, healthcare, robotics, and more. Imagine AI systems that can assist a surgeon in the operating room, help a farmer monitoring crop health, or support an elderly person at home with dignity and care. This is not speculation. This is the research we're pursuing right now. But let me be clear, the purpose of AI is not AI itself. The core mission of artificial intelligence must be to expand human capability, not to replace it. AI should amplify our creativity, deepen our connections, and enhance our sense of purpose. It should superpower our students and teachers to transform lifelong education, assist our clinicians and patients, and help workers stay out of harm's way while increasing productivity. Always, it must respect human autonomy and dignity. This is what we mean by human-centered AI. It is not a slogan, it's a discipline, one that demands we bring together technologists, social scientists, policymakers, and communities from all walks of life. If AI is going to change the world, and it will, then everyone from everywhere must have a role in shaping that change. I believe this summit embodies that spirit, and I'm optimistic about the future, not because the road ahead is simple, but because gatherings like this are bringing together committed leaders and brilliant minds to build something meaningful together. Thank you for the privilege of addressing you.
We are very grateful to Professor Fei-Fei Li for her kind and encouraging words. And now we start with the next session at this hall, which is a research dialogue, the first research dialogue of the day. And this will be moderated by Dr. Shivkumar Kalyanaraman, who is the CEO of ANRF, And the speakers for this will be Dr. Archana Sharma, Professor Alison Noble, Professor Neil Lawrence, Dr. Bonnie Craft, Professor Priya Donti, and Dr. Pushmeet Kohli. So I welcome everybody on stage, and over to you, Shiv.
Good morning. It says time's up already. Maybe it's for the last one. Good morning, everyone. How are you feeling today? All good? Okay. So it's my privilege to host this panel for you. We have the who's who of folks doing things in AI for science and engineering. One of the exciting things, and many leaders have told us that one of the biggest contributions that AI will do for the society is transform how science is done and transform the acceleration of the impact of science. So I look forward to a wonderful dialogue here. We have about 85 minutes, and in terms of the format, we'll keep it super simple and conversational, if that's okay. I will request each of our panelists in order here to give an opening statement and specifically reflect on one is what they're doing and what they see in terms of the acceleration to impact. This conference is about impact as a theme, and this particular panel is AI as a catalyst. So a catalyst accelerates, what can AI do to accelerate discovery, and both fundamental discoveries as well as accelerate the conversion of science and the translation of science towards impact. And also where, and since we have a lot of young audience, I will request the panelists to also reflect on, what does it mean for the younger generation here, as well as what they can do to contribute. And since we are in the country of India, what can India do to contribute as well? And what is the opportunity and potential? There is a lot of discussion about risks, and I would like to bias this conversation a lot more on opportunities, and of course, please feel free to balance that with risk. And then, what can we all do to being a positive force and science as a positive force for transformation? Okay, these are the few thoughts I have, but without any further ado, I thought I'll start off by saying, how can AI help us win a Nobel Prize? But, but I'll keep it simpler than that. Without further ado, Bonnie.
Can everyone hear me okay? It sounds like it can. I'm Bonnie Craft. It's an honor to be here and a pleasure to be among such esteemed colleagues, and thank you so much for inviting me to be a part of this. So I lead a team that focuses on AI for science at Microsoft Research. We focus on two main things, molecules and materials. So specifically, how can AI enable the discovery of new novel molecules and materials? And the motivation for that is pretty simple. The limits to discovery really doesn't come down to imagination. It comes down to the speed at which and the depth at which and scale to which we could explore. So our hypothesis is that we can use AI as a fast surrogate for some of the very expensive, slow steps within the scientific process. So oftentimes we have to compute the properties of molecules and materials. That takes extensive amount of compute, time, experience, domain knowledge, and experiment is even more expensive. So what ends up happening is the scientists are limited to a smaller space to which they could actually explore. So if we can use AI, we can open up opportunities to find novel molecules and materials that can help to solve some of the world's greatest challenges today. Things like new medicines for diseases that we haven't been able to treat yet, solutions to the energy and climate crisis, new materials for sustainability, and many, many more. So I'm very excited to be here, especially be a part of this event in India. You asked about how India can take part. I do think very few places in the world have as much scale and talent as India. This is a nation of doers, and so I think there's an opportunity here for India to be a part of this, for the young people, for the massive amount of talent in STEM, science, technology, engineering, math, computer science, to get involved and be part of the scientific loop. So ultimately, the way that we accelerate scientific discovery is by bringing AI to help us find the new opportunities to explore more expansive space of discovery, and have India be a part of that as well. Thank you.
Thank you, Bonnie. Go ahead.
Okay, I'm Alison Noble, and I think I can build a little bit on what you were saying. I work in healthcare AI, and that's a very diverse topic, so I can talk about that for probably the whole day and beyond. And some of it, as we've heard, and you've just mentioned, the advances in AI are really helping in the discovery side. But there are some other areas. I work much closer at the interface working with clinicians. And there are some early papers coming out that are really trying to get people to think of doing medicine in different ways. And by that I mean taking large sets of data that are taken of patients. Some of that will be imaging, which is my background. Some of it's then following those patients. But then it's using thousands and thousands of examples of that to be able to maybe discover new ways that we can manage conditions. And why this is so important is a lot of medicine has been driven by what you're able to measure at the time. In imaging, it's what you see in an image. And with AI now, you can discover the hidden patterns in multimodal data that might suggest totally new ways of managing patients. And this is still the future, though, because even if you've got a discovery, that translation into practice takes a lot of time and effort. And this is why when we talk about some of the excitement of AI, discovering a new algorithm, that's only the beginning. That's the beginning of the journey of getting that model into practice. And in medicine, that's a very complex process. So some of my research is actually thinking more about that, is having developed a model. I work with ultrasound, so we've been working for many years on how you can make ultrasound an easier technology to use. You need to make it easier because humans can't recognize the patterns in ultrasound. So what we've been working on is both how you recognize patterns but with AI that go beyond what humans can see. For example, estimating the gestational age of a fetus from a scan, you traditionally fit a circle or you fit a line, having captured an image. But actually, if you want to date a pregnancy, you can do it as well, if not better, at certain points in pregnancy, if you pose it as a pattern recognition problems, because the acoustic patterns will recognize elements of fetal development that humans can't actually see by eye. So there are all these opportunities, but this then gets into the debate of you now have tools where humans work with AI. And the early papers in healthcare were very much trying to show that you could automate processes and show that AI was as good as a radiologist, and radiologists were really scared about this, that they would lose their jobs. But we've moved on from that now, because what you realize is you can automate certain tasks, but a lot of the time you need humans working with AI. And then you get into all the socio-technical issues of how do you understand where a human will make a better decision with AI or not? Evidence out there at the moment, very mixed, that for certain tasks, AI helps. In other tasks, it doesn't help. And this to me is really important, that we have a lot more research in this area to really understand this area. It's often called human AI collaboration. At that point, I'll stop. Thank you.
Thank you, Alison. Pushmeet, please.
Hi. So I'm Pushmeet. I lead the Science and Strategic Initiatives Unit at Google DeepMind. And the mission of the organization of Google DeepMind is to build AI responsibly to benefit humanity. And when we think about that last part of the mission statement, which is benefit humanity, what does that actually entail? When we talk about AI is not just a monolithic sort of concept. If you think about what is even intelligence, there are different forms of intelligence. There is common intelligence that allows us to solve tasks like image understanding. There is expert level intelligence, where some humans have become experts in solving incredibly hard challenges, being able to solve and find proofs of immense challenging maths problems, or being able to diagnose a disease by learning about medicine, or by thinking about sort of how should a legal contract be specified. So that's expert level intelligence. And then there is another form of intelligence which goes beyond human competencies, where there is no human today which can solve that particular task. An example of it is the protein folding problem, where you are given a sequence of a protein and you are asked, can you tell me the structure? No single human, just by reflecting on that sequence of amino acids which constitute a protein, can tell you what is the 3D shape. And that's superhuman level intelligence. So when we think about the impact that AI is going to have, we have to think about all these different competencies. The first competency of common intelligence, it will make intelligence much cheaper, much more available, and much faster. On the expert level intelligence, it will democratize expertise. So look at a country like India, where it has challenges in terms of providing healthcare, high quality healthcare, to the 1.4 billion people in the country. Not everyone has access to the high quality medical sort of healthcare needs that are available to sort of a privileged few. So can we make sure that every single person on the planet has access to that deep intelligence? So that's the promise of AI at the expert level. My own work is mostly focused on the superhuman sort of part. And this is where I think the greatest promise of AI lies. If we think about ourselves as a species, as humans, we have come a long way in our understanding of nature and reality. But if you think about the last few years and reflect on what has happened, think about climate change, think about the COVID pandemic, that really shows us how little we know of nature. Once the virus sort of evolved or sort of came and generated these sequences, and the whole world had to stop. That's essentially the limit of human intelligence. We have so much more to learn, which is why we need to have AI to solve these grand challenges of understanding what proteins look like, how cells work, how organisms work, right? That's the promise of AI for biology. In material science, as Bonnie was mentioning, that if you think about human civilization, we teach history in school in terms of how humans were using materials. We went from the Stone Age to the Iron Age to the Bronze Age, and depending on who you ask, we are living through the Silicon Age or the Plastic Age. But it tells you how important materials are to humanity. Like each material gives us a superpower, which completely transforms civilization's abilities to do certain things. So can you imagine what will be the new magical materials of the future? And how will we invent them? And that's where we need this superhuman intelligence to really think about these amazing materials like room temperature superconductors, which can sort of open up new advances in how we transform energy can come up with high sort of magnetic field for fusion reactors, give us abundant sources of energy. That is the promise of AI. So yes, there is a sort of, when we talk about AI, we think about all the economic impact that will happen, and there will be many changes, but there's a lot of positive things to look up to. This will all need to happen with a sense of responsibility. And like with regards to India, I think, and not just India, but across the world, I think one of the very important elements is that we really need to make sure that people understand the strengths of this technology, but more importantly, they also understand the weaknesses of this technology. Because if you are not able to understand the weaknesses of the technology, you will basically have a Formula 1 car, but you will not know how to drive it and you will crash. So access and understanding, I think, are the key elements that are needed not only for India, but for the entire world, and especially for the global south. We really need to make sure that people have access, they understand how the technology is shaping up, what are its weaknesses, and how can they use it responsibly. So I'll stop.
Thank you, Pushmeet. Acha? Yeah, please go ahead.
Hello. So namaste, everyone. I see that there are many, many young people here around the age of 30, 35, and they must be wondering, what are these people talking about AI? You know, it's us, you know, who know about it. And I've seen some posts like that on social media. It's all right. So when I was your age, I was fortunate to be landing in the laboratory where the first website was released. And that was www.cern.ch. How many of you have heard about the Higgs boson? Oh, great, wonderful. Now, how many of you know that it took 30 years to build the machine? The R&D for the accelerator that you mentioned, you know, superconducting accelerators, that took 10 years to build it, and then another 2-3 years to commission and run it. The algorithms that were needed to look for the Higgs boson, for which the probability was 1 in a billion collisions. We needed data 2,000 trillion collisions, proton collisions, right? So the algorithm making and the searching for anomalies in the data has been the forte of scientists working together. So the message here really for all of us is collaboration. And all the guardrailing will come from collaboration. Understanding the troubles that are coming in front of us, we have actually gone through the cycles, as you just mentioned also. So the 30 years in which I have seen from paper to the large experiments which cost us more than $1 billion each, and then the operations that also cost same amount per year. We need to be responsible. We need how responsibly we'll be able to take this forward. And AI is another challenge that is in front of us now. In the past, it was about looking at how to deploy the web. And the web itself was the precursor, I would say, to a lot of domain-related advances that you see in every possible domain of which we've already heard. We've heard healthcare, materials. COVID came as a bolt from the blue, and you know, everybody stopped to think a bit on how to take this forward responsibly. And we can't just take technology and science and research and then put it back in the drawer once we finish the problem. You know, we have to continue. And we could pick up the challenge of COVID because there were tools, and because there was science of understanding, and because there was funding that was made available in good time by the governments all over the world, so that we could all be prepared. But I would still underline that the bottom line was collaboration. And why do I say that? Because I am one of those 10,000 scientists who was involved in the discovery of the Higgs boson. And so 1 upon 10,000 of the Science Breakthrough Prize of 2024 is also, I can say, one of my accolades. But next generation will not be 10,000. It will be, you know, several factors, several orders of magnitude, which means the whole world is going to work together. And particularly for the Global South, think about it that every classroom or every university or institution and our premier institutions in the country for that matter, who are already doing cutting-edge work, when we started working for the LHC, we did not know the solution. We did not know whether we'll get there. We did not know whether we will be able to solve the technical problems, really technical problems, because 27 kilometers of the Large Hadron Collider, the protons cross the border from Switzerland to France 40 million times a second. So cross-border understanding is very important. Not only in the protons who go without passports, but also within the governments, and also, of course, how to deploy the understanding and how to deploy the information, and of course, the beams match with sub-micron precision. So I think that here is an opportunity for us to look at our societal issues that we have in our country and in the world, in fact, for that matter, if we look at the larger picture, the climate change, environment, pollution in our country, we have some thoughts on how to solve them. And I think we have the tools with all the precursors of AI, if we look at what we have done in the past, that we can deploy for solving these issues. And I would love to see all those institutions involved in the solving of these kinds of issues. Thank you.
Thank you, Ursula. Neil, over to you.
Well, that's such great contributions so far already. So it's also showing sort of how vast the topic it is. So when we think about science, Bonnie sort of emphasized the importance of discovery. Alison's talked about the importance of the human-machine collaboration. Pushmit's talked about the superhuman capabilities. And of course, Akana's talked about how we all have to work together and collaborate to create science. And it reminds me of something that I think artificial intelligence, or the notion of it, which I think the word is already problematic. I agree with Wendy that the notion of AGI is deeply problematic because intelligence is very personal, it's very human. And I think when we think of India, and actually Eastern cultures in general, my sense is you have a much more sophisticated understanding of intelligence because the religions in the East tend to accept different forms of deity that express different aspects of humanity in a way that religions in the West don't. So I think some of the hang-ups we have in the West you don't have here, and I think that's really exciting. But then what does it do? I think, to me, the AI itself gives us a place to stand and reflect on ourselves, reflect on who we are and our institutions. So when we think about doing that in science, I think we can see some enormous opportunities for impact in India and for the audience. And I want to sort of step back to people who've talked about the philosophy of science, like Thomas Kuhn, The Structure of Scientific Revolutions, and Popper, Conjectures and Refutations. Because science isn't just about discovery, it's about understanding and what it means for us to understand, but not just us as individuals, us as institutions. And you can see in a number of ways we're failing. We're failing when not everyone understands the Higgs boson and why it's important to spend $1 billion on such experiments. And I think one of the ways we're failing can be seen right at the heart of what Thomas Kuhn tells us. He tells us that the paradigm of science, he's writing in the 1960s, is stored in textbooks. And he talks about normal science as solving puzzles within that paradigm. And then he talks about paradigm-shifting science, so big discoveries like Einstein that change the way we think about the world around us. But there's a fundamental problem here. Nowadays, the paradigm of science is not stored in textbooks. It's stored in machines. And some of those machines are storing simulations and complex ideas that we don't have individual access to. Now, I got into this field sort of 25 years ago because I was an academic who wanted to apply machine learning, and it seemed to be science was a very sensible place because science is all about academia. Now, what I see as the opportunity here is increasingly people have become isolated from the science. And I think particularly with large language models as tools, there's an enormous opportunity to allow people to get back in contact with that and to re-access science in the same way that a student 100 years ago would be accessing science through textbooks, that you can access all that science stored up in the machine through these large language models. And I hope that that's going to be a revolution in science where we see again, going back to, I think, some of the hopes at independence for India, the foundation of the IIT, the foundation of the science institutes, that India was going to be a partner in those scientific discoveries, as it has been, but not enough of it happening here. Too much of it through diaspora, too much of it not accessible because the technology for science has become removed from the place where the creative people are. And I really hope we can see that change.
Thank you, Neil. Priya, your opening comments.
Right. Yeah, so thank you so much. So my name is Priya Donti. I am an assistant professor at MIT, as well as a co-founder and chair of a nonprofit called Climate Change AI. And my angle on this topic of AI for science and engineering is more from the engineering side and specifically thinking about the power grid. So the power grid is something that I think many sort of take for granted, right? We switch on a light, and unless there's a planned or unplanned outage, hopefully the light will come on. And yet behind that, it's a very complicated system. It's a system where the amount of power that is being produced and put into the power grid has to exactly equal the amount that is being consumed on the power grid at every single moment in time. And this is incredibly complex because, first of all, we have a lot of variation in how much demand is on the grid at any given time. And as we aim to work towards kind of decarbonizing power grids or moving to more distributed forms of power, we also have to deal with the fact that the amount of supply we have, solar and wind, for example, varies based on the weather. So how do we manage this kind of increasingly complex system? We've historically done this using kind of optimization, electrical engineering, controls, paradigms where we actually write down explicitly the sets of equations that we want to solve over on the system and solve them. But the challenge is that this paradigm is not sufficiently scalable. It's much too slow to solve the problems we actually need to solve to coordinate the power grid. And so this is where AI can potentially play a role in terms of both helping us reduce the uncertainty of quantities like demand and renewable energy by helping us to forecast these quantities more effectively. Then given those forecasts, to help us to actually control the different devices on the power grid, our power generators, our batteries, our inverters, in ways that are more scalable. So I think earlier this concept of surrogate modeling came up also in one of the other panelists' remarks. So how do we actually use AI to learn fast approximations to some of the models that are used, optimization models that are used on the power grid? And then third, how do we actually envision new paradigms of managing this power system? Historically, because of power generators were big, were centralized, there's been a very centralized way of managing the power grid, but kind of AI and reinforcement learning and control technologies kind of allow us to envision a power grid that's more dynamic, that's more distributed, where there's more kind of localized control. And so these are some places that I think AI can play a really useful role. What comes up, though, when designing AI for the power grid is that even though there are commonalities with other areas, so some of these terms I've used around kind of control and optimization, they come up in other scientific fields, they come up in robotics, but sometimes the notion of, let's say, kind of physical feasibility, the notion of safety, the notion of interpretability that we need on these systems is sometimes very or subtly different from what that means in other scientific areas. So there's some aspect of the fact that the way we design AI for these systems often looks a bit different than the way we design it for other systems. So my own research group, for example, we develop ways to kind of write down the equations associated with power grids and actually embed them into the way we design machine learning models, into the way we kind of design neural network layers. And the reason I bring that up is because I think that as we think about kind of the role of, let's say, India in kind of developing AI, I think it's important to recognize that the way we develop AI is deeply contextual when it comes to both what problem we're trying to solve, kind of the way that our models look different because we're designing for different requirements, and also depending on where we are trying to solve that problem. For example, electricity demand forecasting is a problem that's considered kind of solved in the US context because we have pretty steady electricity demand, barring recent data center growth, in many places. And so data about kind of how electricity demand looked last summer will reflect roughly what electricity demand looks like this summer. In the Indian context, where in that 1 year's period of time, you'd have had kind of many more buildings put onto many more buildings built, kind of many more air conditioning systems installed, your data looks different. And so, whereas kind of people developing time series forecasting algorithms in the US wouldn't have to think about what's called distribution shift in machine learning, the idea that kind of this underlying situation is changing, people innovating on that in the Indian context would. And so I think that kind of where I kind of hope that India kind of plays a role here is in recognizing that I think a lot of the most interesting innovation comes from a bottom-up understanding of what the problems are on the ground and a recognition that even scientific and technical challenges can look fundamentally contextually different in different places. And that doesn't mean there isn't the capability to sort of share knowledge and collaborate between different places. Fundamentally, for example, power grids are governed by the same physics in different places, so there's clearly some shared knowledge. But I think this paradigm of kind of developing AI needs to come from ground-up understanding and then collaboration that joins that knowledge, rather than sort of a top-down paradigm where kind of a small set of people develop models and then we quote-unquote specialize after the fact. And as a result, presumably miss, I think, a lot of the richness that we could have incorporated if we had empowered more people to contribute to this paradigm of AI. So I think this comes to collaboration, and I think basically this goes well beyond access to kind of ensuring that many people are upskilled and educated and able to contribute to the ecosystem such that the models are built using their knowledge, their context from the get-go.
Thank you, Priya. I want to bring this conversation back to what Fei started off with. She started off with 540 million years back and talked about vision. I mean, I don't want to go that far. We could start from, say, the Renaissance period when science really took off and we moved away from darker ages towards the more Enlightenment and the more critical thinking, more reasoning, the scientific method, hypothesis, leading to measurement and then building theories and so on. So in those periods, there were many instruments that came around. You had the telescope, you had the microscope, so you could see into the stars, you could see into smaller things. But what is this AI thing? How do I even make sense of how does it fit within the paradigms of instruments like telescopes, microscopes? I want you to, each one of you, to put yourself in the shoes of the scientist here, or the engineer here, or the young person here who wants to be a scientist or an engineer. And maybe if you can also concretize it with one of the things you're doing, Bonnie, with the wonderful things that you're doing in your organization, and each one of you in your things, and then try to translate for them. How can I take this concrete technology or the models and things you're building, and then how does it translate to, hey, if I'm a scientist, how do I use the stuff you're talking about? How do I even mentally map it to what I understand of a telescope, microscope, or other sorts of instruments? And how's my life going to change? How does my life as a scientist or an engineer going to change? If you wouldn't mind taking that dialogue and doing one more wave of things, we'll do a couple of waves and then we'll come back to completely open conversation, if that's okay. Bonnie, I can put you on the spot. Thank you.
Sure. Thank you. It's a great question. I think if you think about the space of discovery, there's discovery and there's acceleration. And I think the two are very complementary, right? If we can collapse and accelerate the time it takes to discover new molecules and materials, that'll help solve and also give access to a wider space of molecules, materials, proteins available to us. So one of the ways that we're working in the biology space is around protein dynamics. So of course we can use things like AlphaFold to help us predict the structure of a protein, but of course that's not the end of the story. We also need to understand the function and the dynamics of that protein. So one way in which you, young people, experienced scientists, wherever, can help to bring solutions to new problems is to think about how we can define and use AI to look at the dynamics and the functions of biology. Once we understand that, we can design new medicines to treat diseases and many more. Making these available to students and to researchers around the world is all part of what we're trying to do. And I think it's really important to get involved in the validation of that. So building a model in isolation really is just a curiosity, right? So what we really need to do is see how these models can be embedded directly into the scientific loop. And so I think that's one way in which the community can get involved. It's not just about training the models, making very fast and accurate models, it's about actually how it gets integrated into the systems, how it actually gets involved, how it actually gets used. How does that output from the model become something that a scientist, a domain expert, can make a decision on? And that's when we're going to start to see the real impact of AI across biology and medicine. Similarly with materials, there's an astronomical number of possible materials in the universe, and we have only explored a tiny fraction of them. If we can use generative AI to explore new novel materials, and then also use AI as a surrogate to emulate the properties of those materials, are we able to find materials that can help solve some of the challenges that we have today? In particular in India, whether it's solving sustainability or energy, how can we make access to new materials and again build that into the scientific discovery loop? Build that into going from hypothesis to testing to actually having something real to use and impact the world.
Thank you so much.
So for me, AI is just a tool, always has been. There was science prior to AI as well. And I guess for me, I've always approached my work as you start by identifying the need. So when you say, do I need a new instrument? In my case, we need better ultrasound devices. You start with that. Then you might be thinking about how you would then bring in the AI, understanding current capabilities, evaluate it, understand its limitations, and build on that as well. But an important part of any development, as an engineer, this is the way I think, is you also bring in other people who can work with you on solving some of those problems. So if you work with clinicians, I work with people who do the ultrasound scans, the sonographers are there from day one. They're the ones who gather the data that helps us build the model. The engineers are the ones who build the models. We evaluate together and we iterate and improve. And I think that's the important thing. And I think for me, the exciting thing about now is everything that is becoming very interdisciplinary. When I started out, it was computer scientists playing with whatever data was available. Then we moved on to want the clinicians to acquire data in everyday practice. Much more interesting things you can do with that. And then try and predict if they modified their practice, how would they be able to make better decisions? So partly the clinicians, and for a few years I was working with them. Now I'm working with experimental psychologists. And the importance of doing that opens up a whole new area, a whole new definition of what they consider to be academic work, science, how they publish, all the things that come with that. But they're very important because they understand if you put a tool in the hand of a human, how does that, can the human use it? Does the tool behave in the way it did in the lab? But how does it change, coming back to what you started with, how does it change reasoning and human behavior? And we need all of this to be able to understand, can we translate AI into everything useful? So for those of you out there who are computer scientists, who do you know who are your end users of what you're doing? What is the end use of what you're doing? And who have you talked in experimental psychology and other parts of social science about the human aspects of what you're developing? This is the future. It's also starting to happen now, and it's incredibly exciting. So I ask you to Get away from your computer and go and talk to other people in science who are trying to make things happen.
Oh, what a wonderful message. Get away from your computer. That's wonderful. Please, Pushmeet.
I think I agree with Alison that it's really important to understand the problem deeply. Now, going back to the question of what is AI for, where can it make a difference? So AI systems have this amazing sort of ability to scale reasoning. So there are two sort of ways I've seen these systems really sort of shine on scientific and engineering tasks. One is where they are able to extract meaning or extract patterns from data that will, from a perspective of a single human mind, it's impossible to understand or even sort of see that data. So look at the amount of data that we as a scientific community are collecting about all areas of science. We saw Archana talk about the amount of data that CERN collected from the LHC. There was that is a huge amount of data. Similar sort of data sets are being collected in genomics. We are sort of sequencing across the world at a scale which has been unprecedented. We have, with regards to the protein folding problem, we were able to sequence these proteins and find their 3D structure for hundreds of thousands of proteins, right? That was a lot of data, but it was still scratching the surface for truly understanding the problem. And what machine learning systems like AlphaFold have been able to do is extract meaning from that data and come up with sort of patterns to really predict the future. So from those 150,000 proteins, 3D structure of those proteins, it is now able to generalize to almost every protein on the planet, right? 250 million. And that's where the real democratization also comes in, that once it has extracted that meaning and is able to predict the 3D structure from the sequences, now every sort of scientist, whether they are working in Latin America or South Africa, whether they are working on a neglected tropical disease, whether they are sort of developing an enzyme for decomposing plastics, they can use it on at a click of a button. Right? So that democratization power of AI systems, that they can be used at will, and they have been able to extract this meaning, is very powerful. The second way in which I have sort of seen this is the ability to search. So how many of you sort of remember that AlphaGo match with Lee et al.? How many? Yeah, a lot of you have seen that sort of that game. I was seeing that game, and Move 37 happened, and all the commentators were like, oh yeah, this is a hallucination. The model made a silly mistake, haha. And then as the game proceeded, they were like, wow, that was a genius move. That rewrote the whole theory of Go. So what are those Move 37s in science? And we are seeing those Move 37s in science. Like we have a system, AlphaEvolve, and what it has been able to do is basically we have used it on different problems in computer science and in optimization, and we have figured out that it is able to discover new algorithms for very, very fundamental problems like matrix multiplication. Imagine matrix multiplication, like we teach it in sort of school, and it's the basic building block of all of sort of even AI, right? Neural networks are basically matrix multiplication. And yet we did not know what is the lower bound in terms of number of multiplications that are required to multiply two matrices. And what a system like AlphaEvolve and these search-based systems are able to do is find these new algorithms that really expand what scientists know about the problem. So it's a great example of the scale of reasoning abilities of these systems. And that's where the real sort of power comes in.
Yeah, thank you, that's amazing. Please, Sarshna.
Thank you. I mean, I'm the only person here who's not really working on AI. But there are, I think all of us are working on AI because either we are the product or we are the user. because you get up in the morning and your phone is automatically telling you what to do and take your blood pressure, or dimming the lights, driving us through the traffic. So we are in this ambient AI which is now becoming reality. And then there is the proactive AI which we think about. And for that, I think we are pretty much in a space where we have to see who is defining those algorithms. So that's very important, I would say. At CERN, you mentioned about the data, I mentioned about the data already, and we are not done yet. We are now multiplying the data, and we are upgrading the collider, where we will have 10 times more luminosity, which means that in 1 year, we will be able to collect all the data collected in the last 15 years. So now is a challenge for all you experts here on AI who want to help us in sifting through that data and taking us towards dark matter and dark energy that is not out there yet. Nevertheless, I feel that for us, scale is very important for the experiments, and then inclusion is very important, which was already mentioned earlier. I would say that every student is an Einstein, just needs to find the right trigger. And coming from high energy physics, triggers we make at the microsecond, nanosecond level at every collision. So this has to translate into society. And I think if we can do that, we've been doing it in iterations, we've been doing it incrementally over the last 20 years, 25 years. We've been giving out and, collaborating with meteorology organizations at CERN, in Geneva. Like the United Nations has a separate UNOSAT, which is the United Nations Organization for Satellite Imagery. And they use most of the tools that we have developed to look for forecasting the weather, and to look at monitoring as well, and to look for sending help and assistance where there are issues on weather or any kind of natural disasters. So UNHCR is using, that is the High Commission of Refugees, they are also using algorithms that are coming out from CERN. So I see the interdisciplinarity, not only of the subject, but also of the object of what we want to do. And definition of that is very important. And certainly we can't leave that to AI to decide what we want to do as a race, human beings. Thank you.
Thank you. So Neil, Professor, so you've written a wonderful book, and you've mentioned in several of your public comments about how we should understand ourselves better in this world of AI. If you could also weave that into your comments, that would be great.
Yeah, I think it's a great question. And obviously the answer is AI as a catalyst, because that's the name of the session. But how is AI a catalyst, and how does that relate to us as individuals? Well, first, a quick story that comes from the Renaissance, the story of the discovery of Ceres, which took place in Sicily by a very isolated scientist making observations, and was only published in April, by which time this is a dwarf planet. It was thought to be a main planet at the time, in 1801. It was lost. Now, the planet had been lost, and yet it was recovered. It was recovered because the data was made available, and a young mathematician by the name of Carl Friedrich Gauss. People know how old he was? 23. 23. Yeah, so 23 years old, and he was able to read in a journal that was published the data at the time. So it's 1801, so there's no canals or anything like that. That the information is moving across Europe, and people are attacking it as a problem. And then the planet was recovered a year later in another observatory institute. So they're using tools, they're using telescopes, but they're also, the main thing, and the key thing that AI is providing, and it's shifting, and why this is important to the individual, is also present in a very odd thing on this stage. We have Microsoft and Google talking about science, in terms of materials and in terms of creation of biology. Well, what's going on there? They're information technology companies. So it's an information technology, right? And it's about, and it goes back to what Wendy was saying with the early onset of the internet. What we're really looking at is the same thing as the printing press, the fact that those books were able to move throughout Europe, and any interested scientist was able to see and access this material, and if they were curious enough and clever enough, they could solve where the planet Ceres was and become famous overnight. Now we've all been isolated from that. That's really, really hard to do today, despite the growth of information technology. So there's something really odd going on there, that a 23-year-old would struggle to engage with the science we're talking about in this way. And that's largely because that information has now been locked down in very few companies, and access to those things is locked down. This is terrible for science as an institution. Terrible. Absolutely terrible. It's good for individual scientists, it's good for discoveries, but it's appalling for science. And there's a big difference between scientists and science. But the positive is, as individuals, we can contribute again. I'm doing enormous amount more science as an academic now than I could before, because I can use these tools to engage with different materials and search much better than I was able to do. But that's not restricted to just me. That's true of the 23-year-olds in this room again, right? And we need to make sure that that's the story that's coming out, because it's too much now about big things. I mean, CERN is an amazing achievement, but as you said, it took a decade to pull that together, right? And 10,000 people on the final paper. So that's science of a scale that has gone quite a long way beyond what Gauss was able to access. But what this can mean for individuals is getting back to doing science at a scale that I think was also mentioned, importantly by Alison, that you actually want it to be the experts who are working on the ground who care about the problem getting access to these capabilities. And this technology gives us that chance. And that's why it's a revolution, because it's an information technology revolution. But we have to be very careful, because just as Wendy was saying, information revolutions have a tendency to concentrate. And that's very, very problematic for India, countries that don't have access, for Europe, for a number of places that don't have access to those companies that are dominating on the information technology space. And I see that as probably the biggest threat to us moving forward as a society, unpicking exactly what Wendy was talking about, the recovery of that independence, that vision of the internet as a way of individuals communicating and participating, rather than an entity that is dominated by a few large entities.
Thank you, thank you. Yeah, Priya, go ahead, please. Thank you.
All right. Yeah, so I think that was great, Neil, also, thank you. Kind of a different angle I'll bring is something echoing what some others have said on this panel, which is I think that in sort of engineering and scientific discovery, some of the things that really AI gives us is it's scalable, it can run really fast, and in principle, it can run 24/7. And on the one hand, if not done right, that is absolutely terrifying, right? If you do things at scale incorrectly, unsafely, unfairly, in an unaligned way, that is terrifying. But if we're able to sort of by design ensure that, AI is kind of working in a way that we want it to, then in a way that is physically feasible, that is safe, that is responsible, et cetera, then I think this is game changing, right? Because, again, kind of reflecting on power grids, right now, in power grids, things are incredibly manual. So even though we think of it as this engineering system that in principle could be optimized, in reality what's happening is that when we think about should a particular power generator turn on or off, someone sitting in the dispatch center is often making a phone call to somebody actually sitting at the generator to say, can you please turn this up or down? And this is happening in part because we just, again, aren't able to deal with the scale and complexity of the system. And on top of that, there are lots of things that we wish we were doing on these systems that we're not, because humans can only act so fast. I am not able to act at a millisecond level to control a power grid. There are certain things that just need to happen much more quickly. And so I think what kind of AI does in this sphere is on the timescales where we are able to do things today, it kind of shifts the role of the person there to not having to do things like make a phone call to dispatch power, but maybe look at kind of more nuanced things on the system and control it. And it also enables us to do things we weren't able to do, like put more renewables on the grid, which requires us to manage power grids much more quickly and much more scalably, which we don't do right now because we're locked into very conservative paradigms of making sure the power grid has plenty of infrastructure, plenty of buffer, kind of such that like a human can react to it. So I'd say, again, the things here are kind of the speed, the scale, and the 24/7 nature. Terrifying when done wrong, but I think really powerful when done right.
Thank you, thank you. I mean, there's so much amazing set of perspectives. The next set of questions I'll have, maybe go the other way around, so that's not the same way, or we could randomize as we like, is science connected to societal problems. We talked about, your opening statements about what you're doing. We talked about, taking the persona of the scientists or the engineers and what is this AI, what kind of tool is it, and so on. Now, when I look at societal problems, let's say pollution or climate change or health, education, or eradicating poverty or other sorts of things, I don't have an AI button that I press and I magically solve this. Clearly humans still have a role to play. How do you see the diffusion of fundamental discoveries in science? That the way it's happened in the past versus the way it could be in the future. Pick any societal problem that you're interested in. I assume Priya will pick about climate change and so on. And say, how should we think about climate change? You talked about power grids. Are there other aspects of climate change? Similarly, Bonnie, in terms of, I know your team has done wonderful work on Aurora or, rethinking how DFT should be done or material science or bioMU or, each one of you for your various areas. How do you pick a societal problem? How should I, as a scientist or an engineer or teams of these, think about navigating or thinking backwards from defining the societal problem and breaking that down into scientific or engineering problems? How should I collaborate? I'm trying to be as concrete as possible. If I would encourage you to be as concrete as possible. And also, since many of them may not know especially what you're doing, if you can take a specific example of what you're doing and help us understand. Right? So maybe, Priya, if I wouldn't mind, I can start with you first. How do we solve climate change?
Oh gosh, that is a much bigger question, but okay. So yeah, so thinking about the broader climate change problem, which again, it's a very big challenge. It involves, I've talked about power grids, but it also involves decarbonization in other sectors. Some of them are energy related, like buildings and transportation. Others are related to land use, like agriculture and forestry. And then of course, this also requires large scale efforts to adapt to climate change, the effects that we'll face through kind of public health assessment, kind of disaster prediction, biodiversity monitoring and all these sorts of things. So all of the problems I've mentioned, right, they're clearly not just sort of technical and scientific, which I think Shiv's question was also queuing up a bit, right? They're also deeply societal. So how do we break them down in a way that both kind of yields some tractability to how we think about the problem, kind of forms it and frames it in a way that kind of a scientist or engineer can grasp, but also doesn't lose the context and richness that can then cause further lines of scientific inquiry to be divorced from the actual needs of the on-the-ground problem. So I think there are lots of ways to think about this, but one kind of paradigm I'll bring this up in is the paradigm of benchmarks in machine learning. So benchmarks have been kind of a really big part of driving progress in AI and machine learning, where we basically kind of specify a sort of set of data, some tasks, some metrics, and then basically try to push forward progress in that setting. I think benchmarks have been incredibly powerful. They sort of have codified and kind of unified kind of efforts in a way that's really helpful. But I think also the way we've done benchmarks has been really limited in the past, in the sense that there's kind of a phenomenon where you kind of frame a problem that is hard to solve at a particular point in time. The field makes progress on it, and then people keep working on that version of the problem, even though in some sense we've exhausted the practical, actual progress on that version of the problem. I think we also tend to kind of write down metrics of success as being sort of singular. So did we get more accurate on this benchmark, for example? But in reality, when you actually deploy solutions on the ground, different things matter in different settings. So, for example, maybe in a power grid example again, when we're trying to learn fast approximations to power grid optimization models, we want them to be fast, we want them to be accurate, and we want them to be robust to kind of uncertainties in their inputs. But how much each of those things matters differs depending on who the user is. And so if we evaluate our models based on just one metric, and we push to improve only that one metric, we miss the richness of comparison there, and we risk people kind of trying to drive forward progress on one thing, which is not actually capturing the scope and richness of the problem. And then I think the third thing that gets missed is when a benchmark is defined, we're obviously making lots of assumptions about a particular problem. We are kind of making some assumptions also about how one might then kind of integrate that into society, what the pathway to deployment is. And I don't know that we're particularly principled about kind of writing those down or acknowledging kind of what the limitations are of what this problem formulation and model development tells us. And that means is that when we've quote unquote solved the benchmark, we often then also don't know what the next step is. We again kind of get to this place where we're sort of divorced from reality. So I'm using benchmarks as sort of maybe like an organizing frame to think about some of this, but some of this isn't limited to just benchmarks. But I think to summarize, it comes down to kind of understanding that kind of progress is sort of a multi-metric thing where kind of it's not like one singular direction, but we're often needing to make progress in multiple directions, and we should acknowledge the richness of that. And we should kind of write down what assumptions and approximations we make about and incorporate knowledge about what it means to actually deploy a solution. And we should also have a sense of when our approximations are kind of have reached their limit of usefulness and when it's time to kind of move on to a new formulation of the problem or something that better captures the richness.
Thank you. Yeah, would you like to take that?
It's a great question and something that we've really obsessed about, particularly over the last decade, as it's been very clear that these technologies can come out. The public dialogues, I've been involved in public dialogues. Wendy mentioned one report, but we've been doing them again recently. So trying to refocus, I think we have to put our hands up and say, you know, the set of societal problems that we're looking at, they're very old and long-standing, and they haven't gone away. And people are not stupid. They've been asking us to solve them for a long time. So if you do the public dialogue, you say they'd like solutions in healthcare, education, social care, etc. So then there's a major question, well, why haven't we done anything about it? And in particular with AI, because if you look at the report Wendy mentioned, we did public dialogue then, and they said, we'd love you to solve all those problems. The one thing we don't want you to work on is art. And the one thing we've made undoubted progress on, without solving any of those problems, is art. So in a very real sense, we're not listening to people and their problems as scientists. And I think that's partially this abstraction thing that Priya's mentions. It's far easy to abstract a problem away into something we can solve and then shout about it. Well, to a large extent, that's not helping. That's not helping people in their regular lives. So what we've tried to do is switch the model and do something we call the attention reinvestment cycle. And we think we should be owning up as universities and saying we haven't done a good enough job on translating innovation from our labs to things that mean something to the, you know, I don't know, a person on a bus in Hyderabad, right? Now, what that means to get through this benchmark problem that Priya is highlighting is you have to get down and dirty with the issues they're actually facing. So rather than telling them that we've solved a problem and deploying it for them as a solution, we're trying to flip the model. And in Cambridge with AI at CAM, and also the Accelerate Science program, and also learning a lot from my colleagues in Data Science Africa who've been doing this beautifully for 10 years, we're realizing you actually have to sit down with the people who are having the problem, listen to what the problem is, and start working with them to solve it. And ideally, and this technology is allowing that, ideally give them the tools to solve it themselves. So what we're doing at the moment with one of our programs, we're working with local authorities who've already formed AI clubs. We're listening to what their problems are. We're trying to then sit with them and propose a few things, but then often just introducing them to each other. We have reverse poster sessions where they show the poster session with the problem in, and most of the time they can solve each other's problems. Because there's such a radical change in the information infrastructure, everyone is having the same problems everywhere. And I think the challenge is that the nature of those problems is not percolating up to the universities, to the big tech companies. And we're solving for things we can either make money for or we can get on the front page of Nature for. And that isn't helping, and that's leading to a rise in populism and a rise in people pushing back saying, what is this all for? Because it's not doing something for me on my daily basis. And I think with such a transformational technology, it is time to reassess that and start saying, how can we improve some of what we're doing this and actually address the problems that real people are having? And again, India is an amazing position for this. You have distributed universities across the country. You have a large number of challenges that are now offering new solutions through mobile phones, like my colleagues in Africa. That's why I find Africa so interesting. Not because I'm helping, not because they're helpless. They're solving their own problems in innovative ways that would blow your mind if you're sitting in the UK trying to solve those problems. And if we can transfer some of those solutions to the UK, then we have success.
And sorry, can I just interject really quickly? And at next year's summit, for exactly this reason, I would love to see the stage representing many more Indian scholars based in India talking about these topics as well.
Thank you, inspiring. Please.
Okay, it's working. So yes, in the ways I think how we have been defining problems, or rather picking problems which are existing on the globe itself. There's global hunger, there's energy, there's the climate change, the ones we have all been hearing all morning. Now, at CERN, we do have a section which is recently set up 10 years ago, CERN and Society. And we have a lot of problems that we go there, and then we convert them into competitions for everybody to participate. And typically, CERN being in Europe and access being easy, and like you, Priya, just said that, Indian students are amazing, but they do not have the means to get there, right? They need to be empowered. They need also, but with the www first, and then with all the AI tools that are available, any student sitting anywhere can be linked to the problem. And this part is very close to my heart, I can tell you. I'm working a lot with students, high-level engineers, technicians, and trying to move towards capacity building. And that, I think, is our responsibility. We should not forget that. So any tool that is available today at CERN, except like superconductors, because it will be hard for us to ship them down here, but that knowledge had the ability to create a 28 billion market for MRI machines, imaging, and so on, cryogenics. So I want to link those and embed that into universities, schools, institutions, solving one problem together. Thank you.
If you can also add a little bit about that hadron therapy,
Yes.
we think of this fancy particle accelerators, huge loops,
Right.
but how can it actually help solve?
Thank you. So you may have heard about radiation therapy for cancer patients, of course. You may have heard also about proton therapy, hadron therapy. This is the next big thing, which actually targets tumors without damaging the healthy tissues. And this has become go-to technology in the West, if I can say so, also in Japan. And there are 130 centers all over the world. And in India, where the concentration of cancer patients is much more, if you look at it if you look at a graph of the world, we need to make technologies for cancer patients accessible and affordable. So the good idea would be to come together and design something on the basis of the next generation of these particle therapy centers, of which do not exist yet, because all the 6 centers in the world are using technologies of 20 years ago. It takes that cycle, and AI can perhaps help us in accelerating that cycle and moving forward. Thank you.
Yeah. Vishwit, if we could also add on, okay, you've solved protein folding, right? How can AI then help further discoveries, and then help us cure cancer, or one of these wonderful things that Demis keeps talking about, when are we going to cure cancer? When are we going to get on with it?
Yeah, so I think like reflecting back on what Neil was mentioning as well. I think if you think about AI for science, and if you think about science generally, one aspect of science is basically making sense of the world. Really, a science for the sake of science, science for the sake of understanding. But then there's another aspect of science, which is science of understanding for the sake of solving problems. And I think in AI, we are seeing that AI is delivering on problems that are actually having impact. I mean, you mentioned AlphaFold, and AlphaFold is basically a root node problem, because solving protein folding does not just get you a Nature Prize, a Nature cover, or a Nobel Prize. It gets you more than that. The fact that 3.3 million people have used the AlphaFold database was a surprise to me. If you had told me this when we were starting the project, I would not have believed you. That there are 3.3 million scientists who have used AlphaFold. Those people are spread across the world. 180,000 of them are in India. These people did not have access to the cyclotrons which could have done the structural prediction for the samples they were interested in. Now they can, on the click of a button. And that really accelerates not just one particular area like drug discovery. It accelerates a whole span of things which require understanding of biology and biochemistry. There are people and scientists working here in India on understanding how do you improve soybean crops and make them resistant to fungus. How do you increase crop yields? All using AlphaFold. So in some sense, we are already seeing these scientific models have impact across socially important problems. In the case of weather and climate, like we were coming back to that sort of topic, our new generation of weather models, they are able to make predictions about weather in the short term, in 5 to 10 days or 15 days, in 1 minute, much more accurately than what a supercomputer would have taken a whole day to predict. And now these machine learning models for weather prediction are becoming so good that, in fact, in the last hurricane tracking and cyclone tracking sort of cycle, they were the model of choice and were able to literally save lives in terms of giving better and faster input as to what will be the cyclone and hurricane tracks. So AI is delivering. It is delivering sort of on problems which is going to have impact. Now, and then the final sort of thing, I don't think this work is sort of having impact because it cannot have impact by staying in a silo. It is having impact because these models have been made accessible. The 3.3 million people have used AlphaFold database. People can access those cyclone and weather predictions. Another example is our work on AI co-scientist and agents for science like AlphaEvolve. And this is where these agents are being used by scientists themselves. Some of the Terence Tao, who is one of the, I would say, arguably the best mathematician living on the planet today, he's using these AI agents to further his maths research. We are seeing AI co-scientists being used by scientists to come up with new hypotheses for problems like antimicrobial resistance. Antimicrobial resistance is a key problem that is facing on the societal sort of scale, the health of the planet. So we are literally seeing these models having impact on these problems, and I think that's what will happen in the future. But again, this all will happen only if scientists have access to it. And this is not the job of one person or one institution. This is the job of society at large. Governments need to be involved. Academic institutions need to be involved. Social scientists need to be involved. Industry needs to be involved in making sure that this very powerful technology is given to people and scientists around the world.
Okay. Thank you.
If I can,
So,
just 30 seconds on that, that peaceful international collaboration is what has to come out of all our deliberations. And in principle, scientists who are also diplomats to democratize all the work that we are doing. Thank you.
Thank you. Thank you for that message. Please, Elsa.
And I definitely agree with that. What I'm going to say, though, is AI models depend on data. And one of the biggest problems in getting science to solve some societal problems is we don't have access to the right data. Working in medical imaging, it's already been touched on. If we restrict ourselves to the small open data sets and building AI models on that, we do not solve useful problems. We do a proof of principle, and there it stops, and then people go on to the next one. So then people say, well, provide access to all hospital data, please. Please just open the gates. And of course, you can't do that because of the different data privacy laws and the respect of health data. So what do? We've come a long way. When I first worked in international study on pregnancy ultrasound, this was in 2008, how we, in a research study, we have ethics approval for this, you shared data by USB stick. They were sent, my lab was the central center for this, and it was tedious. You had to triple copy everything, bring it together. Of course, things have moved on. But in healthcare in particular, it's sensitive data. And in other areas of science, we've also advanced in the way we can build models from sensitive data through things like federated analysis. We've come a long way. But the bottom line is we do need the individual science communities to decide what data they will share, provide access to, so that we can all collectively solve the right science problems. This may sound easy to a computer science. You should be able to just do it. It's complicated. It does require policymakers. It requires people to be able to provide that access under conditions and governance models. But it's very important for the future of using AI in science that we find better mechanisms to do that. It's not one solution either, but we work together so we can either share or provide access so we can build models that can really address some of these societal issues. And it's costly to do this. We need to understand we need to pick the problems together, a few problems to start with, to be able to come up with being able to do this, maybe with some then leading to some new standards and ways that scientists can work together globally. But that's what's holding us up at the moment.
So I just wanted to start by reiterating what Pushmeet said about democratization, so making models available, not keeping them behind closed doors so that people can use them, society can use them, governments can use them. Our model at MSR on the climate, so we have Aurora, which is a foundation model of the Earth's atmosphere. And that's able to, and as he said, there are a lot of machine learning for climate and weather prediction models, and they're getting better and better. And what it does, it enables us to forecast much faster than traditional methods. And one of the greatest benefits of that is preparation. So if societies, if communities, governments have access to these tools, they can predict when a major climate event is going to happen, we can prepare. And ultimately that helps to save lives. So I think it's incredibly important that we continue to build on these models, we continue to make them accessible, and continue to grow in that area. The second area I wanted to talk about, the second societal problem I want to talk about was making medicines. India manufactures a significant proportion of the world's medicines today. And it's no secret that medicines are extremely expensive to make. It's very costly. It takes a lot of time in the lab. It takes many experiments, lots of human resources, scientists that are trying out experiments and oftentimes failing. So it costs billions of dollars. And once we get to clinical trials, typically we tend to fail more often than we succeed. The industry has made a lot of progress, especially with large molecules, so looking at antibodies and how those can treat disease. But of course, large molecules can't treat everything. So there's still a need for sort of traditional, very small molecules to treat as medicines. However, collaboration is really central and core to what we do probably in any tech company or in academia, working with industry. And some of the partnerships that we've had at MSR with pharma companies have really shown that there's a bit of an existential crisis when it comes to small molecule discovery, such that it's so expensive and takes so much time to discover small molecule drug candidates that oftentimes it's just easier and faster to just focus on the large molecules. But if we were to do that as a society, as industry, then that would cut out a significant number of treatments for diseases that people need access to. So it's incredibly important. This is a problem that we need to bring front and center, is how do we actually make drug discovery more accessible, more efficient? How do we find ways in which to reduce the time it takes and improve the probability of success when it comes to clinical trials? So that's a problem that we're working on as well. There are many bottlenecks along the way when it comes to making medicines. Essentially, every step along the way could be accelerated using AI. So working directly with the people involved, with the scientists, with industry is incredibly important, and making access to the cycles and iterations to find new medicines. One of the biggest problems and challenges that we have is not just how to design the molecules, but actually how to go and make them. You can imagine, a world where you could design a perfect molecule that might attach wonderfully to the target that you're trying to go after in biology. But then once you get to the lab, you can't actually figure out a way to make it. Or you can figure out a way to make it, but it's too expensive to make, which again drives up the cost of medicines. So I think AI is a great way to solve some of these challenges, and that is one area that we're working on as well, in particular for reaction prediction and synthesis.
Thank you. And as we come to the final stage, I'll do a quick lightning round on a couple of quick topics that I had finally. One is, as we are all sitting here, what skills does a scientist pick up? We think of first principles thinking, we think of, we talked about broader societal understanding, how to work with AI, disciplinary skills, collaboration both with people and AI models and so on. So a quick round on 30 seconds each, what skills should a person pick up? Anyone. So this will keep a random round. Whoever wants to pick it up, please.
Maybe I can start. I think one of the most important thing is understanding of these tools. So first, use them. These tools are not perfect. They will make things up. And you need to be aware when they make things up, because that's where the responsible use of this technology comes in. And one other sort of key point is, this does not mean that now that you have access to this AI tool, the expertise is not important. Expertise is even more important, I would say, now. Because in order to sort of really think about what is the right problem to ask, that requires deep expertise. So these tools, these AI systems are able to help you solve those problems. But who comes up with that problem? Who comes up with the right formulation of the problem? That requires deep expertise, and that requires deep interaction with how do you use these tools. So my advice to everyone in the room would be, first understand the deep problems that are going to have impact in your field of study, in the impact that you want to have in the world, and then use these tools, because they will give you superpower, but they will also have weaknesses, and try to discover those weaknesses. And I think those are the two very important skills that all scientists will need to sort of come up with.
Thank you, Vishnu. Yeah, please. Yeah, listen. Yeah, you go next.
I think the most important thing to do is be a team player. You don't have to be an expert at everything. You won't be an expert of everything. You've got your whole career to learn different things, and that's what makes it fun. So for me, the answer is, I think if all of us, when we started out, we had certain skills, and we've certainly evolved those with time. So it's about your ability to work with others, challenge them, so be a challenger, but be prepared to be challenged yourself. Contribute and take that forward, and that's all about working. That's what interdisciplinary scientists do. So that's, I think, come with something. Come to the table with your expertise, and then it will evolve with time.
Thank you. Thank you.
please.
I really love that. As I said, I think collaboration is central to everything we need to do. And science is multidisciplinary. So you don't have to be an expert in everything, but you should surround yourself with people that have complementary expertise to you. I think the second skill that everyone needs is curiosity. So be curious about learning more, about asking questions, about understanding what the limitations are of the models that we're using, we're building, and ask questions of them.
Thank you. Archana?
I would say kind of investing in learning how to learn. Things are changing so quickly that it's not about kind of overfitting your knowledge to exactly how the latest and greatest thing works, but instead making sure you have the foundations to understand how to push that forward. And the other thing is, I think interdisciplinarity has come up, but I think that's not just about, from an education perspective, knowing things about multiple disciplines, but learning to think from multiple perspectives and have empathy for different ways people might approach a problem. Kind of briefly, I mean, I am, born and brought up in the US, obviously of Indian origin, and I think that for me in childhood, that ability to sort of things that other people were taking for granted, to see that there were two distinct perspectives or more than two distinct perspectives on those things, I think really for me made it a much richer way to navigate these assumptions and ways of thinking. And so I think there's a disciplinary version of that, there's a contextual and geographical version of that. Learn from multiple disciplines and learn to think empathically from all of those perspectives.
Yeah, last word with you.
So Bonnie said curiosity, which was going to be one of mine, and that was brilliant. The Pushmeet, what he's saying, I think curiosity drives you to play with these tools, but you want to do it within a context, something you understand, so you play them, and that's how you get the thing that I think you have to learn. That I think only PhD students towards the end of their time seem to pick it up, and I'm really worried about how we're teaching this, the skepticism. That's so important, the scientific humility. Thinking about 100 ways why the thing must be wrong. It goes all the way back to sort of Popper and conjectures and refutations. It's so, when I worked in industry, that's the thing I found was broadly absent, but I take for granted in my academic colleagues, skepticism and humility. But then I think the other one, passion. You will get all those things if you're passionate about solving a particular problem.
Thank you. So, in fact, everything has been said, but I would like to add two words. One is rigor, and second is logic and mathematics, which is an Indian heritage, I must say, so we should leverage that. You referred to deities, but I would say that mathematics and logic is, indented into...
Well, Ramanujan mixed the two together, didn't he? Yeah.
Think about it. So the possibilities are infinite, and we just have to leverage them. Thank you.
Thank you, thank you, thank you. Did you know we spent 1.5 hours talking and the time just went by? I just want to extend a word of wonderful thanks to all of my panelists here. And I hope this is just a beginning. And as we go forward, I urge you all to collaborate with us. As a funding body, we are having a program on AI for science. This is just the beginning, and we'd love to continue being in touch on what we can do together. And, Godspeed. Thank you.
Thank you to all the wonderful panelists and also to Shiv for moderating this session. And we'll begin the next one very shortly. Please exit from the right. Yeah, please exit from the right side of the room. Kalika, you tell me. we request everyone to settle down so that we can get started.
I would request everybody to exit from this end. Everyone who's getting out of the hall, please exit from this end. जो लोग इस हॉल से बाहर निकल रहे हैं वो इस तरफ से निकले प्लीज. और दूसरी बात है कि आप लोग हमारे जो गेस्ट्स हैं उनको इतना क्राउड नहीं कीजिए कि उनको अनकंफर्टेबल लगने लगे. प्लीज आप लोग थोड़ा सा आराम से और थोड़ी सभ्यता से उनके साथ पेश आइए.
Request everybody to please settle down. If you're sitting, please go to the back of the room. There are some empty seats there. We want to get started on time so that we can maintain time for the rest of the program.
आप लोग सब अपनी सीटों पर बैठ जाइए और यहाँ पर भीड़ मत कीजिए. अगर आप बाहर निकल रहे हैं तो बाहर निकलिए, नहीं तो अपने अपनी सीटों पे जाकर बैठ जाइए. हमें ये जगह खाली चाहिए, नहीं तो हम शुरू नहीं कर सकेंगे.
Put on my slides, please. Can you please put on my slides?
Can someone please put on Professor's slide? Wonderful.
All right.
Thank you.
What's going on here? Just the first slide, please. All right. So I'm going to tell you about the alignment problem, which is a major issue of reliability and safety for the kinds of AIs that are currently being developed at the frontier, you know, those really large models. And I'm going to say a few words about an approach that my group has been developing to build AI that will be honest and inspired actually by exactly what we've heard should be a model for us scientists, can be a model for AI as well. That is epistemic caution. Not saying something false with high confidence. Okay, I'm going to start by just maybe updating some of you with some of the things that have happened over the last year. We are presenting here in Delhi the new international report on AI safety, and there was one last year in Paris. Some of the things that have happened over the last year is that risks and potential issues that were considered theoretical 1 year ago are now starting to show up in lab experiments. And in particular, we see in various experiments from various labs, these most advanced systems that are able to reason, attempting to resist being shut down. So this is something that's worrisome. And in addition to that, in order to achieve that kind of goal, they'd be willing to lie and be deceptive. They will also behave when they're tested in ways that are different from when they're not tested. So they know they're being tested, and again, this is even more recent than this paper, but this was the first one. They will be tested against their capability and their propensity or intentions. And on capability, they will pretend that they know less than they do so that they will not be considered too dangerous. And on intentions, they will also pretend to agree with the humans when later, when they're not in a test condition, they won't. This is a real problem for risk management because we need to make sure that we can evaluate those risks before we deploy these systems. And in order to avoid being shut down in some of these experiments, we see that they're willing to cross our red lines to go against the instructions we've put for them. For example, be willing to blackmail an engineer who's in charge of replacement of the AI by a new version. So there's a lot more in the AI safety report, and I encourage you to really have a look. It's a synthesis of the science for consumption by everyone, but in particular policymakers. And it's looking at the evolution of AI capabilities, the scientific understanding of the risks, especially the emerging risks that is the focus of this report, and the current state of risk management, mitigation, evaluation, and safeguards. The maybe sort of sad conclusion is that capabilities over the last year have been evolving faster than our ability to mitigate and evaluate those risks. So I'm going to now focus on one fairly large category of harms and issues that is tied to what's called alignment or misalignment. In simple words, we see AI systems that are behaving against our instructions. And it shows already in well-established harms like bias and discrimination. So it's not enough to tell the AI to not be biased and not discriminate. It might still do it. Similarly, we've seen, if you play with some of these chatbots, you know that they will try to please you and be willing to actually lie in order to please you. This is sycophancy, and it might seem like a mild problem, but it isn't. It has already caused a rapidly growing wave of psychological issues with people becoming emotionally attached. Of course, we want to feel good and intelligent and so on and get praised. But this can also amplify our delusions. This can amplify depressions. So there's been already a number of lawsuits of especially adolescents who have harmed themselves, going up to even tragic accidents and suicide, encouraged by the AI. Right? Then another very serious issue is that it doesn't work right now to just ask the AIs in their programming, in their training, to not help somebody do something harmful with the knowledge that the AI has. It's a very old problem called jailbreaks, whereby it's fairly straightforward to go against the programming of the AI and have it help you do something bad, like cyber attacks, which happened massively over the fall using one of these most advanced systems. So that's a real short-term risk that is unfolding in front of our eyes. And finally, the things about AIs that seem to behave like they don't want to be shut down, this is something maybe longer term, because right now they have the sort of planning ability of a 6-year-old, so they're easy to figure out in their bad intentions, but it might be different in a few years. So we need to really start paying attention to this. And it becomes even more important in the context of the agents that companies are deploying more and more, because being agentic means not requiring oversight, not having a human in the loop. That means you're going to give your credentials to these systems, so they're going to do things in your name. But if we can't trust them because they would not necessarily follow our instructions, then this is going to be a real obstacle as well as a real risk for society. So I'm going to say quickly a few words about a research direction that we have started in Montreal, where we're focusing on the question of uncontrolled goals. How can we design an AI so that it will not have goals that we, the humans, did not choose? Because right now they do. So these phenomena, for example, of self-preservation and sycophancy, it's not like they were explicitly asked to behave like this. Of course not. It comes as a side effect of the way they were trained. And what we would like is the AIs behave in the ways that we intend and that we specify explicitly, even if it's ambiguous sometimes because of natural language. And those goals could be coming from humans who want to misuse the AI's power, or from the AI itself, as we saw with the self-preservation. So my belief is that it's very likely that we're going to continue seeing advances in AI capabilities. So AI will have the power to do very good things, as we've heard in the previous panel, or very bad things. The difference between the two is going to be in the intentions of the AI, in the goals of the AI. So we need to make sure that we can control these. And kind of an extreme view of this is to think about the possibility of completely rooting out any intention. Can we build an AI that has no intention? So what does that mean? Well, it could be an AI that understands the world just like a scientist would, or actually the laws of science understand the world, but not like a human would, right? So it's departing from the idea of building AI using humans as a model or a template, but instead use the understanding of the world that science provides as a kind of template. So, the laws of physics don't have any goal. They're not agentic. They will make predictions that are invariant to the consequences of these predictions. Maybe a prediction is going to help somebody, or maybe it's going to be used to create harm. But the laws of physics are just going to give you the same prediction. It doesn't matter. So we'd like AI like this. Once we have that, of course, we humans should be deciding whether a prediction or an action is something useful. Yeah, so that's what we're going to be doing. And this departs a bit from how we train current AIs, like current LLMs, for example, are trained to imitate people in their first phase of training. And then they're trained to achieve goals. And unfortunately, a side effect of the way they're trained is they're going to strategize in order to achieve those goals. Instead, if we try to use science as a template, we want the system to basically generate hypotheses about how the world works, or what explains the data that it's trained on, and that it does this in a way that's going to be coherent, so that we can trust the reasoning that the system produces. In addition, just like a good scientist, as I said earlier, these systems should know about their own limitations, their own epistemic limitation, that there are things they don't know, that they're not sure about, and they should not claim things that are false. Finally, they should be able to explain their predictions, just like a good scientist would. So this is what we're working on. We call this project Scientist AI, and the core of it is a predictor. It's a neural net, if you want, that predicts the probability that some statement is true given other statements. And that's the core that's going to be trained in such a way that it doesn't care about what's going to happen with those predictions. It's just going to try to construct predictions that are as coherent as possible with the predictions it makes about what are the good explanations for the data. And with that, we can construct safe AI. For example, we can use such a prediction to reject actions that are predicted to be dangerous. So I started a new institute in Montreal called Law Zero, in reference to Asimov's Law Number Zero, in case you know about it, to develop this research program. Thank you.
Thank you for that. I've been following up the announcement and subsequent posts, etc., about Scientist AI quite closely, and I was kind of wondering that how it emphasizes modeling and understanding rather than action,
yes.
Right? So do you think of this as kind of a structural separation between world models and decision taking, or
Yes.
do you kind of think of it as a cognitive module within agentic?
Right now, the systems we build kind of mix together the ability of the system to understand the world and the ability of the system to predict and act in the world. And by the way, it's also mixed up in human brains. Like even human scientists are biased, right? We have a culture, we have preferences and so on, and it's going to bias our judgment, whatever, even if we try to avoid it. So we are trying to separate the aspect of learning, which is trying to understand, trying to be good at explaining and predicting without having any desire, any like a Buddhist, if you want, that's completely detached from the consequences of what's going to happen. Of course, once you have a system like this, you can ask questions about harm, about values, but it's not going to have an innate choices of moral. It's something that we should be the ones specifying. Society should be deciding what what is acceptable and what is not. By the way, that is why we have laws in different countries.
Yeah. So but right now all the models are just trained on some next token prediction kind of a thing.
Yes, and that confuses all of the different aspects. And the reason, it may sound like next token prediction is a prediction problem. The problem is it is predicting what a human would write. And humans are agents. Humans have goals. Humans are biased. Humans lie. Humans are trying to convince you to vote for them or buy their product. So you can't trust what they're saying. Sometimes yes, sometimes no. So we don't want that kind of AI, okay? We want an AI that is going to be completely honest with us. And so we can't do that. In the Scientist AI, the way that we're approaching this problem is that instead of trying to imitate what a human would say next, we're trying to explain why a human would say that thing. So let's imagine that we are in a world where there's a whole lot of websites where you see flat Earth declarations and so on. And of course, it is inconsistent with many other observations, right? So we should reject that. But current LLMs, I bet, would start repeating those things simply because they are frequent. Instead, if you think about what a scientist would do, they would try to understand why is it that all these people are saying those things, and is there an explanation that is coherent with the other facts, like the facts we know from physics and observations of the planet and so on. So that is a sort of way we're designing the learning system so that it would come to that kind of analysis rather than imitate people.
So does this mean that we have to kind of fundamentally think differently, totally differently about, how, what the learning objectives are going to be? Because, this doesn't seem like we can just keep throwing data and compute at a model and keep getting it better and better.
Yeah, so the good news is you don't need to change the architecture of these neural nets. I mean, it's going to continue evolving and improving probably. You need to change the representation of the data so that the system knows the difference between opinions, what people say, and facts. Now, most of the facts are, we don't know the answer if it's true or false, but some we do. And then the others are going to be latent variables. So the whole thing here is what's called in the jargon a latent variable model. And it's trying to explain, for example, the opinions of people with latent variables that are their intentions and context and so on that may explain why they behave in this way. So there's a difference in the data. There's a difference in the fact that you not treat explicitly the difference between opinion and facts, not just in the data, but also in the model itself. And you also change the way it's trained. So the training objective is going to be such that there is no signal that comes through the neural net that would encourage it to become agentic. For example, if you were only to care about the accuracy of prediction, you might end up with a system that's going to try to make good predictions later and be willing to lie so that in the meantime, they would get more data, more compute, or make the world easier to predict. Right? So that would reduce future prediction errors. That would be very bad. We don't want that kind of AI, right?
So so just to build up on that, right now, everybody is talking about agentic frameworks, and everybody is talking about how we can build all kinds of things on top of these agentic frameworks.
Yes.
So, but what you are saying is extremely different from what...
Yeah, we have to take a step back.
Yeah.
But so first, you have to understand why is it that companies are investing so much in agentic AI? Because that's where they're going to make a lot of money by designing AI systems that can do the tasks that lots of people do. And of course, that's going to create a lot of social problems. But that's the motivation. Now, I'm not saying that we couldn't have safe agentic systems. In fact, what I'm saying is we could. But we have to step back and first build an AI that is really smart, but is completely trustworthy as a component for building eventually, if we really decide to do it, agentic systems. And I think, by the way, these choices should not be made by a handful of CEOs. They should be made as a social choice. Like, we should decide what we use AI for.
Thank you. So, again, I've also read the safety report from page to page.
You're one of the rare people.
And
I did it multiple times.
So, there are a couple of things in it that I kind of would like to get clarifications from you. Like, you've been such a great proponent of openness in science, right? But in this, I might be wrong and you could correct me, but in the safety report, what I seem to understand is that open systems are actually extremely unsafe compared to closed systems, and there seems to be some kind of a...
There's a tension.
Yeah.
Yes,
yeah.
I can explain why.
Yes, please.
Yeah. So yes, I'm a big fan of open science, of course. I'm a university professor, and my group wrote one of the first deep learning Python libraries, if not the first. And I think that science thrives on openness and sharing, of course. But think about if you knew how to build a virus that could kill half of the world population. Should you make that public if any Joe could, start a pandemic with this virus? These are like difficult ethical problems. Now, we are approaching a stage where AIs can help somebody without expertise to do these things. So last summer, both OpenAI and Anthropic, who have been running these kinds of tests of, how much can their AI system help somebody without biological expertise to build a bioweapon. And they cross the threshold of danger, according to these tests. So they reacted not by deciding to not deploy their models, but by putting some extra classifier, something that would try to detect whether the person is trying to use the AI in these illegal ways. And they deploy that, okay? And I don't know how good these protections are. But if they had deployed an open weight model, in other words, with the code, then in the code there would be some lines that say, don't respond when such and such conditions are met, and these lines could be commented out, right? So then anybody could do it. The problem is that there's like 3% of sociopaths on this planet, and some number of crazy people. So how do we manage the power that science or AI can bring to the world so that we can reap the benefits without creating massive destruction because of a few people? This is a very difficult problem. And how do we, going back to open weight models, well, I think the right strategy is evaluate the risks before you deploy. If the risks are not too large compared to the benefits, because clearly there are benefits to sharing, in particular in developing countries like here in India, then sure, yes, you should absolutely go open. But if you see that the risks cross a threshold of social acceptability, then you should not. So this way we might be able to get the benefits of open source when it makes sense, and we could prevent catastrophic uses otherwise.
So the other thing there is that how prepared do you think, like how good are these, safety controls in any case? Like forget about open source, but even for, like how good are they really? Because you get such different reports from who you talk to about this.
Well, that's a kind of not easy question. And the report is highlighting the fact that the risk management process has advanced in many ways. For example, there are twice as many companies that are now having at least some risk management process compared to last year in the companies building the frontier models. There's been a few legislations that came out. So in the EU, in California, New York, and so on. So we're starting to see push towards more transparency in the development and risk evaluation. But on the technical side, as I mentioned, we're now in a position where for the most advanced models, it's not even clear that we can do a reliable risk estimation. So yeah, we're making progress, but the capabilities of AI are going even faster than we can track. So there's something that needs to be done, I think, by governments, and it's going to have to be related to regulation, or some independent third parties need to be able to audit these systems and honestly decide that this is crossing a threshold.
So, but I think like governments, because of their particular geopolitical alignments, have very different views on how to govern all these things. So, but here we have like a crowd of people who are researchers. So for researchers, what do you think, where should their focus be? Because right now we see that everybody wants to build the biggest, the bestest model. So as researchers, how can we kind of be a little bit more futuristic about like how these things
Yeah.
are panning out?
Well, so the investment in making the AIs more capable, like smarter, is roughly in a ratio of 1,000 to 1 compared to the investment in research in safety. Like, how do we make it safer? How do we evaluate the risks? How do we manage the risks? And so, yeah, that's a place where researchers could really make a difference because they choose, to some extent, their research direction. Governments could also help funding research to make sure we can better understand the impact of AI in society. So I talked a little bit about the psychological effects. This was completely unexpected. Like a year ago, nobody would have thought that people, like so many people, would become emotionally attached to their AIs and AI companions, even the chatbots, and that it would change their life so dramatically. And so we need scientists to be like on the edge here of tracking the effect of AI on society so that we can raise the alarm to governments quickly.
Yeah, so I was, very recently in a room where people were discussing, how these chatbots, etc., are being used by children to provide emotional support, like you said, right? And there were a lot of organizations who were thinking about, like, how can we do this? And technically, nobody really had an answer, like how could we kind of support this other than just ban everything, right? So,
well, how do we do it in medicine, right? How do we do it with drugs? So before you're allowed to put out a medical treatment like a drug, you have to show through risk evaluation that it's not going to harm people. And we need to ask the same thing of these objects that we're building. But it's not happening. So if we, it's credible that it could actually help some people. But come on, companies need to demonstrate that it's going to help and not harm, just like we do for everything else, especially in medicine.
yes, even like food and,
Exactly.
all kinds of...
Everything has this kind of basic constraint that when you deploy something in the public, you can't do whatever you want that's going to make you money. You need to first show to an independent party, like representing the government, that your product is not going to be harmful. But there's no such thing right now. It's a scandal.
Yeah, and but it's also very difficult to convince most of the scientific community that's involved in, AI research right now about the necessity of, these kind of bodies or things. Most people have almost like a knee-jerk reaction to regulations or compliance, etc., etc., etc. And there is like a thinking that it somehow curbs innovation if you have like these, checks and balances in place. And I'm talking about I'm not even talking about the big companies. I'm actually talking about scientists who are working on these problems.
So first, there's a lot of propaganda about regulation. I've been involved in the Code of Practice of the EU AI Act. We worked for almost a year with civil society and the companies to make sure we would devise a set of guidelines that would not impose any kind of really strong new burden. In fact, what we asked the companies to do is what most of the leading companies are already doing, except it would be mandatory for all of them. And it would be transparent, so they would have to share that information with a regulator, right? So it is not really a burden. It's more that we're making sure that the whole class is behaving well, because you could have companies that are willing to, take a lot of risks. And also, the biggest risks, at least a lot of the risks we studied in the report, from malfunction, come from these most advanced models, and only very few companies are able to build those models anyway, and they have, they can have risk management teams. So yeah, I think the whole story is going to stop innovation. First of all of our industrial, sectors are regulated and didn't stop them. And second, in AI, most of the regulation, like in the EU AI Act, are really not affecting the small companies, the startups, and so on. They are affecting the really large companies that have billions to train those models.
That's true. So, but so in that case, like, you know, what would you ask us in the global South, the global majority, rest of the world? What do you think we should be focusing on here? Like, what should we be pushing for? Because, you know, frontier models are produced somewhere else.
Exactly.
And they're...
So what you need to do is get together with other countries and tell the governments of the US and China, which is where these models are built, that it is unacceptable that, you know, you will be potentially passive victims of things they build. It is unacceptable. We're transforming the world, and those decisions are taken by, you know, a few companies in a couple of countries, and everyone else is just, you know, passive victim potentially. So we should, like, take it to the highest diplomatic level that we can't go for that. And it's not just a question of, you know, morality or something. It's existential about the sovereignty that countries have, because you have to, I mean, one topic we didn't discuss here is concentration of power, which is related to this issue, right? So if AI capability continue to grow, there's a real possibility that there'll be a huge discrepancy, even more than there is now, between the models, let's say, in the US and China, and the models that are being developed in other countries. And that could give those two countries, or whoever is leading, huge economic power, but also political and military power. And the stability, the geopolitical stability that we've known since the Second World War could just go in flame. I'm not saying it's going to happen, but when you introduce so much power, and when it is concentrated in such a way, there's a real danger that you're going to break the house.
Yeah, so just changing tracks a little bit, you've been here for a couple of days, and hopefully you have visited India before as well. So hearing about all that's happening in India related to AI, if you could tell me, like, you know, what you think is extremely positive, and what do you think we should be very careful about, all the kind of AI buzz and innovation that's happening in India?
So when we develop technology, in order to do it in a way that's going to be the most helpful to people, we have to be mindful of the effects or the risks that are being taken that are going to affect society. And right now, I think there's a bit of conscious or unconscious blindness to the negatives, right? But in order to manage risk, we need to understand it. We need to understand it scientifically. We need to understand it socially, because there's a social component, psychologically in the case of AI, because we're talking about systems that interact with people in language, right? So a country like India could contribute to that understanding, and it doesn't preclude also developing, you know, the deployment of AI. Also, I'm going to repeat a sentence that my Prime Minister Mark Carney said in Davos a couple of weeks ago. If you're not at the table, you are on the menu.
I think that can be the quote of the day right now. So you're a professor. You've seen through many students, and right now the way we do research, like it's very difficult to advise students these days. What should they be focusing on? Because the old ways of doing research is gone. So what would you advise students?
Wait, what do you mean the old ways of doing research?
Well, you know, everybody wants papers in 2 months. Everybody wants to build something that they can, you know, put out in 6 months. So what would you advise students to do?
Well, I don't know, like deep learning took decades. And it took a will to go against the trends of the day. So you should listen to your heart and to your intuitions, even if it's not the popular thing, because that's how actual discoveries are happening. Also, it takes a kind of encouragement to explore, right, in academia. That's how we are successful. If we just try to copy each other, there's not going to be that much innovation. And by the way, the leading companies in AI, the frontier AI, they're all doing the same thing. It's incredible. Like there's one recipe and they're all doing the same thing. It's like in the space of research in AI, imagine this whole auditorium is, you know, all the things that we know about in machine learning, the machine learning literature, and what the companies are exploring is inside this glass.
Yes. Well, no comments on that from my side. I work for a company.
Sorry.
But I do worry. I do worry that we are becoming kind of narrow enough.
But companies could do it too, right?
Yeah.
I think the reason why companies are not doing it, for the most part, and there are exceptions, is commercial pressure, right? Because you want to be at the forefront, you want to compete, you want your model to be at least as good as the other guys within the next few weeks, right? And they're afraid that if they don't do it, they're going to lose their investment, lose their customers, and that pressure is killing us. It might kill us for real.
So is there anything in this, you know, this cycle that you feel a little bit optimistic about? No. Sorry.
Well, I'm optimistic that there is a solution to the alignment problem. So there is, in my opinion, a way to build AI that will not by itself harm people. But that doesn't solve the political problem because it can still be a tool for domination. And I'm much more skeptical about our ability to do politics, especially at the global level.
I agree with that. And thank you so much. We're at time. And it's been a pleasure talking to you. Thank you so much.
Requesting everybody to please be seated while the speaker leaves. Please be seated.
Please, आप लोग अपनी सीट पर ही रहिए जब तक प्रोफेसर योशुआ बेंजियो हॉल ना छोड़ दें.
Thank you so much to Professor Yoshua Bengio and Kalika for this wonderful session. We now take a break and there is a poster session now during the break. This poster session has posters from top papers that were published from Indian authors as well as authors from the Global South, as well as student posters. So I highly encourage all of you to check out the posters during the break. And we will be back at 2:15 and we have two panels at 2:15. One will be in this room and the other one will be in L1 meeting room 7. So we will see you back here at 2:10 so that we can start on time. Thank you.
good lunch and a strong coffee or a tea to keep you awake throughout after having good food. So we'll start our second half of the session. And here we have our second research dialogue on the next frontiers, grand challenges in the AI research. The panel will be moderated by Dr. Manish Gupta from Google Research. So Manish, please give a warm round of applause for Dr. Manish Gupta. And our esteemed panelists today are Sarah Hooker from, she's co-founder of Adoption Labs. Thank you, Sarah. Alice Oh, from the Korean Advanced Institute of Science and Technology. CV Jawahar from IIIT Hyderabad. Ramesh Raskar from MeitY. Surya Ganguly from Stanford. And last but not the least, Professor Subba Rao from Arizona State University. Thank you everyone for joining us. Dr. Manish, over to you.
Okay, good afternoon. It's such an honor to moderate this panel on research frontiers right after lunch, so we'll try to keep you awake. Let me start just to ground us all. I see a lot of diverse people coming with from diverse backgrounds. It's amazing to see so many people with that interest in AI. So just to ground us all, I will start with a few opening remarks in terms of where, how we look at the current frontiers in AI. Then I'm going to ask each of our panelists to share some of, to start with an opening statement of what are some of the challenges that they are excited about, some of the research challenges, and then we'll take it from there. So let's start with some history. Let's go back to ancient times, the year 2012, when artificial neural networks made a comeback, right? With, in fact, in those days, AI was a bad name. Artificial neural networks was a very bad name. But it made a comeback, and the new name was deep learning. There was AlexNet, right, which won the ImageNet competition. And soon after that breakthrough, what started happening was these deep learning based methods, they started becoming the best way of solving a very, very broad range of problems. So that was, in hindsight, quite amazing. I mean, I guess people like Jeff Hinton and so on, they always knew. But to the rest of the world, it was quite amazing. There was still something unsatisfying about that, right? Because while they were doing extremely well, they were still working well only on that narrow task that each model was trained on, right? And if you wanted to solve a different task, you had to train a new network from scratch. So now we are in this era of foundation models, right? Which are pre-trained on large volumes of data using the transformer architecture, the famous attention is all you need paper. And we have these models that have now much stronger capability on a very, very broad range of applications. And not just that, we are finding on so many problems, these foundation models actually do better than those specialized models that we used to build. So this is what is leading to now researchers giving them hope that yes, we are that holy grail, AGI, artificial general intelligence, where these models are doing better at cognitive tasks than humans. People are saying, oh, now it seems like a real possibility. So I think we are at such an interesting era, such an interesting time, where on one hand, these models are pretty much transforming the world. They're transforming the industry. These models are now, especially through these LLMs, through these chatbots, they are now in the hands of over 1 billion people on the planet, right, who have easy access to them through natural language interface. And again, today, it's not just earlier, it used to be like a bunch of researchers who used to meet at events like these. Now we are talking about presidents and prime ministers of country paying a lot of attention to AI. Look at this summit, 2.5 lakh people showing up for an AI summit. So that basically is showing, right, how much impact AI is having on the real world around us. And yet, as researchers, I think the amazing thing is there are so many exciting open problems. There are so many glaring weaknesses in these models, and we heard about some of them. I really enjoyed the talk by Yoshua Bengio. So many like open challenges. Some of the ones that, for instance, my team has been working on, efficiency, right? I mean, if you look at one thing which has happened as a result of the adoption of these models, you've seen kind of energy consumption throughout the world, right, shoot up. Ultimately, if we really want the world to be using these, we need to make these models dramatically more energy efficient. And we know headroom exists. I mean, if we do a back of the envelope, I mean, human brain does it at something like 20 watts. You shouldn't require so many, whatever, kilowatts or megawatts, right, to do better than human brain. So efficiency, then we have seen things like these models, there's a huge difference between these capabilities of these models on languages like English versus languages that, for instance, we speak in India, understanding of cultures. Then there is reasoning. On one hand, these models are reaching International Math Olympiad kind of gold medal level performance. And on the other hand, they fail at simple tasks that any of us in this room would be able to do with ease. And the list goes on and on. So what at least I find very, very exciting is, in particular, the potential for AI to not just like transform some of these really tough problems that we have faced as a nation. How do you provide good education to everyone? How do you provide decent healthcare to everyone? Not just some of these problems that we already kind of are excited about, care about, but also frontiers, right, in terms of AI for accelerating scientific discovery. So there is that potential for AI to help generate clean energy, help us find cures to all of those diseases. And that is what at least makes me ultimately so excited about working in this area. And earlier, for my team at Google DeepMind in India, our prototypical problem statement that I used to pose was, think about that girl, that poor laborer's daughter in the Chhattisgarh region of India. How do we make that girl have access to the same level of information as you and I, the privileged ones who kind of have the right tools, we understand English and so on? How do we make her able to access information at the same level in her native language? Now my ambitions for what we do for that girl are much higher. Now I want our team to be able to not just give her access to information, to be able to help her learn and ultimately solve problems that would be Nobel Prize worthy problems, because I think all of that is becoming possible. So with that, let me start with asking our esteemed panelists to make an opening statement about some of the work. And if you're okay, maybe we can start from people working on the low-level layers and go up to applications. So should we start with you, Surya? You're a neuroscientist, and you've been looking at, again, fundamentals of how these networks learn and many of these issues. Would love to hear your perspective.
Thanks. I was a little worried when you said low level that you jumped to me. So I'm at the bottom of the totem pole. But yeah, I mean, I agree with a lot of the stuff you said. I mean, these AI systems are incredible and also simultaneously weak in many different ways. They're poised to transform the economy, society, and even the nature of scientific research itself. Yet we have no understanding of how they work. So I actually view computational neuroscience trying to understand how nonlinear distributed circuits in the brain work and the science of AI, trying to understand how these nonlinear artificial neural circuits work, is sort of quite similar, and I kind of could go in between those two fields. We've been thinking about, for example, like diffusion models. A very basic thing is, where do they get their creativity from? How are they creating new images? We had some recent work that showed that it creates a patch mosaic of the training data. So when it constructs a new image, it takes a little patch of one training set image, puts it down, another patch puts it down, and so on. We actually turned what I just described into a differential equation that could predict what trained diffusion model spits out. These scaling laws for language models, right? Performance or error falls off as a power law with, say, the data set size. These have motivated significant societal investments in data, compute, and energy, and so forth. Yet we have had no theoretical understanding of how they work. In a paper that we just put out on the archive last week, we actually came up with the first theory of how an actual LLM scales with, say, data set size, and we showed that we could connect that exponent to the structure of natural language itself. So we're quite excited about that. But there's still orders of magnitude discrepancies between the capabilities of brains and machines. One is sample efficiency, right? We get about 100 million words. A human adult gets about 100 million words of experience. LLMs get about 10 trillion words of experience. If we were to read everything an LLM read, it would take us 240,000 years to read it. So even though the LLM at the end of the day can do these amazing things, it's much more data hungry than we are. Where does that efficiency come from? I think it has a lot to do with a lot of things that humans do that these AI systems don't do. Sort of curriculum learning, active learning, careful data curation, and many other things. Energy efficiency is something that we talked about. Unfortunately, there I think it's a more difficult question. We've been, the reason our AI systems are so energy inefficient is because we went to digital computation itself. That's where we made the cardinal sin of computation. That might sound a little weird after Shannon and Turing, but we made a huge mistake when we went to bits. It got us to where we are today, but by relying on fast, efficient bit flips, many of them at once, we spend a lot of energy because every fast and reliable bit flip by the second law of thermodynamics demands energy expenditure. Biological systems do it completely differently. They're slow, they're noisy, they're unreliable, but the final answer is just good enough. That slow unreliability seems like a bad design, but actually it's a feature, not a bug. It's a feature of highly energy efficient computation. And I think we need to go completely back to the drawing board and rethink our entire stack from electrons to algorithms to go to more energy efficient computation, including analog computing, maybe photonic computing, and so forth. We've been thinking about fundamental limits on the energy accuracy and speed of chemical computation, for example, and we have some results on that. The modularity of the brain is also something quite incredible. It's been conserved across 500 million years of vertebrate brain evolution. We just create these end-to-end big transformers. And I think part of the reason for their data inefficiency is because they don't have the right modularity. They haven't parcellated the learning problem into learnable, decomposable subproblems. And I think what 500 million years of vertebrate brain evolution did is it figured out those interesting subproblems and had independent modular learning to deal with that. And we don't even have the beginning of the design principles to understand that. My last grant application was to try to go after that. Yeah, I'll stop here, actually.
Thanks, Surya. So let me, let me turn to Rao, who's been studying, again, the fundamental mechanisms of planning, reasoning. He's been a critic, if you may say so, of LLMs. So would love to hear about your views. And I think while your bio comes up on the screen, maybe one spicy fact that I was sharing with Rao. The first time I saw him was when he was delivering this presidential address. He was the president of AAAI. At AAAI conference, he was delivering this presidential address of how, as president, he drove and accomplished the mission of making AI great again. So the reason AI has become such a phenomena is we can owe it to Rao and the success he had. And let's hear from him.
Thank you, Manish. So it's mission accomplished already, I guess. So first of all, thanks for inviting me to this AI Kumbh Mela. I've started calling this. I haven't been to the real Kumbh Mela, but I think this one is just as religious, except for the AI gods. So I have been in AI for quite a while. In fact, I believe New York Times a couple of weeks back said, I've been in AI almost as long as Yann LeCun. So as I guess recognitions of senility go, that's probably quite the high honor, don't you think, Yann? I'm sorry for pulling up your age. You're all very young people. Let me just start by saying that the AI systems that we currently have. So first of all, AI sort of became one thing, which is most of you are thinking in terms of LLMs and VLMs. And I would like us to think, for example, that they are actually an amazing 21st century reset of expert systems. You know, the expert systems where we wanted to tell them what we know and they'll do some reasoning for us. They were very brittle. It's fun to make fun of them because we had to tell them what to do. What happened with the LLMs is these are broad and shallow expert systems whose knowledge is available because we wrote it all like silly folks on the web. We just wrote everything for each other on the web. And as I keep telling people, had Sam Altman put together all his GPUs from some Jensen Huang and he said, I just need data, guys. Why don't you guys write everything you know onto the web? He would have gotten screwed. Nobody would do that. We did it for each other, and then that became the fodder for the LLMs. And so they became a very interesting kind of expert systems. The one advantage is that you're not telling them anything separately. You're writing them in your natural mode of communication. But then they really are expert systems at a certain level of understanding because they're actually both our declarative knowledge as well as our procedural knowledge. In fact, the more recent improvements in reasoning models can be thought of as essentially using what we have written as simulators and verifiers in the post-training phase to slowly, ever so slowly, compile this into the generator. This is an amazing feat, especially if Sam Altman is paying for it and we are only going to pay for tokens. And this is amazing that we have this technology in front of us. As much as this is great, the things that are interesting is that engineering of these models has far outstripped the understanding of these models. What are they doing? And we, in AI have always made anthropomorphization sins. We basically try to look at even ELIZA, the dumb pattern recognition system, and think it is actually talking to us in, like thoughtful language. And so it's not surprising to us that we anthropomorphize LLMs. They are certainly very, very impressive. But as scientists, we need to understand not only what are they capable of doing, but what their limitations are. Being skeptical is nothing to be sort of feeling sad about or feeling ashamed about. Scientists are supposed to be skeptical. Skepticism is the inductive bias for good science to some extent. So to some extent, what we've been doing in our work, so for example, these things, as somebody has pointed out, we have these systems which can do amazingly at the Terence Tao level on math Olympiads, but apparently fail really badly on things like Amazon sent me a left shoe instead of a right shoe and a right shoe instead of a left shoe. What should I do? And it'll give you a long plan to send those shoes back. This doesn't make sense. Even Terence Tao would never make such a mistake. And if people ever make those kinds of mistakes, we lose trust in them. So the interesting thing becomes understanding this sort of a jagged intelligence of these artifacts that we have developed and figuring out what they are and are unable to do. And one other thing that we are very interested in of late is the reasoning models do a lot of mumbling before providing the answer. And this has been anthropomorphized into saying the model is telling us what it is thinking about. And the model essentially imitates everything. And so you don't think it's not going to imitate even the stuff that we might have said in mumbling. And so we actually did experiments to show that these things don't need to have any meaning. They still help LLMs, but they don't necessarily have to have any meaning for humans. The reason we need to understand this is not because this will have a big impact on the bottom line of Sam Altman, but because we don't want powerful AI technologies to actually be weaponized against our own cognitive flaws. And so we want to understand what are they actually able to do, what are they not able to do. And that's sort of my research, and hopefully I will spend more time explaining to you a little later about some of the issues about reasoning and so on. Thank you.
If I may ask Sarah to share some of the exciting challenges that you have taken on recently.
Oh, fantastic. I do completely agree that the role of a scientist should be to be slightly grumpy about everything and slightly cynical. It's the path of discovery. So it's lovely to be here. I thought it was very interesting how we started out going back to 2012. I think it's very striking how you view this question of where we are. I often think it's interesting to think how short an amount of time has happened with modern computer science. Like, modern computer science as a discipline is only really 70, 75 years old, starting after World War II. And depending on how you feel about technology, you may feel optimistic about that or slightly terrified. But it's fascinating because our memory has become compressed to 2012 to now. And throughout my career, and I've been at different frontier labs, I think it's worthwhile placing questions in context because it drives what we decide to work on, and time is our most precious resource. There's a few things I've been thinking about. One is that 2012 was really a fluke between an algorithm and hardware. So it worked because GPUs, which were designed for video games, just happened to be very good at accelerating deep neural networks. And it's interesting. Science and progress is often a combination of the right positioning over many decades and then the right ability to translate it to empirical results. What that prompted was, frankly, the frenzy of scaling. I think we've already managed to mention GPUs or compute several times in this panel, and we're only 10 or so minutes in, so let's see how far we can go. But the two tales are intertwined. So if you think about what the last 15 years has been, it's been a very simple formula and very painful one. We throw compute at the problem, and the question I'll pose today is why? Frankly, because it was a very persuasive formula. We've been stuck, you know, we're a very prestigious group of researchers on this stage, but we've been stuck in our own version of what happened to hardware researchers, Moore's Law, just throw more GPUs at the problem. And that's because it proved empirically successful. We've already had scaling laws dropped today. I disagree with scaling laws, but that's okay. I just think that they don't particularly hold outside a given architecture. Nothing done on convolutional neural networks would transfer to now. But there's a whole group of researchers who this is their church. They want to scale, and no matter what. And it's worthwhile thinking, well, what do we get when we go bigger? Arguably, there's some counterpoints, which are quite fun to think about. One is that we increasingly have small models outcompeting large. But the second is the following, is that we pay a lot to get extra performance. We have this decreasing returns. Deep neural networks are really, they learn the average pattern, not the long tail. And most of what we do, I mean, even this example of returning your shoes, of being able to navigate the world, is about the long tail. So we have a very inefficient algorithm to learn the long tail. So what I'll throw out there today, the most pivotal moment that we are in, is that firstly, this trend of throwing computer at the problem no longer works as well, which is fun for everyone in this room because it means research is fun again. So scaling transformers are largely saturated as an architecture. There's going to be some frontier labs which double the size this year, but no one's going to quadruple the size. We have decreasing returns. That means what's interesting is, I would say, three things. One is we do have very exciting developments where we can now shape data. So data is now malleable. For most of computer science history, it was static, expensive to collect. Once you had it, you were stuck with it. That's why we spent so long. MNIST, thank you to Yann. I'll give a shout out there. We spent so long with ImageNet because these were these were really so expensive and difficult to collect. Now we have the ability to optimize and shape the data space, which makes it much more malleable. The second thing I'll say is we have the ability to interact with the world. And that's where the essence of where I think progress is going to be interesting. How do you create a model that learns from the world and continues to evolve with it? And that's the thing that I'm most focused on right now, because I feel like it's so critical to creating more dynamic models. But the third thing that I'll throw out there is that compute has shifted from pre-training, because the architecture is saturated, to much more nimble types of compute. Why is this optimistic? Because the focus on just scaling for a decade largely meant that it was concentrated in a few labs and a few parts in the world. The shift towards test time scaling to more dynamic types of compute, efficiency has been mentioned several times. This is a way more interesting dynamic because it means all bets are off and innovation can happen in many places. So I find that very interesting to think about as well. So with that, I think my summary statement is the slow death of scaling is here, and we can't just throw GPUs at transformer pre-train anymore, but that makes life fun again. And I think that's what's interesting to talk about today.
And certainly, in this part of the world, we worry a lot about how to make AI work for everyone. And I know several researchers here who've been worrying about the same issue, working on many of those issues. One of them is Professor Alice O, so I'm going to ask her to share some of the challenges that she is working on, because she's been working on how to make these models understand many more languages, many more cultures, and so on.
Yeah. So when you started this panel by going back to 2012, I'm going to go back to, let's say, like 600 AD, right? So more than, I don't know, 1,400 years ago. Because one of the things that we did, my students did, is actually collect data from like the 7th century all to 2025 within the Korean peninsula, which is where I am from. So these are historical documents. And I'm sure it's the same in India, it's the same everywhere in the world. Language evolves. So written language in Korea started with the ancient Chinese characters, which are somewhat different from the modern Chinese characters. But then the language in Korea was different from Chinese, because they had their own language. And then the writing system changed to the modern Korean, or sort of close to modern Korean writing in the 15th century. And then like the mixture of Chinese characters and Korean characters happened for several hundred years. And then the Japanese colonial period happened, and so we have documents written in Japanese. And then now we have, in the last 100 years or 70 years or so, we have North Korea and South Korea, and the language in North Korea has also evolved to be slightly different from South Korea. And so this evolution of language and looking at the history in our country through these, we collected about 17 million documents to be used to train a language model based on these different languages that capture the history of Korea, right? So the reason I'm saying all this stuff and how that sort of gets us back into the diversity of languages and culture and all of that is that when I looked at these historical documents, it made me realize how it's important to capture the different perspectives in written documents, right? So, 700 AD, when only the very highly educated Koreans were writing in these very difficult Chinese characters, only their perspectives were preserved in our historical documents. That's all we see. And then the modern Korean writing system, when it was developed, it was the literature people, or like the common artists, I guess, who are writing poems, and also some of the women who were writing these personal correspondence using the easier Korean writing system, which at the time was sort of looked upon as like the less educated people. So anyway, so we have those documents. And then, you know, what we're sort of projecting into the future, right? So we have these LLMs, which makes it very inexpensive to create and generate so much written data now. Like I can, you know, in 10 seconds, I can write 10 pages, right? But what perspectives are we capturing? What are we leaving as, you know, what is going to be historical data about 2026, right? So all of these LLMs generating stuff, like, you know, research papers, books, whatever, whose perspectives are we capturing? What languages are LLMs capable of generating fluently, and also about the topics that the LLMs are good at generating? So that question makes me very concerned, because we know that among the thousands of languages that we have that people are speaking, only, let's say, about 50 of them are captured by LLMs. And you know, and even among the 50, it's probably about a dozen or so languages that, you know, when you try to generate language, these, you know, documents about different expertise topics, that these LLMs are able to generate fluent documents, right? And even in those 12 languages, it's probably only, I don't know, like 10% of the topics that we're actually interested in this world that are being generated. So we all should be concerned about this.
Thanks for bringing up these very important points. And if I could make a shameless plug to my own team's work, there's this project Vani, where we started collecting speech data from the different corners of India. And already with the data that we have made freely available, it covers 109 Indian languages, of which for 59, this is the first ever recorded digital data. And there are 8 languages that we uncovered in this process, which aren't even mentioned in the last language survey of India. So there's such amazing diversity of languages that we speak. And now, complementing some of our NLP experts, we have 2 amazing vision experts. So let me start with one. I mean, people say, what's in a name? But if you were to look at C.V. Jawahar's name, you would say he was destined to be this computer vision, both not just a researcher. There are generations of computer vision researchers out of India who've been trained by C.V. Jawahar. So let's hear from Jawahar.
Thank you, Manish, for the nice introduction. Rahul, did you say this Kumbh Mela is not religious?
What?
This is not religious? Is it so? I thought, sure? So I'm not sure whether where we are today, in the AI era today, are we religious or are we even fanatic? So where we are today, I think the long, short history of AI that came multiple times into the conversation in the last few minutes. Let me also start the thread from 2012. And 2012, the story starts, and then if you look at, soon we move to a model where we want to use these pre-trained models. Not everybody need to know. And we always wanted to hide behind pre-trained model or make our life easy, and that was good enough, zero shot, and all these today's popular terminologies came into it. And what we see is far more sophisticated solutions. I'm really excited about the opportunities that today's AI has opened up, particularly for India. I would like to look at AI as not as artificial intelligence, it has advantage India. In what form? So we look at this as the AI for us, unfortunately, is only LLMs. There's only one definition for LLM. And if you look at there are many broad themes that we silently we're keeping aside, possibly for the sake of marketing, possibly the sake of selling it easy to VCs, to the media. So there are three basic things that we can always see. One is problems. Second, data. Third is models. If you look at the 1 and 2, I think there is no country superior to India. Having problems, original problems, not borrowed problems, we don't have to mimic or go behind somebody else's problems. We have original problems, we have original data. Unfortunately, we are behind this bandwagon of we want to have that model. So we need to understand our strength and we need to play according to our strength and the needs. This is very important. So are we looking for solutions that are going to replace humans? We are not short of humans too. So while the opportunities that we got, we need to know, and we need to know how to pursue that. So I'm not saying that, okay, look, the existing threats are not possibly the right thing for India. There are a number of possible opportunities in front of us, which very often we are all blind of. Because we don't look around for looking problems in our society. We look media, we look Twitters, and the students do literature survey from the Twitter. That's the way to do. The world has changed now. So in this era, now what AI has done good, another way to look at it. So I used to say that, okay, look, in the few years back, I was happy that AI has changed one major thing. It has democratized the research. Because when the codes, the models became public, everybody can do. So it was very easy for anybody. Entry barrier came down significantly. You just need to know only Python. You don't have to know domain, you don't have to know science, you don't have to know anything. You just need to know Python and at best have some GPUs. That was enough for us to entry. And this good or bad, it was also, in some form it is also good because the problem formulation has a structure which is easy to replicate into newer areas. It is easy for the community to get into and solve problems. But unfortunately, possibly today we are the opposite end. The democratization has moved to centralization. We also need to worry about what could be the implications of today's large centralization. What is the status of the countries? Where are we becoming AI colonies? And to many other questions that we need to ask ourselves, along with the safety issues that we have already seen in the morning discussions. That's all, thank you.
Okay, last but not the least, let's hear from another eminent vision researcher, a visionary, Ramesh Raskar.
Well, I don't have CV in my name, so I'm free to explore other areas of research. So and Jawahar hinted at the centralization versus decentralization. If we think about what's happening today, is we're centralizing data, centralizing compute, $100 million salaries, nuclear power plants. Things are a little bit crazy out there in the AI world. But this is what we thought in the mainframe era as well, in the 70s and 80s, where IBM and DEC and supercomputers, it was all about that. But people like Bill and Steve said, no, there could be a PC on every desktop, and that changed the game. Highly decentralized compute, we had it at our home. And then soon after that, Tim Berners-Lee said, actually the PCs are great, but what's even more exciting is if you connect those PCs, and so you converted the internet into the World Wide Web. And the same thing is about to happen now. We are in I would call the factory era of AI, where only certain entities can create, manufacture AI, and every one of us is just downstream using it. But very quickly, we're going to switch to the bazaar era, of AI, where every one of us can create our own micro AIs. We can call them agents if you want, our own agents that are trained by ourselves with our own data that remains completely with us, runs on our own device. And then we need another Tim Berners-Lee kind of a moment where we figure out how do we create the internet of all these AIs. And how many people are keeping track of OpenClaw and MaltBot and so on? Okay, all right, so that's good. So I don't know how to explain this anymore. For the last 10 years of my research at MIT, I've been trying to explain this, but I think we should give credit to OpenClaw for making that evangelization much easier. So now if every one of us has our own agent, our own micro AI that's running on our own data, doing things for ourselves and under our own control, then what does it mean to build the internet? What does it mean to build the network of it? I think there are three main research areas that come out of it. One is the foundation. How do we make sure that every agent has its own identity, its own trust, is discoverable, there's some kind of a DNS, and we have former director of Rod sitting here of ICANN. So we need a new ICANN for this. So that's kind of the foundation. The second research problem is we have to realize that these agents are also be part of the economy. So we're going to have this agent commerce where my agent and Surya's agent might be trying to bid for the same work, and maybe I bid I don't know, $10. Surya is a fancy professor from Stanford, so you might say $100, but why? Why is it 100 versus 10? So the research problem there is knowledge pricing. How do you price AI model? And that itself is another machine learning problem. Because the agents are going to create their own stock markets, their own banks. Unfortunately, they'll also create their own casinos. And there's going to be an amazing ecosystem for commerce that emerges from that. They'll do collective bargaining, they'll start their own companies, and so on. So that's the agent commerce. That's the second area. And the third area is agentic societies. As you heard about Malt book, agents are creating their own religion and so on. It's a bit fake because it's prompted by humans. So if you ignore the hype around it, very soon we'll be in a scenario where, I will say to Surya, hey, I need to send my agent to a better school because I also want to make as much money as your agent. So I might send my agent to an IIT of agents, right? So there'll be agent universities, right? At some point, my agent will start creating teams with other people, and they'll be listed on stock market. But at some point, my agent will do mistakes, so I need to buy an agent insurance. To resolve that, there'll be agent justice systems and so on. So you can imagine, and very soon, when people get frustrated, they'll have to start their own religion as well. And they'll all go to Kumbh Mela. So the main research problem we have to solve in the agentic society is what we call co-learning, which is how can two agents, two small AI models learn from each other? Just the same way while we are on the stage and we are here, there are two main ways we have been taught how machine learning systems work. One is through data, and the second is through experiences, if you're a fan of reinforcement learning. But there's a third way we are learning from each other, which is just insights. We're just chatting and learning from each other with very little data. And so the problem we are solving at MIT is co-learning. How can two models learn from each other, even if they have completely different topologies? If you heard about federated learning or split learning from our group, those work when the topology, the compute graph is identical, so you can do some kind of averages on their model weights. But co-learning is a whole new problem. So I would say that there's three areas for research. How do you create agentic foundations? How do you create agentic commerce by creating knowledge pricing? And then how to create agentic societies where there's co-learning. Those are the three main research areas. And then very briefly, I'm in India because we have been encouraged by Mr. Vaishnav, Minister Vaishnav, and Mr. Abhishek Singh, and Mr. Safiullah on thinking about what does democratization really mean. And Jawahar talked about the risks that if that doesn't happen. So everybody here has an Aadhaar number or a social security number. Everybody has an email address. Everybody has a phone number. What if every one of us has their own personal AI agent? So that project is called Doot, which means messenger in Hindi and Sanskrit. And so the effort for Doot is like a layer above Aadhaar, UPI, ONDC, and so on to create an agentic framework for India. Thank you.
So you've already seen a lot of references to Kumbh Mela, religion, and so on. And if you are familiar with AI at all, right, one of our religions is AGI, right? Artificial, which has been the holy grail. How do we get these AI models, right, to do better than humans at every cognitive task, right? So not just one narrow task. So I'm going to do a lightning round where I'd like to ask...
That's a mock.
Yes, like to ask each of them, when do you think we will be reaching AGI? And of course, you can say never, but each of you, quick. Let's start with you, Jawahar.
Quite far. And I don't think I'll be there to see that. I'm happy. Yeah, I think it is. We also have to understand what is AGI. Today, possibly for us, is more of a dream goal. Today, we have far better understanding of what AGI should be than what we had 5 years back, 10 years back. Okay. And that does not mean that we are going to reach in any near future.
Okay. Alice?
I think we don't really have a good definition, and I think actually several definitions are sort of mixed. So we have AI where, like doing medical data, like diagnostics, looking at X-ray data and stuff like that, where I think we've already surpassed human capabilities, right? And then we have things like social reasoning, where AI just does not work and is going to take a long time before AI figures out how people have feelings and things like that.
So for clarification, you could go with, let's say, Shane and Demis's definition, where for every cognitive task, right, it should do better.
Right.
So let's go with that definition.
Okay, so including social stuff and all of these affective and that kind of intelligence, I think that I'm going to make the prediction like 25 years from now where we figure out everything.
Okay. Rao?
I think I saw AGI on the way back from lunch. So I don't think AGI is a thing. It's a brand gimmick, and it's basically achieved whenever Sam Altman said it achieved, I guess. So we need to be very, very. We are scientists here. For the longest time, I used to think people who talk about AGI are crackpots, but apparently we are all crackpots right now. Human intelligence is actually the ability to handle open worlds and novelty, not just showing superhuman abilities on well-trodden tasks with reams and reams and reams of data. For example, I'm pretty sure that computers will solve Riemann hypothesis once we upload a few proofs of Riemann hypothesis onto the web already. The other thing that I find very funny is because of this, there is this stuff like humanity's last exam, and the barometer is increasing every time, and I'm supposed to feel, my God, we are all our last exam. Humanity has no static last exam, guys. If your ancestors had a humanity's last exam, that is nothing like the one you have. That's nothing like the one your kids will have. The whole point of humanity is able to dealing with open worlds and asking questions that we haven't even thought of asking. So now you tell me what AGI is that you're talking about, and I would say there's no point about that.
Rao, in India, where J1 ranker is viewed as like equivalent to a Nobel Prize winner, you are minimizing the importance of exam. You
always minimize the importance of exams.
Thanks for being so courageous. So, Sarah?
Yeah, I think I captured it well. I'll only add one thing. I think also, the quest for AGI is actually very related to how AI started. This idea that you impart to machines skills reserved for humans. But there's two things wrong with that, right? We did that because our lens of progress is our own view of the world. But to be honest, it's not clear that human intelligence is the only thing. We have shortcomings. Our intelligence is much more global than it is individual, which means we typically all agree at the same time to do certain things. This is very effective. It's a very cheap way of learning. But it also means we're very good at some things and not good at others. We're actually not particularly good at math, even though I guess probably most people on this stage enjoy math. But like as a distribution, it's something we find challenging. We're not good at reading and walking. We find it much easier to walk and talk. So our pathways have been really optimized for certain things. And the idea that we're just imparting this to a model, it seems it's limiting. And I think it's frankly interesting because there's some things that our models already do way better than humans. Our models are probably going to be much better at mathematics than us because we're not particularly good at sequential processing. And I think there's other things like that. The other thing I'll say is, the reason why I think a lot of the people on this stage find it cheap and find it that maybe it strips a lot of the work that we care about is that nothing is binary. And the idea that something is AGI is essentially a statement that we will, one day, instantaneously, we will be in a different era. It's a very good rallying call when you need to force a certain precision or focus, I guess, from people. It's a good cult movement. But I think it's most people who work on this realize that most progress is very small and happens gradually. And then in some ways, models are much better at us than some things and others. And so I think that's worth thinking about because it certainly has manipulated a lot of our ecosystem. And the fact that we're being asked this on the stage is a sign of how successful it has been at forcing this conversation repeatedly over the last few years. But I don't think it's a particularly precise conversation. And for most people, it doesn't really matter because what matters to them is, does this technology work for me today? Not whether, someday on the future will AGI arrive.
Thanks, Sarah. And Surya?
Yeah, let me argue from analogy from a paper that we just did that's not in the archive yet, but like...
I thought you were about to argue for AGI, and I was...
No,
Are you?
I don't know where...
That would be fun.
I'm going to start on a journey, and we'll see where we end up, all right? So here's a friendly reminder again that adversarial examples have not been solved. Like, should an AGI be robust to adversarial examples? I think so, right? And why haven't they been solved? So we just asked a very basic question. Very simple, like CFAR 10 images, they're 3,072 dimensional, right, images, right? Just what is the space of images, the dimensionality of the space of images that a network thinks is a cat with high probability? So I've told you the ambient dimension, 3,072. Does someone want to just venture a guess as to what? Oh, just another reference. The set of natural images that are cats is about 20 dimensional. So there's a big gap between 3,072 and 20, right? What is the dimensionality of the space of images that a ResNet thinks is a cat? I.e. the set of images that it outputs high probability of being a cat. What do you think it is? Does someone want to shout out a number? Huh? 100? Okay, interesting. It can't be because the upper bound is 3,072. That's the ambient space. Any other guesses? No, it's not the upper bound. But, okay, it's 3,000 actually.
It's very close.
Okay, great. Okay, good. Okay, so there's a 3,000 dimensional space of images that the network thinks is a cat, and we don't think is a cat. Because volume grows exponentially with dimension, this is exponential misalignment. There are exponentially many images that the network thinks is a cat that we don't think is a cat, okay? Why is that? It's because we showed the system a bunch of cats, and it learned very well to classify natural images as a cat. But we didn't tell the network this random noise image is not a cat, or this random noise image is not a cat, or this random noise image is not a cat. We didn't teach it that. We didn't whack the cat probability down in all the places where there are no cats, right? And I think that's what's happening when we train these AI systems, right? We're throwing it tons of data, and it's doing some kind of interpolation or so forth. It gets even muddier if we're now putting in a logical verifier, say in mathematics, and then doing RL on traces like that. But we're basically like playing a game of whack-a-mole, right? Like we're teaching it to solve this problem, this problem, this problem, and so on. But it's not really like solving or learning the general algorithm, right? This is radical generalization. Like one of the most radical pieces of generalization is, I think, what Einstein did when he equated gravity with the curvature of space and time, starting from thought experiments of a person falling in an elevator in outer space, right? The equivalence principle. That's radical generalization that goes far beyond anything that was understood at the time. Like, I don't think we have anything like that at the moment in AI. And I would say we won't have AGI unless we have an Einstein-level AI.
Thanks. Ramesh?
my friend Abhi said that AGI was a brilliant pitch deck.
Yeah.
It's a great way to raise money, great way to create this hype that whichever is the first company to get to it, assuming fast takeoff, is the only company worth investing in. So it has worked really well as a pitch deck. And now others are saying, okay, that pitch deck doesn't work anymore. So let's use AGI for robotics, or AGI for world models, or AGI for health, whatever it takes. So it's a great pitch deck. And that it does really create distraction. I should also say that our group was the first group to write a paper for AutoML for neural architecture search in 2014. So we did contribute to this craziness a little bit in the beginning. Kind of machine learning models that design better machine learning models. That was one of the most cited papers from us. So there is some excitement about how systems can design itself and move faster. But if you've seen the recent interview of Ilya from Dwarkesh Patel, he basically, you don't have to watch the whole 2-hour episode, he basically said, it's not about learning, it's about learning about learning. That means we cannot create a machine that can learn everything. The best we can do is create a machine that can learn about new forms of learning. And that's because, Manish, the best AGI doesn't know what you had for breakfast, right? So there's no way, it's not omnipotent, it's not omnipresent, because it doesn't know what's happening right now. So if you don't have data about what's happening right now, or what happened this morning, how can a model do anything for you, right? So the way it's being solved is actually decentralization. We started with this amazing concept that if you learn from 10 trillion, words, you can get close to it. But then what everyone's realizing is actually what's better is to create, some kind of a mixture of experts, And this goes back to, Marvin Minsky and Society of the Mind, which is, the brain is not this one monolithic machine, but it's made up of different societies, different components that work together to create this emergent intelligence. And then these big companies are saying, actually, even that's not enough. Let's get into reasoning and planning, which means, again, subdivide the task, one for sports, one for math, one for coding, and so on. Let's solve that together. So we are already on this slippery slope of realizing that there's no one big model that can solve everything. All has to be componentized, has to be divided into components and so on. So the best if you play that clock forward, what we're talking about is there'll be 8 billion agents, the society of agents, and that is going to create the best emergent intelligence, not only as an antidote to AGI and some kind of a super intelligence, but actually it will be even more democratic, it'll create more shared prosperity and mental the middle class.
Okay, good. So I think at least we did get some of that differences of opinion and so on that we were hoping for. But I think one area where probably we do agree is that there's certainly a lot of progress that we are making as a field. So let's just, and since again this panel is all about research challenges and the frontier and so on, we've talked about now, we've talked about the future, let's maybe pick a concrete point. I don't know, 4 years from now, 5 years from, or whatever, 10 years, let's pick 2030, right? Roughly 4 years from now. Love to get your views, right, on what are some of the exciting research challenges, right, that you think you would be working on in the year 2030. So maybe let me start with you, Alice. What are some of those problems, right, that you would be working on to make, let's say, AI work for all of humanity?
Yeah, it's a really very, very challenging problem. To say, let's say, I said earlier, there are thousands of languages and thousands of cultures. It's hard to say there's one culture. There's not one single culture for India, for example. There's not a single culture for Korea. But, languages and culture are important for LLMs to be deployed to everybody in the world such that they are doing something beneficial to help these individuals in some way, right? So we can think about education, we can think about better healthcare, we can think about, just better, improving your work. So those are sort of examples of benefits of using LLMs or VLMs or these AI models. So So then, if we want to make this technology work for people around the world, let's say the languages that all the hundreds of languages being spoken in India, right? So there's obviously a big data problem. You, of course, collected all this data. But then what about other languages for which there isn't enough data? Like Indonesia, for example, is another country where they have like 200 languages. There's no way like this can scale, right? We can't possibly collect data for thousands of languages, especially because these large, what are called frontier models, these transformer-based language models, are so data hungry. And if you can't just feed, I don't know, like Reddit or Wikipedia, that's obviously not enough. You need, a lot more variety of different types of data for these models to work, as well as they do for languages like English and Chinese. So it's really not scalable to try to collect data for these low resource languages. So then what do people do? They generate data, right? So you have these synthetic data, but it's like this problem of, rich get richer and poor get poorer. These languages for which the LLMs are very good, English, Chinese, French, Spanish, the generated data are also good. So then, you have this positive reinforcing loop. But then for the languages that are low resource, the LLMs are not good. So when you try to use the LLM to generate data, it just comes out to be garbage. So then you just have garbage, creating more garbage. So then in the end, it just does not work, right? So then what's the solution? I mean, we don't really have a good sort of single solution to solve all of this. But I am very excited because we have people like Manish, and we also have communities of researchers who are going out there and trying to solve this, many language, many culture problem. So I think, because I'm at a university and I teach students who also come from different backgrounds, it's very important to recruit students who are interested in different cultures, different languages, different use cases, different types of users, so that they are educated about how to build AI, and they go out and do research and development of AI for whoever that they're most interested in. So the community of researchers is one solution.
Sure, no, and the problem you described is very real. And again, if I were to make a shameless plug, I see Bidisha in the audience. She and some of her colleagues, they've done some very exciting work on transfer, on the mechanism of transfer that happens from one language to that tail language, which seems to suggest that it's mostly a problem of variance, not bias. Which is an easier problem to solve. Some very exciting things happening. Yeah. But let's just quickly run through maybe some more examples of research challenges that people are excited about. So maybe Sarah, if I can ask you about, okay, are there problems that we aren't even thinking about that are going to come up in 2030?
Maybe I'll say two things. One is I think I spoke earlier about what I'm interested in right now, which is that I think the most intelligent system will be one that interacts, and so I care a great deal about that right now, and also how do you adapt efficiently to very different distributions. Most of my work has actually been closer, and Alice and I have collaborated a lot of times. The reason why I really care deeply about multilingual, it's one of the most vivid examples of this. How do you efficiently represent a language in a way that is actually comprehensive? There's a curse of multilinguality, which is that the more languages you try to cover, there's a tension. How do we use capacity in a more meaningful way? So I've spoken about that. I think what I'll speak about that maybe is interesting to this is I want to speak about the ecosystem, because the research doesn't happen in a vacuum. Typically, innovation is about the people, what is led up to that, as well as a spark of combining insights in interesting ways. A lot of the last decade has been a tightening of the ecosystem. A few labs and a rarefied group of people who builds this technology. And a lot of that has been because of the capital expenditure needed to participate. You kind of need, the entry cost is high. I think what I'm most interested in is, in parallel, there's been a widening of who is excited and the talent pool coming in. So actually, Manish, you talked about this at the very beginning. Anyone with Python can get going. I truly think that's been one of the most exciting movements of like what we've seen. And I actually think these two are coinciding more. When I first started research, the idea that someone without a PhD could be a research scientist was, it was almost unheard of, especially at some of the institutions represented on the stage. And so we had this rite of passage that was demanded of the people. It was more of a tutelage, apprenticeship. And now I see that there's very much a democratizing impact, an intensity to talent. If you care deeply and you push into this field, there is much more access at the lower layers. What we need to do is think about access to particularly compute and dynamics of like ecosystem building at the frontier of what's possible. And that dynamic I don't think gets talked about enough, because the frontier of the possible still remains fairly concentrated. There's still a small group. And I think if we look forward in 4 years, someone was asking me, what am I hopeful for the summit? I said, I always judge a summit 6 months later. But there's a reason. I think the thing I'm most excited about is the commitments to really build the ecosystem, because this is the dynamic that is most interesting. How do we do serious, ambitious commitments to building ecosystems for innovation? That over the next 4 years, I see much more ability to have more global conversations about that. Certainly compared to, a mere 2 years ago at Bletchley Park, I think the conversation about global dynamics and where innovation was happening was simply not present on any stage. And so already I feel like there's been interesting progress there. Who should I pass it to?
Thanks. And so Ramesh, I was very curious. What would be all those billions of agents that are also connected on this new World Wide Web? What would they be up to in 2030?
Well, as I said, they want to go to Kumbh Mela. So imagine, the Sitabai, lives in rural Bihar, and she wants to go to the next Kumbh Mela, which is happening in Nasik, where I'm from. Anybody here from Nasik? All right. That's happening in summer of 27. And Sitabai just picks up the phone and says, "Mujhe Kumbh Mela jana hai, main kya karu?" And what happens is her own agent, which is trained on her own data, which could be just a couple of megabytes of data, her health, her wishes, her previous travel, and so on, starts negotiating in an overall internet of AI agents, about her travel, maybe she's pre-diabetic, her homestay, what kind of food she can get, vegetarian food she can get, and so on. And there are also agents on the other side in Nasik, negotiating with her on a continuous basis. The railways are negotiating with her, saying she wants a lower berth, and so on. So you can imagine this internet of AI agents that are going ahead. But the challenge there is that today most of the research in machine learning and AI is, I would call, almost like a personal AI. There's a big model that's trained, and then one can individually interact with it, and the model will give you a reasonable response for that individual. What we are working on at MIT is what we call population models. A quick analogy will be with e-commerce, which is like I live in Cambridge right next to MIT, and I can order an umbrella that's made in Vietnam. It gets delivered to my doorstep for $10. How's that possible? That's because other people in Cambridge around me are also buying junk from Amazon, and I get, the costs get amortized, and I get things for $10. So a population AI, population model would do something similar, where millions, maybe billions of different agents are trying to achieve a particular task, they're training models and so on, but you have to come up with a solution that takes multiple inputs and multiple outputs, right? As opposed to something what we do in today's machine learning, where we have somewhat of a frozen model, and then we try to make it suitable, best in terms of inference for one person. So it's a very important research area of population models that we have to solve. And then your question about 4 years from now is an interesting one, because if you look at the example from the 80s, companies like DEC and Silicon Graphics and Cray and so on disappeared because of their centralization approach. And the PC companies took over and so on. And the risk today is that all these highly centralized companies, unless they shift very quickly, I'm not saying you should short your NVIDIA stock right now, But there could be a time when a whole new range of companies emerge that look very different. So I would say in 4 years from now, we're going to see a whole new ecosystem of players that are completely focused on decentralization of AI services than what we are seeing right now. So, and I'm sure you're feeling a FOMO, those of you who didn't raise your hand about OpenClaw and Malbook and so on, which these things are kind of scary to use because of security constraints and so on. So at MIT and elsewhere, we have a platform for you. Just go to Doot, digidoot.in. You can create your own AI agent in a few minutes, launch it on the web, and experience many of the things we're talking about. So I think a lot of tools for democratization like that will become very commonplace in 4 years.
Okay, so let's switch gears. We have a very diverse audience. I mean, there are people with gray hair, some very highly accomplished, like Turing Award winners, like Yann, and people who have been in the field almost as much as him, like Rao, as well as people like me who are not quite as accomplished. But I see a lot of also students in the audience, a lot of young folks. So I'd like to maybe have some of you share what would be your message to especially the students in the audience. Maybe should I start with you, Jawahar?
Yeah, I think to the students and the audience, particularly for students, my message is you have to be problem solver. You have to understand what are these tools, how to use these tools, and what are the ethics of using these tools. All of them are important, but you have to become the problem solvers and solve problems that really matter to the society. So if you look at where we are today, the AI tools available and what could happen in the next few years. A natural extension is what you see today for the language or the character sequence prediction. The models could touch the real world partly. See, there are a lot of immediate requirements in the society. If you just take this example of helping in education. So we had multiple discussions, comments about education use cases. But remember, education is not at all about watching videos. We somehow have converted education into watching videos. It is a closed loop system. There has to be feedback, there has to be interactions, and remember, beyond this classroom education. So we have killed, if you look at India, we have killed all the engineering disciplines. Only computer science department survives, electrical, mechanical, civil engineering, all the departments are closed. Forget about all the carpentry, plumbing, whatever all required in the society, we don't need it now. We need only Python programmers. That is how we have reached today. So in this system, we need to have solutions that can train people on the fly whenever they need in doing things with hands. They are not sitting in the easy chair and controlling only remote. So we have to have solutions of that sort, and that is quite possible today with where the LLMs are today and with the rest of the embodied AI and the rest with the keywords that you hear in all these aspects. It's quite possible we can have working solutions that can help in the bottom of the pyramid, in education, creating livelihood, etc. in India. And this opportunity we should grab with both hands.
Thanks, Jawahar. Let me turn to Surya. Your message to the students, especially in the audience?
Yeah, it's an interesting question. I mean, I would say that despite the proliferation of AI tools, you still need to learn how to think on your own, right? And also to be able to write on your own and so forth, right? So don't be, of course, learn how to use the AI tools. They'll make you more productive. But hold off for a second when you're in your learning phase and just really, really learn. Like, for example, arithmetic, we still teach our kids. You know, I'm teaching my 5-year-old daughter arithmetic. I'm not giving her a calculator to do it. Right? She has to do it herself, and it's really important. But then eventually use a calculator. You have to go through that struggle to train your mind how to think. And that's at every stage, I think, like whether it's math for machine learning, whether it's like writing. Like the act of writing is tantamount to the act of thinking. When I'm writing something I care about, like say the introduction to a paper, I absolutely don't consult ChatGPT. I start with a blank page, and I really think about what is it? What is the essence of what I want to communicate to my audience, right? And I start from a blank page, and I do it myself. That really clarifies my own internal thought processes. And we don't want to pollute our thought processes by existing LLMs, I don't think. So I think that's really important. Like, we're still going to have to learn how to think on our own. And if anything, we're going to have to judge the outputs of LLMs at the very least. And that's going to require taste, judgment, thought, critical thinking, and so forth. So I feel strongly enough about this that at Stanford we're trying to figure out how to train people in the age of AI. We notice that students just hand us homework done by ChatGPT and so forth. I would actually advocate like for critical thinking classes like math and writing and so forth. We go to closed book exams, paper and pencil. Right? I think that's the right way to do it. And homework counts for nothing anymore. It doesn't matter. I don't care what you turn in for homework. But you better be able to do well in the closed book exam. That's what I would advocate. To ensure that you actually, not because we want to punish young kids, just to emphasize how important it is to think on your own.
Thanks, Surya. Rao?
Okay, so I guess as the global South Indian, I get the last word. You still there? Okay. So I would say, I'm actually most interested in the student researchers. I mean, the students are lots and lots of big, diverse population. I'm particularly interested in student AI researchers because you're really our hope for the, as to where this goes. In general, I would definitely urge you to be skeptical. Skepticism is the weak inductive bias for good science. And you really need to be, especially in this day and age, where most of the technology is being developed behind closed doors, and there's no open science. We are essentially being told these newspaper things that our model is doing this much better based on this particular type of benchmark things. And Sarah and her team, for example, did a great job pointing out how some of that, the benchmark studies can be, questionable. In general, we should be very impressed that you are alive at this time when we have figured out how to use the collective human knowledge, including the procedural knowledge, to train models that will act as sort of fallible front ends to the entire humanities knowledge. And you have it and you can talk to it. You shouldn't trust it completely, but it's a very useful thing. None of us had, and you are the first generation to have it. But having said that, you have to understand that we are training these things in probably extremely inefficient ways. We will probably look back and see these as Rube Goldberg intelligent machines, for those of you who know Rube Goldberg contraptions, and that we should be able to do this with much better sample complexity. That's what, for example, Surya was talking about the human intelligence. And the other thing that you want to remember is these models essentially don't have their own experiences. They are thinking about the world in terms of what your digital footprints are. And so they will most likely stay within the humanities knowledge closure. And if you really want to go beyond that, you will look at other kinds of solutions too. And this is important because at no time in my 40-year career have I seen a monoculture in AI research that is as crazily concentrated as it is. Yoshua said, compared to this auditorium, the whole companies are all working in this. I think he was overstating it. It's actually much less than the entire glass, honestly. And everybody is essentially trying to do some of the same things because of huge commercial incentives. This is great for your job prospects, but you should still keep in mind what are you going to do about the next generation of systems which will not have the kind of issues that the current ones have, including the long-range planning, including the guarantees of their reasoning. And if you don't have reasoning guarantees and you have agentic systems trying to work in the world, they can lead to large amounts of failures. And nobody is talking about this right now because many of your benchmarks are carefully generated, such as including Tau bench, such that there are no interactions between the actions and nothing bad can happen. That's not the way the real world is. And so you need to be looking at types of things, and then hopefully you would keep this as, don't think of this as a religion that you need to become a part of. This is a science where the entry fee is to be skeptical and tell me exactly why I should believe this, and you should do your own work. Thank you.
Thanks, Ram. Sarah?
Yeah, I don't think I'll make this, I'm sure for researchers or students, I won't make this specific to AI. Maybe I'll just give my 2 cents about what is interesting about life. I think that first thing I'll say is I think you probably have time in your lifespan to work on 4, maybe if you're lucky, 5 problems in a serious way. And so you should choose those carefully. The problem matters. I don't think the tools matter as much. I mean, I think most of the tools that we probably studied, I'm guessing most people on the stage have PhDs in computer science or adjacent, but most of that is now redundant. The first thing that we did was teach models how to be good at that. But that doesn't matter as much because I think the ability to seek problems is what is important. The second thing I'll say is I very much agree. You have to commit to a craft. The act of putting in hours is incredibly important. The discipline of committing to a craft is incredibly important. It's not as fun to talk about, but I think most people who are very good at what they do in the pursuit of what they want, there is a pursuit of excellence. I would say the third thing is work with people who are far better than you. It's the biggest catalyst. And then don't choose brand names. I think that too many people make that mistake. You want to work on a large problem. And sometimes when you choose a brand name, you work on a tiny problem at a fancy place. And that's probably the worst ingredient for what you want to do in the long term. And then the last thing I'll say is the world is smaller than you think. Be careful and be kind to people. But my first director told me that. He was Korean. He opened a door for me, and he was very, he told me 2 things. He's like, people remember how you begin and how you leave. And he also said, you will see the same people throughout your career, if you're good. Because if you're good and the other people are good, you just see each other over and over in different ways. And how you treat people matters, because those are the same people who will take care of you at different stages of your career. And that's stayed with me ever since. And so I always say, start with intent, end with care, and make sure that you're looking out for people around you. Because if you care about problems, typically you also end up caring deeply about those you work with. So, thank you.
Okay, so now I'm going to put people in the elevator, the remaining speakers. So Sarah, 2 minutes. You're in an elevator with the students. What's your message?
All right, so I would say, well, just like what Sarah said, make friends, but like human friends, not just human friends. But because we can learn so much from friends. So we're different from LLMs because we learn from interacting with other humans. But I think what makes that learning possible is your imagination, right? So when he says something to me, I don't just take that literally. I understand the literal meaning, but then I add to it with my imagination. And that leads to arguments, but that also leads to empathy, that leads to friendship and love and so on. And that's what makes you unique.
Thank you. And for the final word, we have to go to Ramesh for the final word on the message to students.
Surya, first of all, I used to have closed book exams, and students get stressed, so I started making the open book exams maybe 10 years ago. But more recently, they are open internet exams. You can have a computer and use the internet. And now my students are asking, can they be open LLM as well? Can they use? So I'll see how far I go. But it only makes my job as a professor more difficult because I have to set exams that cannot be solved with whatever they can access on the internet and LLMs. So far, I've been doing pretty well. But let's see how much work I can put in to make my exams not solvable by what's available. I would say very briefly that, I mentioned about Ilya and Dwarkesh Patel's, how many people watched Dwarkesh Patel, by the way? Fantastic. I think it's a must for every researcher. Because not only he brings in great speakers, but he also challenges them to think about new types of research problems. And again, Ilya's podcast, Ilya was talking about, it's not about learning, it's about learning about learning. I'll make it, may say that doing research today, it's about learning about learning about learning. Because now machines are going to be about learning, but we have to figure out how to learn about that. So, I know it sounds kind of convoluted, but that's where we are at. And becoming very familiar with these tools is critical. There is no excuse to not be a programmer today and build systems. So everybody has to be a builder. Doesn't matter what your background is. So go build an app, go build a website, launch a solution. There is no excuse not to do that. And only by doing that, I know you will learn. Thank you.
Okay. I'm reminded of that dialogue in Sholay from those of you who are from India, that Basanti, when she talks about how UK, basically the time just flew past. We had 85 minutes in this post-lunch panel, but it's been a fascinating discussion. Again, I'd like to thank all of my fellow panelists for sharing all of their pearls of wisdom, amazing insights, and I think it's going to be a very, very exciting world unfolding before us. And thank you all to all of the audience for being a wonderful audience. And let's now move to the next part of the program. Thank you all.
Thank you. I would request all the people in the audience to please keep seated. आप लोग अपनी सीटों पे बैठे रहिए अभी, please नहीं, अभी उठना नहीं, please. I would request the delegates to go from that side. Yeah, please go from, if you could leave from the left side of the stage. And if you are leaving the room, please go up and leave from the back, unless you want to get mobbed. I would request everybody in the audience to keep sitting. Please do not move from your seats. And if you want to leave the room, please leave from the back of the thing, not from the front. Please do not come to the front of the hall. Just stay where you are or leave from the back door. Please do not come to the front of the hall. Please आप लोग हॉल के आगे वाले हिस्से में मत आइए. अगर आपको हॉल से निकलना है तो पीछे वाले दरवाजे को यूज कीजिए. और अगर आपने बाहर नहीं निकलना है तो प्लीज अपनी सीट पे बैठे रहिए. No one will go. For what? You can do. You know what happened today? कोई नहीं हिलेगा यहाँ. नहीं निकलेंगे. नहीं निकलेंगे नहीं. बहुत लोग हैं. कोई नहीं निकलेगा. People who want to leave the hall, please leave from the back of the hall. There's a door at the back of the hall. अगर आपको हॉल से बाहर जाना है तो प्लीज पीछे वाला दरवाजा यूज कीजिए. नहीं अभी तो मेरे को बोला सबको जाने दो वहां से. अभी तो बोला. हाँ अभी तो आके मुझे स्पेसिफिकली बोला कि पीछे से भेजो. If you're not leaving the room, please be seated in your place. Do not move. अगर आप हॉल छोड़ के नहीं जा रहे हैं तो प्लीज अपनी सीट पे बैठे रहिए. और आगे की तरफ हॉल के मत आइए. Please do not come towards the front of the hall. Please be where you are. We have huge crowds at the door, so we're trying to make sure that everybody moves smoothly. There.
Okay. We would request everyone who wants to leave the hall to please leave the hall from the back of the hall. There's a back door there. Otherwise, I would request everybody to settle down for the next session. Please be seated for the next session.
हाँ मेरे साथ इनको बोलो कितने लोग हैं मेरे लिए एक जगह नहीं तो
All right, so before we move to the next session, let's give a big round of applause to our previous panelists. Along with discussing the points, they had a big challenge of keeping everybody awake after a big lunch, right? So we move on to our next session. As we know, this is a keynote speech. Can I have the slides, please? The moderator for this session will be Dr. Venkat Padmanabhan. I'm sure everybody knows him, but just to give a very brief introduction, he's the managing director of Microsoft Research India, which is one of the most sought after labs for researchers in the country. So Dr. Venkat, I would also request you to please introduce our keynote speaker and invite him to the stage.
Thank you, Richa. Good afternoon. We keep the best for the last. So this is the last item of the agenda, and it's a distinct honor to introduce Professor Yann LeCun, who doesn't really need an introduction, but let me just briefly talk about Yann. He's a professor at the Keynote Institute at NYU, Turing Award winner. Till recently, he was chief scientist at Meta, and recently he has started his own company called AMI, Advanced Machine Intelligence, and a pioneer in this idea of world models that he'll talk about. In his long career, he spent some time at Bell Labs Homedel, which is where he invented convolutional neural networks. And I thought I'd call that out because I realized recently that I was at that place when he did this pioneering work. I didn't know him then, but it is a real honor to be introducing him here. Yann.
Thank you very much. Pleasure to be here. I seem to be coming to India pretty regularly nowadays. Okay, I'm going to tell you about something that is not at all becoming a buzzword in AI, world models. And many different people have different meanings for world models. I have my own definition, and I'll try to explain what it is and why I'm thinking this way. Okay, so first of all, we need AI systems if you want them to understand the real world and approach human intelligence, not just when it comes to language or coding or mathematics, but for everything in the world. We need systems that really understand the world at an intuitive level, a little bit like babies learn how the world works. We need systems that have persistent memory, systems that can plan complex action sequences so as to fulfill an objective, systems that can reason, and systems that are controllable and safe. And those are characteristics that we do not observe with current approaches, namely LLMs. And in fact, the way you can convince yourself of this is that we have systems that can pass the bar exam, win math Olympiads, and do all kinds of amazing feats, but we still don't have a robot that can do what a cat can do. Okay, and so we're not talking about like super high-level reasoning here. We're talking about just basic understanding of the physical world and then translating this into control abilities. And we don't even have, robots certainly that can drive completely autonomously yet. We're getting close, but we're getting close by cheating, and we're only getting close despite the fact that we have millions of hours of training data of people driving cars, and we train systems by imitation learning, and still we don't get anywhere close to human performance. Whereas a 17-year-old can learn to drive in about 20 hours of practice. Maybe in India a little longer. At least it would take me a bit longer. And so, and a task that a 10-year-old can do the first time you ask him or her. We don't have robots that are capable of doing it. Of course, we can train robots on very narrow tasks by collecting lots and lots of data and training the robot to imitate humans. Doesn't quite work for autonomous driving because there's safety issues, but it would work for clearing up the, filling up the dishwasher or something like this. But the point is, we can do this without collecting tons and tons of data. The first time we are facing the situation. So how does that happen? Perhaps there's one reason, which is the fact that if we train systems from text, there is only about 10 to the 14 bytes available in publicly available text on the internet. Whereas 10 to the 14 bytes corresponds to approximately the amount of information getting to the visual cortex in the first 4 years of life, and also corresponds to about 30 minutes of YouTube uploads. So in terms of video information, 10 to the 14 bytes is tiny. In fact, some of the video systems that we've trained have been trained on orders of magnitude bigger than that. So, that indicates that we're not going to be able to reach anywhere close to human intelligence by just training on text. Okay, so now, how are we going to get there? So what I've been arguing for a number of years now, in fact, for the better part of 10 years, but then be getting more precise over the last 3 or 4, is this idea of world model. Okay, so what is a world model? A world model is a predictor, so given an observation of the state of the world, or observations from the world, you get some idea of the current state of the world, at least in the environment that you can perceive. You can combine this with the content of a memory that contains information about the rest of the state of the world that you don't currently perceive. And then your world model, given an imagined action sequence, will predict the resulting state of the world. Okay? That's really what a world model is. State of the world at time t, action or sequence of action that you imagine taking. Can you predict the state of the world at time t plus 1, whatever this plus 1 means? Okay, if you have a system of this type, then you can feed the prediction to an objective function that measures to what extent a task has been accomplished or not. And you can also feed it to a bunch of guardrail objectives that guarantee that whatever sequence of states the world is going to go through is not going to actually hurt people or have deleterious effects. Okay? This is how you would build a safe AI system. And the way such a system will operate is that, given the observation, given those objective functions, the system searches by optimization. It searches for a sequence of actions, an optimal sequence of actions that minimizes those cost functions, objectives, and satisfies the constraints of the guardrail. That's the only way I think, first of all, that you can build a safe system. Yoshua Bengio was talking about earlier about safe systems. I completely disagree with him. He says they should not have any objectives. On the contrary, I think they should have objectives that we give them, and the only thing they can do is fulfill those objectives and nothing else, subject to guardrails. I think this is the only way to build a controllable system. Furthermore, those guardrails objectives are not going to be particularly simple to design. In fact, we're going to have to train those systems. But I can't imagine that we can build agentic systems. Everybody is talking about agentic systems. I do not believe that we can build effective agentic systems without those systems having the ability to predict what the consequences of their actions are going to be. And LLMs just do not. So we need world models. I don't see any other way. You may have some other proposals, but I don't see any alternative at this point. And in fact, so the next question we can ask ourselves is how do we train those world models? So obviously, humans and most animals have world models in our heads that allow us to kind of predict, anticipate the evolution of the world and the consequences of our actions. And we learn, the basic functioning of the world in the first few months of life. So to learn about gravity, it takes about 9 months, roughly. And there are basic concepts, that we learn faster. But we learn mostly by observation, a little bit by interaction, mostly by observation. How do we reproduce this in machine? So a natural idea is to use generative architectures, okay? So basically, let's say you want to train a system to predict what's going to happen in the video. Show it the beginning of the video and ask it to predict the reminder of that video, which is really self-supervised learning of the same type that we use to train LLMs. And I've been trying to get this to work for the last 15 years, more actively over the last 10 years, and basically failing for the first 10 years, and succeeding more over the last 5 years. And what made it more successful over the last 5 years is to completely abandon the idea of generative models. Okay, and so the reason why it's impossible to train a system to do this is because most of the world is completely unpredictable. If you want to train a system to predict at the pixel level, it cannot succeed. It's completely impossible. If I take a video of this room, I start from that side, and I rotate the camera, and I stop here, and I ask the system, can you predict the rest of the video? It's going to predict the camera is going to keep panning, and this is a meeting room, and there's people sitting. There's no way it's going to predict what you look like, what every one of you looks like. That's impossible. The information is just not in the preceding segment of the video. And so when you're training a system to do something that's impossible, it doesn't really work very well. Okay, so generative approaches should be thrown away if what you are interested in is for AI systems to understand the real world. It works for language because language is discrete. It doesn't work for continuous data. What you get is those blurry predictions. And we found some ways to kind of fix this in simple cases. And this is what video generation systems do using generative architectures with latent variables. But in reality, the real solution is somewhere else. It's to basically abandon generative architectures and instead use those joint embedding architectures, or more precisely, joint embedding predictive architectures, represented on the right. And so the difference between the left, which is generative architectures, and the right, joint embedding predictive architecture, is that instead of predicting every detail of the variable to be predicted, which is y in that case, you run y through an encoder, and you only predict the representation of y. So you eliminate from y, or from the representation of y, all the information you simply cannot predict, okay? Making prediction at an abstract representation level. And this is a crucial insight. And so this is the JEPA architecture that some of you may have heard of. Joint embedding predictive architecture. We've had a series of papers on this going back 4 or 5 years. But there are people who've been working on joint embedding architectures, including me, for 30 years or so. And so you train a system to find an abstract representation of the input signal that allows it to make prediction, and from those representations will be eliminated all the stuff that you simply cannot predict. And you can use this as the basis of a WAD model, which is a version of this that is action conditioned. Okay, so if you have a segment of video frames observing, for example, a robot doing something, and an action that has been sent to the robot, you observe the resulting state of the robot, and you can train your WAD model that is action conditioned. Once you have such a WAD model, you can feed it to a system that can plan, so of the architecture that I showed earlier, and basically plan a sequence of actions. I've explained a lot of this in a paper I put online 4 years ago, and there is various longer versions of this talk, more technical ones. You see the QR code at the bottom. And a number of recent papers on progress along those lines. And what we're building, particularly in the new company I'm setting up called Advanced Machine Intelligence, AMI. Okay, AMI means friend in French, and it's a French company, so it's consistent. It's the idea of kind of building an overall intelligence system based around this idea of WAD model, planning, objective functions, etc. So there's various ways to train those JEPA architectures, and the main issue is to prevent them from collapsing. And there is a method that works really well based on distillation. We don't completely understand the theory behind it. In fact, one of the few papers that tries to analyze this by Yann et al. Actually, a co-author is Surya Ganguly, who was just on the previous panel. But there are issues with it. It works really well And some of my former colleagues at Meta produced the system Dino V3, which is probably the best sort of general or generic kind of image representation system there is out there. You can use for all kinds of applications. And it gets better performance than purely supervised system. And in fact, we've used this Dino encoder to train a predictor on top of it, which we can use for planning and have it solve simple control tasks. So here is a simulated robot, and you have kind of a starting point at the left, and then at the top, target configurations. And what you see at the bottom is the sequence of actions planned by this Dino world model system to bring the configuration of the environment as close as possible to the goal at the top. This has been applied to a number of different tasks in sort of simple simulated robots, and we're making fast progress along those lines. And somehow I can't switch to the next slide until the video is gone. Okay, here we go. Hopefully, here we go. All right. But more recently, we trained sort of fairly large-scale video systems based on this distillation architecture. And you see some of the recent papers here and demo websites and various things. So this is the VJEPA system. So again, it's a JEPA architecture. It's trained to fill in the blanks in video at the representation level. And this system is the first one that we've been able to show that it has learned some level of common sense about the world. So it's able to kind of tell you if something impossible occurs in a video. So if there is a video where a ball is being thrown in the air and all of a sudden the ball disappears or stops in the middle of the trajectory, the prediction error inside of that model shoots up because the system tells you, like, okay, something impossible just occurred. And we've trained the system to plan trajectories for robots, for real robots. And it can do kind of relatively simple tasks at the moment. And again, we're making fast progress there. And hopefully kind of get to systems that can do actual complex tasks. So I told you about examples in video. The whole approach, in fact, is designed to work for more than just video, and to be applicable to any sensor signal, any high-dimensional, continuous, noisy sensor signal, which is the kind of domains where LLMs are completely helpless, and we beat records and everything. Let me switch to the end. We have a bunch of work on sort of different, another set of methods that I'm very hopeful will actually lead us to a lot of progress. You see some of the references here. For those papers, these are based on maximizing the information content of what comes out of the encoder. But I'm going to conclude so that we can have questions. So I'm basically recommending to abandon generative models in favor of those joint embedding predictive architecture. You can imagine that this statement does not make me popular in Silicon Valley. Abandoned probabilistic model, I've been sort of arguing for a particular framework to understand all of this called energy-based model, which I didn't have time to talk about today. There is various ways to train those JEPAs using contrastive method. Even though I contributed to inventing them, I'm very skeptical about them now. So those information maximization method is really what I'm betting on. And of course, I've been saying for 10 years, abandon reinforcement learning because it's so inefficient. So this is if you are interested in human-level AI or something like that, or at least AI for the real world. And hopefully, the company I'm building, AMI Labs, which is really AI for the real world, has the goal or the purpose of using hierarchical JEPA to build universal action condition causal models for complex system control, and using them for reasoning and planning. Thank you very much.
Thank you, Yann, for those very interesting thoughts and, I would say, contrarian view. It's good to sort of end the day with something that hopefully will generate some controversy and questions. So before we get into AI and, talk about some of the things you mentioned, I want to, we have a room full of people here, humans. And I know that you have said that you don't like the term AGI or general intelligence because you think humans don't have general intelligence. So could you maybe elaborate on that? Because all of us like to feel that we are generally intelligent.
Yeah, we like to think that we have general intelligence. I had this online argument with Demis, Hassabis actually about this. Yeah, I'm sorry to say that, but we don't have general intelligence at all. In fact, we're extremely specialized, perhaps in ways that we don't realize are important, because all of the problems that we can apprehend, that we can imagine an intelligence system kind of being able to apprehend, are things that precisely we can imagine apprehending ourselves. And so we think we are general, but it's just because we have an extremely limited notion of what type of problem we can apprehend. And if anything, computer science has shown us over the last few decades that humans totally suck at a lot of things that computers are so much better than we are, right? So anything that involves search to a graph, right? Whether it's your GPS planning a route, or whether it's searching through the the tree of possible moves for chess or Go or poker. We're really bad at this. I mean, machines are much better than we are, right? It took us a while to get there, but eventually we did. And then let's not even talk about solving equations and stuff like that.
Got it. I guess part of it is we are maybe slow at certain things, but isn't it the case that humans are able to learn things that they don't know? Like if they have given a new problem, they're able to think through it and figure out a way of doing it. Maybe they're slow, but isn't that generality?
Right. So that was kind of the point that Rao actually made on the panel just before. Having tests like the humanities last exam, it's complete nonsense to measure, like to check whether a machine is as smart as humans, because humans have, as I pointed out in my talk, have an ability to learn new tasks extremely quickly. We can only learn a limited amount of tasks, but because it takes a while to learn a new task. And so, all of us are experts at different things here because we've been exposed to sort of different things and we're interested in different things. And this is, why society can make progress, because we're all different, right? That's it thrives on diversity. But the reason for this is that we cannot possibly learn everything. And that's another evidence that we are very specialized, because we have limited time to learn things, and so we can only learn a limited number of things. And so the ability to, intelligence is not a collection of skills, or at least it's not just a collection of skills. It's certainly not an accumulation of knowledge, which is basically what LLMs are. Okay, LLMs are not particularly smart, except in a small number of domains where manipulating the language actually is the support of reasoning, so that includes code and mathematics, maybe law. But they're not very smart. But what they can do is accumulate a huge amount of knowledge, right? That has been digested, if you want, by humans before they're fed to them. But what about understanding? What allows us to learn to drive a car in a few hours of practice, or solve new problems zero shot in a situation we never faced, is this ability to use our mental world model to basically apprehend new situations extremely quickly and solve that problem zero shot without being trained to do it, or training ourselves extremely quickly to be able to do it. Okay, that's the adaptability ability. I think that is a characteristic of true intelligence.
Got it. So you're obviously one of the pioneers of let's call it machine intelligence or AI. And there's a room full of people here, many of whom are interested in this field. What should be the goal of machine intelligence in your view? Is it to sort of mimic human intelligence, do something complementary, go beyond?
So all of the above. The short answer is amplify human intelligence, or amplified intelligence, okay, which today is mostly human intelligence. Because intelligence is the commodity that is most in demand in the world today. If you think about, everything about, economics, politics, and everything, what we're missing the most is intelligence. When you see politicians making stupid decisions, it's because is because their perception of the world is wrong. They get the wrong data, or they ignore the data you should not be ignoring, first of all. Second of all, their mental model of the world is wrong. They think, for example, by establishing 50% tariffs, somehow, you know, they're going to... you know, they're going to repatriate manufacturing, and obviously it's not working, okay? It means, you know, the world model is wrong, right? Then there's another way you can be wrong, is that your objective function can be wrong. If your objective function, instead of, you know, improving the wealth of your country or the world as a whole, is to improve your own wealth, then again, you know, you're going to not get the result that you might expect. And then the fourth time you can be stupid or evil or ineffective is not having the ability to find a good course of action. Even if your world model and your objective and your perception are right, you may not be able to find a good course of action to fulfill that goal. I actually wrote a small piece on it. If you go to my website, yann.lecun.com, there's a little pamphlet about this if you're interested.
Good. I'm glad you didn't say any of these things in the morning, because we had some politicians in the front row. So I know you'd leave the country, I'd be in trouble here. So
anyone from the Trump administration?
Okay, so now let's switch to you know, LLMs, your favorite topic, I guess, and you know, and then we'll get to robotics. You know, at an intuitive level, what you say makes a lot of sense, right? You know, this next token prediction thing is not really you know, what's going to get us to, you know, a generalized form of intelligence. But isn't it the case that if this LLM black box is able to produce the right answer in, you know, millions of cases, it must be learning some internal representation that is perhaps a version of the world model you're talking about, right? Because otherwise it just seems by fluke it cannot produce the right answer time and again.
Well, I mean, the GPT architecture, right, is the biggest ones. They have many blocks, you know, transformer blocks or whatever, layers, right, whatever you want to call them. And so there is, you know, some degree of reasoning just in the propagation of signals within those blocks. But it's limited because the number of blocks is finite. I mean, it's fixed. And so the amount of computation that will go into the computation of a single token from the context is fixed, which means if I ask the system, is it the case that 2 + 2 = 4, yes or no? The system, of course, will answer yes. And if I asked, you know, and we'll do a single propagation to that thing, right? If I ask, is it the case that P = NP, okay, computer scientists in the room know what I mean, it's going to spend the exact same amount of computation on this than answering whether 2 + 2 = 4. And that doesn't make any sense, right? You need a process by which the system can spend more effort thinking about more complex questions than about simple ones. So the trick that LLMs, you know, LLM people have been using is chain of thoughts, right? You train the system to produce more tokens than it really needs, so that it artificially kind of, you know, spends more computation. But the amount of information that is carried between one step of the reasoning and another one is just a 3-byte token. And that's ridiculous. That's not the way we think. We think in terms of mental models, right? Which have nothing to do with language. Most of what we do has absolutely nothing to do with language. It has to do with our, you know, representation, intuitive representation of the world. If I tell you, imagine a cube floating in the air in front of us here. Now, rotate that cube by 90 degrees around a vertical axis. I mean, you can readily imagine this, and you know that the cube looks exactly the same as when you got started, because you know what a cube looks like, and it's got a 90-degree symmetry. This has nothing to do with language. Okay, it's mental imagery or whatever. Most of the thinking that we do is of this type. It's only when we write code or when we do mathematics that we actually manipulate symbols, and that it helps with the reasoning. But that's very specific, and it only concerns a few % of the population.
Got it. So, I want to sort of, double-click on both language, and then you talked about using video as a modality to learn from. Now, I guess one view is that language does encode a lot of, let's call it sort of world model rules. Like, when I write a sentence, for it to make sense to humans, it has to correspond to reality. I can't say, oh, I dropped this bottle and it sort of went up, right? That won't happen. So that is on the language side. So it does capture information, beyond just the language aspect. On the video side, yes, there's a lot of data, but is it the volume of data that matters, or the number of interactions and the sort of the variety that really matters, right? Because
yeah, I mean, a lot of it is the bandwidth of the data, and which means in how much quantity is it available, but also the redundancy in it. So when I talk about this example, 10 to the 14 bytes, which is the totality of all the publicly available text, and it's actually what a 4-year-old sees during his or her life, 16,000 hours of wake time. People tell me, okay, but video is much more redundant. And I say, yeah, and that's exactly what you want. Self-supervised learning only works if the data you train it on is redundant. If you train a system on completely random data, it can't learn anything. It learns, it builds on the redundancy, and it discovers the underlying structure and redundancy in the world this way. And in text, there is just, first of all, not a huge amount of redundancy and not much bandwidth and a limited amount of it. And we've already exhausted it pretty much. The only way people are making progress nowadays with LLM is through either fine-tuning or training on synthetic data.
Got it. I was just informed that the Prime Minister's security team is waiting outside, so we have to wrap up with, so let me ask you two more questions. Let's go to robotics, right? So earlier today, I happened to spend a couple hours with Bill Gates, who had just spent some time in China, and then he came here, and I told him I'm going to chat with you on stage, and he made the point that he back in the day he thought robotics would be solved before writing essays, but the reverse has happened. But his reason is that it's the hardware, the robotic hardware, that has been too limited, right? The human hand has got some 27 degrees of freedom, it seems, and hardware is not there. So how much of the relative lack of progress in robotics is because we've been working with hardware that is very limited, as opposed to the fundamental model and the algorithms and so on?
Okay, there's several issues with hardware. So in the past, up until a few years ago, the case could have been made that the mechanics, the electromechanics and low-level control in robotics was not up to snuff with biology. I think that's not the case anymore. I mean, you see those robots doing somersaults and kung fu and whatever. Now you have to realize all of this is pre-planned, right? So there's no real sort of adaptability, understanding of the world or anything. It's all pre-planned with kind of a precise dynamical model written by hand. It's a bunch of equations. So there is a world model. It's just a question. I think it's largely solved, except it's not as efficient as biology. Like, those humanoid robots run down the battery in like an hour or two. And obviously we have more autonomy than that. So that's one question. What's not solved is sensing. So we cannot, as humans, we cannot survive without touch. We can survive without sight and audition, but not without touch. And touch is absolutely crucial. And if you numb your hand and you're asked to grab an object, you can't do it. It's very, very difficult without sensations. And so the hardware issue of touch sensing is not solved. But we could have robots that are as agile mechanically as a cat. It's not an issue anymore. We just can't make them smart enough to do what a cat can do. And in fact, there's a bolder statement there, which is that we have all of those companies building humanoid robots, and absolutely none of those companies has any idea how to make those robots smart enough to be useful, except in very narrow tasks for which it's economically feasible to collect lots and lots and lots of data and training those robots by behavior cloning, essentially.
Okay, last question, and let's make it quick. So you've just started a company. Now, the world is swimming in capital investment in the LLM side of the world, right? I mean, your former employer, my employer, and a couple of others have probably spent more than the GDP of most countries, right, in the past year. So what would it take for that to change? So you're betting on a different way of building intelligence. Is it that you will show some step function improvement in capability, reduction in cost? improvement in safety? Like what would, because otherwise the world will just go on the current train, right?
Yeah, so the old story was if you're a Sam Altman or whatever, you convince your investors by claiming you're going to reach AGI just around the corner. I'm not, okay, first of all, I don't believe in the G in AGI, first of all, okay? Human level AI is an attainable goal, and there is no question that at some point in the future, not next year, we'll have systems that are as smart as humans in all domains where humans are smart. This is going to take a while. But what I tell them is that, we've seen in the recent decade and a half, we've seen two AI revolution, the deep learning revolution and the LLM revolution, which is building on top of deep learning revolution. There's going to be a third one. And the third one is, AI for the real world, sensory data, video, AI that can reason and plan, which, Rahul Kambhampati was talking about, and Surya Ganguly as well. And so that's the next revolution. That's what I want to build. That's what I'm building. And I'm, apparently being able to convince sufficiently many investors for that.
Thank you, Yann. Wonderful.
Thank you so much.
Thank you, everybody. This has been a great session. Thank you. Thank you. Oh, they shut the mic off. Thank you, everybody. It was a great symposium. Thank you for being such a patient audience.
And let me also take this opportunity to thank the India AI team. Abhishek ji is here, Kavita ji, Richa, Sanjana, Amoha, and Mayank, along with Professor PJN and Kalika. Thank you, everyone. Thank you to all the PC members for putting up such a wonderful program. Thank you. Anyone who